in global supply chains. This is Bharat, building the next semiconductor powerhouse. Jai Hind.
Welcome back, ladies and gentlemen. Good morning to all of you, and warm welcome. Well, the last couple of days, we were, in fact, critical aspects pertaining to the semiconductor manufacturing and the steps needed to ensure development of robust, resilient, and sustainable semiconductor ecosystem. A lot of discussions did take place, and through these discussions, ladies and gentlemen, you would agree with me that there has been a remarkable strides which has been made since the inception of its one-of-its-kind SEMICON program. Probably it's a pioneering effort on part of Government of India that the SEMICON program has laid a very strong foundation for the growth and development of the semiconductor. Welcome to all of you. Let's give a round of applause for SEMICON 2025 because we have all congregated here in large numbers to ensure that India will be a great force in semiconductor. Yes, today's session we are indeed honored to be taking off with design, EDA design, product creation, and startup ecosystem development. And this session also will offer us great insights into India's growing design capabilities and so on. With us today, we have Mr. Jyotis Indirabhai, the CEO of Netra Semi, already set here to take off. Please come, sir. He has more than 3 decades of experience in chip design, and before Netra Semi, he worked as design manager and micro-architect at Intel Corporation. So all in all, he has 9 patent grants and several pending patent applications in the domains, and still we don't want to clap. He's had 9 patents. Yeah, why I ask this question is I want all of you to be proactive throughout the day, just you have been in the last 2 days. It's over to you, Mr. Jyotis Indirabhai. It's all yours.
Good morning, everyone. Thank you for the introduction, and thank you for having me here. It's a great honor. So let me give a brief introduction about myself and my company. I'm Jyotis Indirabhai. I'm the CEO and co-founder of Netra Semi. It's a company building semiconductor chips. This is a fabulous semiconductor chip company building chips for edge AI market. That means enabling AI and computer vision on small devices and on-premise computing without the need to send data to the cloud and servers. So SEMICON India has a great impact to our startup. We started in 2020, and in 2023, mid of 2023, in SEMICON India Future Design event in IIT Delhi, we got an award from then IT Minister Rajiv Chandrasekhar ji. This was a Future Design Startup Award. Along with that, we were awarded a DLI Startup Award. So this was a huge impact for us, and we are standing here after 2 years, closely after 2 years. So a lot of milestones happened for us in between. We are in the tape-out stage of one of the most complex chip, probably it's actually an edge AI chip with a significant amount of performance and features targeted for video analytics market. And there is one more chip going to get taped out by December this year. This is also an AI chip with the microcontroller features. And also, most importantly, we also raised 107 crores, that is around 12.5 million USD funding, Series A funding, just closed last month. So these milestones would not have been possible without the support and the policy of the Indian government and the SEMICON India award we received in 2023. So coming to the policy aspect, what we are seeing here in India is a completely new kind of emphasis on deep tech and semiconductors especially. What we are seeing is actually a government with the continuous comprehensive and innovative policy for semiconductors. Why I am saying this? Why it is innovative? What is happening is, see, I have worked for multiple geos. I worked in US, Japan, and also travel around the world. I've never seen a kind of support scheme like this, a DLI or C2S. So these kind of schemes I've never seen. I work for startups in US, in Bay Area. But I have never seen, there's a great ecosystem existing there, but government side, I have never seen such kind of policies or even promotions available for startups. Same here in Taiwan or even Japan. Semiconductor companies or even any deep tech companies are not supported like this manner, right? And that's why I'm saying this is an extremely innovative policy from the government side. And secondly, it is comprehensive, right? They are not just throwing some promotion schemes. Okay, you take this DLI to get 50% discount, like refund. No, that is not how the government is moving. They are creating EDA tool infrastructure, chip-in, one of the biggest effort in the semiconductor sector around the world. Huge number of EDA tools are procured and made it available for startups, student community, colleges, academia. So all are getting opportunity to get access to multi-crore worth of EDA tools. And this is unheard of. And secondly, on the support side, of course, startups need to contribute to. They have to take care of more than 50% of their contribution to these programs. But still, 50% refund when you go for a tape-out, it's not a simple thing. And also, most importantly, you are getting exposure. Look at NetResmi, we are here, right? We are getting exposed to the expos here, stalls here. And also, we are getting opportunity to talk to OEMs, right? Indian market is accessible to us through various government initiatives. So that's why I'm saying it is a comprehensive policy, right? And here is a government having both innovative and comprehensive policy for startups. And thirdly, it is continuous. When we received it in 2023, we thought that, okay, when the new government comes, it will go away, right? But it is still staying, and it is going in a much better manner, and there is going to be a DLA 2.0 with much more benefits waited for the startups, right? So it is a continuous policy. So it is innovative, comprehensive, and continuous policy placed there for the startups and the semiconductor companies in India, right? So this is the best time. And most importantly, there is a PM who is talking Moore's law, right? Have you heard anywhere in the world a PM talking Moore's law in front of an event like SEMICON? I had a great opportunity to interact with him yesterday morning. And I mean, the conversation we had is extremely technical, right? And so this shows the vision of the government, vision of the leaders of the government, right? And that's not a simple thing. There is a government who is supporting semiconductor as a domain with innovative, comprehensive, and continuous policy. And they are counting on this community, the semiconductor community, to deliver for India, right? This is a great call. So this is a great call each one of us should take and deliver for the nation, right? Each one of us has an element of patriotism in us, but I am not going that far. I'm saying that this is a great opportunity. India-like country is a huge market out there, huge talent out there. 20% of the world's semiconductor talent is here, and very less entry barrier kept there for the government, by the government, with the form of EDA tools, DLA schemes, etc. And if you cannot deliver at this point of time, I'm saying we will never be able to do that. And this is the time when we should really work towards that. Coming back to the reason why I'm here, let me give a small overview or a description of our journey as NetResmi. So we are actually started in Trivandrum in 2020. Even though we started in 2020, the effort started a bit 2-3 years ahead. So I came back from US with the vision of starting a startup because I worked for a few years in the startup industry, mainly on the wireless chip domain in San Diego area. So when I came back to India, a lot of friends asked me, why you are going back to India? If you want to start a startup, start in California, right? It's easy because you can find good co-founders and also good investments available there for semiconductor sector. But for me, it was not just, my intention was not to get succeeded in a startup journey. It's not all about success, a purpose also, right? I want to be succeeded in the middle of the people I care, right? That is, you can call it as a homesickness or whatever it is, but I think sometimes the weakness helps you to move forward, right? So that is the first part of getting me come to India and starting this startup. And I got some wonderful co-founders and who were also joining my journey. And I knew that it's going to be a long process, especially since we are talking about last 8 years back. It's not easy to raise funds in India. There are no DLI scheme, no C2S scheme. You just have to find your own ways, right? That's how Netrasemi was started. I picked Trivandrum as a place to be because that's my hometown, of course. Again, the homesickness helps. But most importantly, it's also part of a strategy I have taken. India as a country has talent everywhere, right? If I borrow the statement of our investor, say, Sridhar Vembu sir, if you put a dot in any geo of India and consistently put effort around it, you will see great results, right? It doesn't need to be in Bangalore or Hyderabad or Delhi or, for that matter, any place. Any place you pick, huge amount of talent available, and you can actually invest on people, you'll see results. I believe that story. So when I started it, in fact, that is what my motivation also. And also, of course, there are certain advantages as a tier 2 city like Trivandrum has. ISR are very close. There are a lot of advantages there. But even other places also have similar advantages. We started, and I knew that investment is not going to knock our doors, right? You have to sustain. So sustenance is extremely important for startups. So we took some bootstrap jobs, bootstrap contracts. We created a team. We took some years. And also we took one field which is going to be there forever, which is AI, right? Because see, if you are investing on a high gestation period gain, then you need to have a field identified with a long life. So we took computer vision and AI as a domain to be, and we didn't want to simply create a chip. First of all, we didn't have money to buy all the IPs and all the tools. What we took is a path of IP building, intellectual property building, because even with open source tools, you can build IPs. As long as the design is in your brain, you can always convey it through open source tools. So we started that manner. We created team using bootstrap projects. We trained them. We picked the best students around from the Trivandrum region. We invested on them, and we gave them opportunities. Many of them were actually craving for technical jobs, first generation design jobs, because many of the MNCs offer them 12th generation chip designs, bug fixes, regression runs. What we offer to our engineers is world-class first generation chip design opportunity, which I think many of the students from the nearest colleges took it as a great opportunity. And in fact, that's what I tell all the freshers even today. Go and join startups. Startups have nothing in their hand. They have fresh ideas. You will be given opportunity to design. You should be given opportunity to architect. So these are the opportunities students have, because to me, my learning is, if you don't learn a technology in the first 7 years, you are never going to learn anything, right? So 7 years, I think it's a great opportunity to work for startups. That way you'll be able to work on the great, the first generation designs. So we trained people, but then you have the IPs, you have the team, now what, right? We were educating investors for the first few minutes. Like I was interacting with pitching to the investors. And what I have noticed is they were not, semiconductor awareness is not among the investors early stage, and I'm talking about 5-6 years back. But with a lot of things got changed after we got the DLI award. The DLI got announced, and a lot of interest happened from the investor world. They wanted to learn about semiconductor, the opportunities. They started interacting with us, and what we are seeing is the last 2 years, we were able to raise multiple rounds of investment, and last is the Series A investment I just mentioned. So my point is, after the DLI and the SEMICON kind of initiatives, the Indian scenario is changing. There is a lot of interest among the investors. I'm seeing in the last few days, investors are roaming around looking for good startups to invest on. And so this is the opportunities I ask each and every startup aspirant to capture. And good luck. Thank you very much for having me here. Thank you.
Take it offline, because already we have short behind time. Yeah. Sorry about that. This is the first session, and we can take the question offline because you're already short going back. Don't think otherwise, please, yeah? Thank you, Mr. Jyotis Rabai. I think he has come straight towards you, and you can have a discussion there. We move on to the next keynote. The next keynote will be presented by Mr. Ruchir Dikshit, the Vice President and Country Manager, India of Siemens EDA. He has more than 25 years in semiconductor industry, has executed multiple levels of responsibility in design and development of ASICs, FPGAs, and PCB products. He is the chairperson of ISA Board of Directors and personally driving 2 core interest groups, WISE. WISE means Women in Semiconductor and Electronics, and Startup Mitra, to improve the ecosystem for ESDM startups in India. So put your hands together and let's welcome Mr. Ruchir Dikshit. The next 10 minutes is yours.
Thank you so much. Can you guys hear me in the back? No? Let's try again. Yes? No? Yes. Now yes. But otherwise I'd have to scream really loud. Oh, there's a countdown timer here. I'm 15 minutes into it already. But before I start, the previous speaker, I hope that we hear his story, we heard his story, and take inspiration from his success. So, Indra Chandrabai, thank you. Netra Semi is a big example, and I'm glad that we started today with that talk. Today is all about design. So what I thought I would share my views, Siemens' views on what we believe will drive semiconductors and electronics in the future. We believe there are 3 pillars. Now, in any talk for the last 2 years, if you don't talk AI, the talk does not become legitimate. The person does not become legitimate. So I'm going to quote Jensen. Very recently, just about 3 weeks ago, Jensen said that if there is anything moving today, it will move with AI in the future, which means that there'll be physical AI, a term that we may not have used, that we may not have heard very often. So let's start breaking this physical AI thing down. What is it? It's essentially a mechatronic system. Starts with perception. Think of a car. Best example, an autonomous car. Starts with perception. After the perception, it has to understand what it perceived. Once the understanding comes in, then it has to make a decision. Once it makes a decision, then the most important part comes in, action. Should I continue driving? Should I brake? Should I swerve? Should I change lane right now or not? And then outcome of that decision defines what it does next. That is learning. And that's what a physical AI system will do. So, built on real-world interaction, sensor-driven, action-oriented, and adaptive. So that's the universe. The question is, what enables it? What enables it is software, because software-driven hardware is the future. What will the software run on? It will run on semiconductors. And where do the semiconductors live? They live inside of electronic systems. So that's what we are seeing the world evolve to. That's what you in this room will take the world to. Now, a mention was done earlier, open source EDA tools. Yes, they are very valuable, very useful, But there is a point in time when you want to build a complex system, you may need something a little bit more mature, a little bit more, how should I say, invested in developing technology. So you look at what EDA allows us to do, right? It allows us to do architectural exploration. It allows us to go and design and build IC chips. It also helps us verify them. It allows us to go to manufacturing so that whatever we have designed, we can manufacture. And once we have manufactured it, it allows us to put that into a system, because without the system, the user doesn't get to experience any of the good things that you have developed. So that's the value chain, right? The first two parts, they are about making sure that whatever you build will have a piece of software in time, and that software will design and define what your user can do with it. So that's the first step. The second step is all about IC design manufacturing. A lot of people here are doing it. Logic design, physical implementation, and validation. You do that. Once you've done that, GDS is still just ASCII file. It has to actually go into production. And now we are starting to hear about heterogeneous integration, 3D IC, because that's the next step in what will allow us to solve complex problems. We take that 3D IC or monolithic IC and put it on an electronic system. That's when the world sees your efforts. Without that, the world doesn't get to see your efforts. So this is where we are focusing, is to make sure that whatever you're doing, you can take it to your end customer and provide the experience that you want. And of course, the foundational element that will take us forward is AI across the board. Are some of you making parts that go into these devices, or devices that look like this? Could be a consumer electronics device, could be an industrial device. You could actually be making the factory that makes these things. And that's where IC, electronic system design, becomes the core or the center of the entire digital twin story. It doesn't matter what you're making a product, making an IP, making the factory that makes the product, there is the ability to make a digital twin. But when I talk of AI, right, physical AI is something I mentioned earlier, there are multiple layers to this AI. It's not just one thing. We keep talking about AI here, AI there. So I thought I'll just break this down on what AI could mean for you as a designer. And I will come back to this slide. I'll make a mention of it. But just keep this in mind. AI for design should be a system. It's not just about making faster engines. It's not just about making faster engineers. It's not just about fewer workloads. Of course, that's the bedrock, because if we don't do this, as somebody who enables you to do designs, there is no stake at the table. That's the basic things, right? So we start with that. And that's what we do to get the outcomes, right? Me and other EDA providers are working on making the engines faster, adding AI, ML into the engines, Gen AI capabilities to make your engineers faster, get to the data faster, get the knowledge faster, and then using agentic AI to reduce workloads or move these workloads from human to machine. So that's layer one. And that's what everybody has been talking about so far. And that's just the beginning. That's where we start. That's not where we end. Where we end is this concept. Any knowledge that you have today, it could be user manuals, it could be some things that your peers have done, it could be your own design data. You combine all of that, do you have the ability to use it? It could be from any product, any phase in the design, by anybody else in your company. Can you utilize it? So you take that, build the next layer on top of it. Add your LLM, your choice. You built your own, brilliant. You want to use something else, brilliant, use that. On top of that, add another layer of assistants, of reasoners, and agents who will do actually the work for you. So that's the layer one that I talked about. That sits on top of this foundational element. Now, wouldn't it be nice that every single tool that you were using in your flow, mine or somebody else's, could not only utilize the AI that's built into the tool, but could also learn from every other step that was taken in the design process. So you had all the tools on top of it. Now you have the ability to use all the knowledge from outside, all the knowledge from inside, across the design flow, through the tooling, through the phases, and learn from each other. That's real AI. The question is, how will you use it? You could use it through a web-based interface, you could use it through command line, you could use it through the tool, or you can build your own interfaces. You have a design style in your company, you have a communication style in your company. Use the APIs to access the system outside. That's what our vision is. This is what we provide to you. Your knowledge, your expertise, added and augmented with our knowledge, our expertise, to do things that you want, to get the outcomes you want, the way you want them. That's real AI. Anything less than that is not taking you where you should be. The second pillar, heterogeneous integration, 3D IC. Yes, our Prime Minister did talk of Moore's Law, but we know that Moore's Law is not going to be sufficient. We have to find different techniques, and 3D IC is now one of them. The thing is, when anybody talks of 3D IC, the first thought, and perhaps the only thought that comes to their mind, is multiphysics. Of course, that's a problem, right? There are so many things that we need to take care of. There are physical issues, assembly issues, thermal issues, manufacturability issues, and all of that. But there's something more. When you start thinking of a heterogeneous device, maybe the chiplet was done by you, by a team inside your company. Maybe it was done from outside. I left that intentionally blank because sometimes this is what I draw, which is what I get from the people I talk to. What's other than multiphysics? This is the real picture. When you start to look at things that you need to build with your IP, with your chiplets, with somebody else's IP, with somebody else's chiplets. It's not just about the physics. It's about logic. Will this work? Can I put this together once I manufacture it? If I can I test it? Because if I cannot test it, all the effort that you put in is a waste. So this is what a 3D IC flow should look like, and as a designer, as somebody who's making silicon, with some of these parameters, you should be looking at. And if you're not, I encourage you to take another look. I have about 3 seconds over. I'll take 30 seconds more, promise. Because this is the last thing, software enablement. How many times have you gone into hardware design, have your silicon ready, but your software is 6 months behind? How many times has software held your silicon from being exposed to your customer? It happens all the time. But if we are saying that software is going to define the world going forward, if everything that we build is going to be software driven, we will need to know, before we make silicon, is this software going to work? Is this software that I'm thinking about will get me the function that I want? So you must have the ability to either virtualize the entire system, and we have people who have virtualized the entire car, every single function of the car in a virtual mode, making sure that the parts that they manufacture later, 18 months out, 2 years out, are manufacturable, they are functional, they will work with each other, and all the software that I'm going to put in the car will actually make it. From there, you can come down, all the way down to the prototype level, and that continuum is also important. So, this is where we see the world going. We see the world being driven by AI, for AI. We see the world being three-dimensional, and we see the world being driven by software, and this is where we're investing. Thank you so much for your attention. By the way, this is a very brutal room. It looks so empty, but I know there are more than 150 people here. If we just had one column, this would all be full. So thank you for your attention, and have a good day. All well.
Thank you, Mr. Ruchi Dikshit, and definitely it was a great presentation. And after the two keynote presentations, ladies and gentlemen, we now move on to another important panel discussion on semiconductor startups in India, the challenges, champions, and the road ahead. We have a galaxy of panelists, and this particular session will be moderated by Shri Jaswinder Singh Ahuja, ex-MD of Cadence. Before Mr. Jaswinder comes over, it gives me great pleasure to say a few words about him. He has been a deep tech investor, of course, board advisor and a startup mentor with over 37 years in the semiconductor industry. And most recently, he served as corporate vice president of international headquarters in Ireland and India and managing director at Cadence Design Systems. He has been instrumental, ladies and gentlemen, in building India's semiconductor ecosystem as a founding member and former president of the VLSI Society of India. He's also been the founding member and past chairman of ISA and a key contributor to initiatives like Entrepreneur Park and the India Semiconductor Mission. So please put your hands together and let's welcome Mr. Jaswinder Ahuja onto the stage, please. And very quickly, I would like to call upon the panelists. Mr. Neil Gala, the CTO, co-founder in Core Semiconductors, is the co-founder and CTO there. He's a pioneer in India's RISC-V ecosystem. He co-founded the landmark Shakti processor program at IIT Madras in 2012. He has served on multiple nation and international committees. Hearty welcome to you, Mr. Neil Gala. And after that, Mr. Parag Naik, the co-founder and CEO of Sankhya Labs. He's a seasoned technology serial entrepreneur with over 32 years of industry experience, including more than 21 years in indigenous high technology startups. And of course, he has won several awards. So let's give a round of applause to Mr. Parag Naik, the co-founder and CEO of Sankhya Labs. We will also be having Mr. Jitendra Chadda, the Managing Director and Country Head, GF India, Vice President, GFES Fab Operations. He's a thought leader with 2 decades of experience in executive roles across multiple geos, US, India, Mexico, and Canada. Hi, how are you? And under his leadership, GF India's team has grown rapidly, evolving GF India into a microcosm of GF. So very hearty welcome to you, Mr. Jitendra Chadda. We also will be having Mr. Sridharan Mani, CEO of Ahisa Digital Innovations, and more than 3 decades of senior leadership experience in IT product innovation and business expansion. And post AMI at Amazon, he led a team to build Amazon Academy and EdTech platform for IIT, JEE, and NEET platforms. Hari, welcome to you. Namaskar, Sridharan Maniji. And finally, Dr. Kamaljeet Singh, Director General, Semiconductor Laboratory. He worked in ISRO as RF designer and subsequently became Group Director of Hybrid Micro Devices, has published more than 200 technical articles in various journals and conferences, has written 6 technical books. Hearty welcome to you, but I can hear the clapping only from the left-hand side. No clapping from the right-hand side. Okay. So with that, I would straight away hand over the session to Mr. Jaswinder. So over to you, sir.
Thank you. Good morning. Okay, we are set for a very exciting panel here. The last couple of days, there's been a lot of focus on the manufacturing ecosystem. But let's not forget the fact that at the end of the day, we've got to fill up those fabs with some designs. And so today we're going to talk about the fabless ecosystem. And we have a wonderful panel here today. We've got Neil and Sridharan, who represent 2 relatively new fabless semiconductor startups, both of whom have been selected as part of the DLI initiative. And I believe, Neil, your startup was incubated at IIT Chennai, Pioneer. And then we have Parag, who is a veteran entrepreneur, one of the very early startups in the fabless ecosystem in India, Sankhya Labs, which subsequently got acquired by Tejas Networks, and he's now part of Tejas Networks in the Tata Group. So he's a battle-scarred veteran of the industry, and we'll get to learn from his experiences and perspectives in building up Sankhya Labs. We have JC, as we affectionately call him, who is another industry veteran. He was part of Intel in the past, where he was also, during that period as the chairman of ISA, he was leading a lot of the industry initiatives at Intel in developing the ecosystem. And presently, he's country manager at Global Foundries, and again, a huge supporter and advocate of the ecosystem in India, and playing a very active role. So we will gain from his perspective. And finally, we have Dr. Kamaljeet Singh, the sole government representative on the panel. So we'll pick his brains in more than one way. But I think SCL, as we all know, is an iconic Indian enterprise and is playing a very vital role in the strategic sector. And Dr. Kamaljeet Singh, congratulations. 2 days ago at the inaugural, the PM was gifted a memento which had the Vikram 32-bit microprocessor jointly developed by ISRO and SCL, and several other chips that have been designed as part of the C2S program but fabricated at SCL. So SCL is definitely playing a very vital role in helping bootstrap and develop this ecosystem. What we're going to do is we're going to look at the journey of a fabless startup through different phases. And I'm going to pose a few questions to some of the gentlemen on the panel. And obviously, if others want to jump in, please feel free. There are mics right next to you. So my first question is going to go to the two relatively new startups, Neil and Sridhar. Neil, you can start first. Right on the onset, when you are thinking of starting an enterprise or building a product, there are some fundamental questions that need to be asked. Excuse me. What product will you build? Which market will you serve? Who your customers are? What the competitive landscape looks like? Is it India-centric? Is it global? How do you differentiate yourself? And last but not the least, how you make money, right? And which is all about achieving scale. So why don't you kick us off by sharing a little bit of your experience in how you went about this process, and what can you share as a reflection for others to benefit from?
Thanks, Jaswinder, for the question. I'm happy to be here amongst these gentlemen. Hope to share a lot more of what our journey has been so far. So my journey as a founder at Shakti, at Encore, starts with the academic roots, right? I think the most important thing is we can build very great technology. I don't think there's a doubt about that. But are we building it for the right problem, right? So the first question is, are you in love with the problem or are you in love with the solution? If you're in love with your solution, you're not going to go anywhere, right? If you can keep beating your chest that you've built the fastest processor or the tiniest core, if it's not a problem that a large people can appreciate, it's not going to be sold, right? So definitely from my roots, coming from academia, building Shakti, we knew that there is a technology, there is RISC-V, and that's going to be the bedrock of what we build on. But we made certain assumptions, we made certain wrong decisions, which we learned the hard way, right? The first one was you assume what the world needs, right? That was the first thing. We assume that with RISC-V, you can build cores and the world is waiting for these cores to happen, waiting for these processors to come out, but that's not the reality. So there's a lot of academic arrogance that you start with. There's a lot of fulfillment that you say, oh, I've done these simulations, I've been shown power, but once you go to market, that's where the reality kicks in, right? So we were sort of bootstrapped for a good amount of time, right? 3-4 years, we were doing multiple different things. And then we started customer traction. Then we reached out. We had the conversation with the first customer, the 10 customers, 20 customers, 50 customers, and they all taught us what last 4 years of development did not, right? We were trying to build Ferraris, whereas the world wanted a reliable Toyota with a custom paint job. That's it, as simple as that. And that's when we realized that we need to change ourselves, right? So the third learning was you got to listen to the market, you got to read them, and you have to turn around. And that's only a startup can do. No MNC can turn around that fast, right? And that's the strength you have. And I was lucky that all of my co-founders, we realized that, we saw that, we turned around, we realized that, not just the cores, people want everything that comes around these processors, the tooling, the verification, the infrastructure. If you're just going to give them an engine and say, go build your own car, that's not going to work, right? You got to give a good amount of assembly line to them. And that's where the pivot happens, right? So that was the third step. We said, okay, this is good. This makes sense. There are people wanting the solution. And then we moved to building these generators out of it, SoC generators, subsystem solutions. And then comes the validation part, right? That's when you need extreme amount of focus. And we just stick with one customer first, go to silicon, get the silicon out, test it for them, do everything possible for their success, because that's where your success is, right? You may not get paid enough for it, but what you get paid is the word of mouth. Today, that same customer is at SEMICON, we've got 4 leads coming from that first customer, right? And that's the investment you want to do on. You don't want to be doing 5 different things because you're a startup and you don't know what's going to work. Pick one, choose one, focus on that. And when it comes to making money, I think we are an IP company, right? We don't build chips. We're also getting into the automation side of things where we're trying to solve the spec to RTL space. The economies are not favored in that space. Right? They don't make you $1 billion or a unicorn. Roadmap is tough to build in that space. That's where you got to innovate, right? And one thing we've done is we've realized that today is a subscription era, right? You're not going to, I mean, if you want to choose a channel on your dish TV, you pay only for that channel, right? You no longer pay for the entire package anymore. You can pick and choose what you need, how you need, and that's exactly the model that we are also trying to imbibe. Whether it's IP, whether it's automation, whether it's the solution, I think making a change in the business model rather than sticking to just NRE and licensing, having a subscription-based model, that's something that we're trying out. We don't know whether it's going to work or not. But yeah, those were some of my learnings, some of my initial thoughts that people should be aware when you're starting your journey off. Happy to hear others.
Good morning, everyone. Thank you. First, I would like to congratulate SEMICON India, DLI, Mighty, and all the people who are behind the scenes to make this happen. Our journey started almost 1 year of doing a complete market study in understanding what is available in the market, what are the differential factors we can bring in, and more importantly, we wanted to pick something that will have a mass appeal and where we don't need to go through so much of regulatory compliance and several other requirements, because at the end of the day, when you're getting into a semiconductor fabless design, we really want to make sure whatever we are building can go in masses and it can also meet the market price which is already there. Then we went to all the manufacturers, OEMs and ODMs who are making a product line which will be with our chip. We shared our feature list. We had multiple rounds of discussions with them. We understood what is needed and what is not needed. And finally, we had our business plan and business proposal in terms of what is going to be the overall costing, and then had to look at how we are going to fund this whole operation. And more importantly, we wanted to have a very strong validation done, and that is where DLI came. So we had our business plan and our solution and the chip, whatever we are making. We basically pitched it to the DLI forum, and in DLI forum, we had like stalwarts like Vinod Damji and several people were there who actually validated our proposal. And then like when they validated our proposal and when they finally gave a go ahead, then we know that, okay, we are actually getting into a SOC that will have a big market appeal and which will also have a good volume business, because at the end of the day, being a startup is a little difficult. But importantly, when you are a startup, your funds are limited, so you have to focus on the areas and you need to have a very first pass silicon, and you really need to have a market that will accept and observe. So we started with the market and then we finalized on what we want to go. My team had a lot of stalwarts, so who understood this area and who have been experienced in the telecom and networking side, that really helped us to focus on this. Thank you.
Thank you. So clearly, I think investing upfront in ensuring a good product market fit, getting your early customer win, and gaining credibility on the back of that is critical in the early stages, and intense focus on execution. Great. Now, obviously, the big question is, where is the opportunity for Indian fabless startup companies to, build products where they can be successful? We are looking at the worldwide semiconductor market projected to be roughly about 1.1 trillion by 2030. I think the numbers keep fluctuating a little bit, but something of that sort. And I think a lot of the survey results show that India might be roughly 10% of that in terms of consumption. So a little over 100 billion maybe by 2030. Out of that, maybe about a 60% or so is going to be in the GPU, CPU type of an area, which is dominated by a handful of players. And I'm going to go out on a limb and venture that competing head-on with them is not the smartest strategy for a startup. It would require rather deep pockets and big investments. So, Jesse, you have a global view by virtue of having been in the industry for quite some time, working at multinationals across geographies and the like. Where do you see there is an opportunity? What sectors do you think Indian companies should try to address where they can be successful where they can build a sustainable business, so to speak, because it's also about scale, right? Semiconductors is a scale business. You're going to build, let's say, 100,000 to 1,000,000 chips a year, right? Your wafer pricing itself is going to be 20% more than a global player who's going to build 100 million chips a year. So what sectors do you think provide an opportunity to build a sustainable, successful, profitable business for Indian startup companies?
Thanks, thanks, Jesse. First of all, thanks for a very kind intro, Jesse. I don't think I deserved, all that you said. But, I just want to start. I've been telling this to Jesse, but I want to openly say, lot of us growing up in this semiconductor industry, and specifically in India, we have always looked up to Jesse for a longest time. At least people I know, some of the
You're
people
making me feel very old right now.
20, 25 years plus. I think you have given a lot of inspiration to a lot of when we were young, during our young times. And I think some of the things that we tried to achieve, came through, what we talked over the last 20 years with you. So thank you very much for that. I want to openly say that. And not only me, a lot of us, when we talk offline, we talk about that. So, round of applause to Jesse. And I agree with Ruchir, it's a very daunting room. But, Ruchir is not used to it. I'm very used to empty houses, right? So this is not, I'm not afraid of this one. I think you said right. The only change I will make is the statement, Jesse, you made before I answer my question is, hopefully it is not 60% in the high end, it's 40%, because that's our view. It would be 40, 60 when we get to $1 trillion, industry. When I say 40, 60, just to clarify, 40% on the mature, advanced nodes, 60% on the mature nodes, kind of a thing. So that's the view. I think that's where we feel how the industry will go. Now, to your question on what the fabless companies should look for in which segments they should play. One of the lessons I've learned working very closely with the startups, and I'm in awe with everybody who does a startup, because I can never imagine to do one, is that not to tell them which areas to look for. I think that's the biggest mistake that mistake I've made multiple times, telling them. Why I say that is a mistake is whenever you tell them, I think first they don't listen. They will never follow what you are telling them, because they already have their passion. They already know which area, they would want to contribute. They have their experience that they bring to whatever they start as a startup. But what I would say is, in general, if I have to give little bit of guidance, because we all work very closely with startups, from our business or the company perspective, or personally at times, right? I think first thing we all should know, not only the startups but even the industry, players like us, is there is lot of trend change that is happening that we have to be aware of and build and be conscious that that trend should not come in way of anything that we start today within next 5 to 10 years, right? I'll give some examples. There are many, but I think the new materials that are coming in the semiconductor, from CMOS to compound, the GaN and the silicon carbide space, right? From electrons to photons, because that is the need, with silicon photonics coming in, that is the need that you need, not only on the edge, but on the data center side of it, right? From, the generic purpose SoCs to, application specific, and it is being enabled by AI designs and so on and so forth, right? Becoming cost effective. I think if you look at all of those trends, and you can keep adding, I think there are 8 or 10 that are received. The first thing, if you are starting a fabless or if you are looking at it, see where these trends and what impact to the industry these trends are going to make, so that you are aware right off the bat. The second one, I would say, over the time I have divided the startups, especially in the semiconductor space, into 3 segments. One is, and this is not, I think, the industry one, it's just in my head. So one of them is like deep tech, where you are trying to bend the law of physics or the limitations of physics, and you are trying to bend and going across it. I think very, very impactful if you are in that play. The second one is the Me Too. Lot of us that we see is, this SOCs are, being already in play. Some other part of the world, the Taiwan ecosystem, China ecosystem is developing that. And you also want to do it and do it at a right cost or a better cost, right? So you can become a Me Too player there. And the third one is, can we develop a platform? Is somebody thinking of developing a platform on which you can develop multiple solutions over the time, either for a vertical or a little bit of the generic, right? So I would say for India, I'm actually just reversing it. Rather than startups thinking of which segment to go, and Jesse, with your new role with the ISM, I think this is something I would like you to propagate. This will be very powerful. Can we look at the top 10 problems that we can solve in India and rally all of our startups maybe around those 10 problems, right? And I will give you some examples and then I will close. For example, in the infrastructure space, Mr. Amitesh was here, but railways, can we build the whole stack or a solution for railways? Not just think of a fabulous startup, but the solution for the railways, which lot of startups can come and play a role. Or, our toll, management system. Why do we have to stand 5-10 minutes, for the toll? 25 years back, if you were in Singapore, you were just crossing by. But our road conditions, our systems are little demand that we have something that is indigenous for us or something specific. Can we build a $2 billion solution for multiple startups to play, and Fabulous being one of them there? And there are multiple of those examples. But we can take those top 10 and say how we can then $2 billion business for each of them and take it from the ISM as a challenge back to the DLI companies, non-DLI companies, and so on and so forth. So that would be my guidance.
Awesome. So if I were to summarize what you just said, Jesse, one is look at the trends going forward and focus on areas which are emerging. That's one. And the second big pillar would be, let's look inwards to, the challenges and opportunities we have within the country and address those with novel and innovative solutions. Those would be two key messages that you'd leave everybody
So that way you're not competing with the global players who are already doing...
Competing with established global players is just going to create headwinds. That's going to make it more difficult. Excellent. And so my next question is going to go to you, Kamaljeet. Yesterday, there was, in one of the panels, there was talk about the fact that, when it comes to surveillance and CCTV cameras, there are new, for reasons of security and privacy, there are new STQC guidelines that, in a sense, create an opportunity for Indian companies to come in and build both chips and systems addressing that. I think that's another sort of example that feeds into the kind of thing, Desi, that you're talking about. So, Kamaljeet, question to you is going to be, like, if you look at the strategic sectors, if you look at space, defense, security, and other such related segments, where do you see opportunity for Indian startups to play in that space?
Thanks for giving me the opportunity. I will just brief you that whenever there is a need of a strategic sector, like in the case of a space, if you take, or take the case of a defense, nowadays there is a lot of startups in the space also. I think mostly around 200 plus are there, and they are doing very good. And the segment is also not only on the rocket side, but satellite side also. You are doing a lot of things in the bus systems also. In the case of defense also, you have a lot of startups, more than 1,000 startups are there. Now, where the opportunities lies, now comes to this, in this segment, the most important point is that you should have a repeatable system, you should have reliable system, and you should have reproducible system. Now, all these factors, what it makes is, you used to go with a heritage system then, because it is highly, highly reliable, and you can't take chances in that type of system. But what is happening in the present scenario is, you need a system which is miniaturized, because if it is a miniaturized, you save a lot of things, like rocket cost is saved. You need a modular system, you need an agile system, and it can be reconfigurable system. Now, what is happening in this case is, if your system is very big, now you want to make it miniaturized. Lot of systems has to be put in one chip. Now you have to define a problem like that way so that your board size decreases drastically. And in this scenario, what we have done in the case of SCL also, we have taken that type of challenge, and we have made 60 to 80% reduction in the size. Now, what startup can do is, because if you define a problem to them, they can come out with a very innovative solutions. Now, another part is because you are in the strategic sector, so you need the design also should be in the country, manufacturing also should be in the country, and validation also in the country. So in the case of SCL, we are doing the customized solution, but we are also opening up for the startups. And that is why we are giving our PDKs to the startups so that they can use 180 nanometer. The next approach is because once you have made the design, like if I am a designer, if I am a startup, what I need from design to product, it has to come out very quickly. It should have low turnaround time. So as an IDM in SCL, not only we are giving the flexibility of doing this designing as well as packaging, we are also giving manufacturing, as well as the another aspect is we make it the TRL level 7 or 8. So we also have a capabilities of screening and qualification of the devices. Now, keeping this scenario in mind, the only thing is because in the case of strategic sector, you have to define a problem for the startups, because if the problem is defined in a particular way or they understand it, they can come out with the solutions. So now I think space sector is open up. They have put all their specifications on an online platform. So anybody can take that challenge, can make it. Now one more example is there is one more processor which is known as Leon processor. This is Red Hat processor, and that also is an imported thing. So one more challenge can be taken, like this type of processor can be made in the country itself using this manufacturing of SCL as a prototyping, and in future in 2 to 3 years when Tata Fab is coming, it can always be ported in 28 nanometer. The another change, another thing which startup has to look into is because strategic sector needs mill grade or space grade radiation hardened devices and all. So that also they need hand holding. So that way there should be more interactions of strategic sector with the startup, because they should be knowing that what is the Red Hat and what is the mill standards, which is making it in extreme temperature, the devices has to be there. So I'm seeing this lot of opportunities in there, not only in the space or defense, like in the case of railways also. There is modular things which is coming in the Vande Bharat, so lot of scope for them also. Even in the space for not only in the chip side, if you see space sector and all, there are triple E components. In the triple E components, you need lot of triple E components like MOSFETs and all, which we are not producing, discrete transistors and all. So that also has to be looked into, because that technology itself is prone for HMCs and all, which we can customize it. So there are a lot of opportunities which is there for the present startups.
Thank you. No, clearly in these strategic sectors, in the area of infrastructure, we want to be self-reliant, Atmanirbhar in the true sense of the word, for various reasons. And there is, what I'm hearing from what JC mentioned and what you're saying is that there is a lot of opportunity, and the government itself is going to be a huge customer in these areas. And SCL is committed to working very closely with startups and enabling them to be successful in addressing these needs and solving these challenges.
Added up to that, last year we have a space startup meet. Last year we have a startup meet where 35 startups were there in Delhi itself. 8 and 9 have taken PDKs from us. They are doing the actual problems which we post to them. 10 days back we have a space startup meet where more than 180 startups have joined there, and we have given that opportunities which we are providing to them. The another thing which we are giving to the startup is we are giving some space free of cost in our MPW shuttle run. So they can utilize that type of opportunities also.
Awesome.
To make that type of their product which can be validated also.
Awesome. So, Parag, now coming to you, right? As we said, you were one of the very early fabless startups in the country, perhaps maybe the first one? Okay, good. And a successful one at that. I'm sure there are many that didn't make it, but you're one of the very early and successful startups. And you've been through like the full journey, right? Culminating in the acquisition, a strategic exit, if you will, and an acquisition by Tejas. So from your experience, what can you share in terms of the challenges that you faced, beyond what's already been shared by Neil and by Sridharan, right? What challenges did you face? What can we learn from your experience, both for the startups, but also from a policy perspective, right? We know that MIT and ISM are very committed to doing whatever it takes to enable this ecosystem. So we'd love to hear from you your perspective, both for the startups, but also for the policymakers?
Yeah, thanks. Thanks, Jess. Sometimes I think I can write a web series on what we did for the last 14 years and survive. I think if you look at it, our story has largely been pivots, near-death experiences, and a lot of headwinds. Right, I'll come to each of them. I think pivot is a fancy American euphemism for saying that you failed, right, and you turned around. So we did multiple pivots. The first one was, we started off like any other, I think Neil said that, right? You're starry-eyed, you've got this romantic vision that you'll start a company, you'll become a billionaire in maybe about 5 years, you'll go IPO. And we thought, we thought we had one of the best architectures that we had. I think, like JC mentioned, we took on probably too much, plate in the first place, right? We invented what passes off now as multi-core heterogeneous DSP architectures. We didn't know that at that time. So it's called that. So about 10, 15 years ahead of our times. That said, we came up with a product. The product worked. We had, design wins with Sony. But then you just couldn't meet the pricing. So what happens is semiconductors is part. It's the tip of the iceberg, right? Technology, if you look at it, is the tip of the iceberg. The real thing is the operations and getting the grit work done. You have to meet the price points. You have to meet the quality requirements of customers. We still start off with semiconductors as some kind of a technology hobby, but converting that into a business has been a very big challenge. So one of the things that we didn't bargain for when we started off is the Chinese government and the Indian government. So the Indian government was giving us headwinds, pulling us down at that time. I'll give you a couple of stories of how we went around. So the difference between then and now for Neil and Mani and probably Jyotish now is the macro environment. So somebody raises money and the minister tweets, said, wow, we raised $25 million, $20 million in 2011 or 2010. We are one of the only startups in India, non-Chinese startups in the world to probably raise money. And that too from Intel Capital and General Motors. So nobody even knew about it, right? So probably we were not that narcissistic as we are today. So the macro environment is very different right now. So that's a big thing. You get immediate visibility. You get also all the accolades and also VCs chasing you. During our times, we were competing with Flipkart. All the Kirana stores, I call them, passing off as deep tech. So that was the challenge that we had. The Chinese government, because the moment you get into a design, you get a design win or a design in with a customer. Somebody out there is buying revenues. At that time, we had a lot of these Chinese startups coming in and being subsidized by the government. So they got a wafer pricing that was 1/4 of what we used to get. Yeah. How do you compete? No technology can compete. You can't build a business. So that was the challenge at that. And just to talk about the headwind that we got from within the local ecosystem is, we taped out, we did our first 40 nanometer chip, I think it was. It was 40 nanometer chip. We did the first 65 nanometer chip in 2010, 29, in less than $1.5 million those days. Then we did the 40 nanometer after we got the Intel, in spite of the Intel backing, we are doing this tape out. We have a contract with TSMC. So we are sending out, payment to TSMC. And we have to send out about $750K or $1 million those days. We're not getting anything back. So the RBI thinks that we are doing a Ponzi scheme. We are doing some hawala. So they sat on the file for about 4 months. TSMC being TSMC, they threatened to, cancel the contract. Because we keep telling them, the government is not allowing us. Then finally, we had to use our good books in ISRO, go to the finance ministry and tell them, look, these guys are our boys. They're not doing hawala. They're a semiconductor company. This is how things happen in India. So at that time, the guys before us used to actually have then we realized it's better to have a headquarter in Singapore or somewhere else, sell the thing and get the chips back in India. So those are the kind of headwinds that you faced with, right? And on the near-death experiences, I think we had two. We first in 2011, just before when Intel came in and invested in us, and next in 2016, I think 2016 or 2017, where we were 1 week away from closing down the company. And it was impossible to raise money. And Intel was just exiting for a whole lot of other reasons. Most investors thought that, you know, we have done something wrong because Intel is exited, because they had their own challenges at that time. So those were the some of the issues that that we had. And then the pivot that we did was we realized that, you know, it's extremely difficult. I mean, part of selling semiconductors is operations, right? If you don't have good operations and good product marketing, however good your technology is, you won't go too far with that. Yeah, and so the pivot that we did was we had a very interesting architecture, and we initially started off looking at the global markets out of India. That was one of the mistakes. We should probably had been incorporated elsewhere at that time. Now the macro environment is different. So we pivoted in building systems ourselves. So we started to build satellite modules for ISRO. ISRO was our first customer. Then we worked with the Indian Army to build software-defined radios. That's one of the key technologies that we built. So what we realized also then is we had to go out because we didn't have a Samsung or a Sony based out of India. There are no motherships. There are no motherships in India, systems company in India that actually pick up these products, pick up this fabulous products and actually take it to market. An important part of the ecosystem I also realized over a period of time is not just building the product. You also need a customer who's willing to take a 70-80% product ready and pull it out of you. And if that element is missing, no amount of, and any startup, right, they will all be raw always, right? You won't have that thing. So the final thing I always, and it is true then and it is true now, I call this the Swami Vivekananda route. The route to Delhi, anywhere in India, goes from Chicago. So even before he went to Chicago, he was just hanging around like a fakir in India. Nobody knew about him. So when a Caucasian baptized him, then he suddenly becomes popular in India. Same thing with Gandhiji, right? If you had not had a stint in South Africa, I think you wouldn't have recognized him. So that's the problem, that we have a mindset, I say, in India, that we should be actually be willing to bet and believe in our own entrepreneurs. That was the lesson. The building of the trust was, is something that I think was the major important lesson that we learned.
Awesome. No, thank you. Thank you for sharing your journey, Parag. A lot of very valuable lessons, but if I were to very, very quickly summarize, I'd say that the macro is definitely changed significantly, as evidenced by this event, as evidenced by the fact that the PM showed up twice over 3 days. I think the macro is very different. The time maybe is right now for fabless and semiconductor companies to build products in India. But the one thing which still remains a challenge is the fact that we don't have a vibrant systems ecosystem in India, which means we can design and build all the chips we want, but who's going to design, who's going to design in those chips into systems? Because eventually it's the systems that sell, that it's the systems that businesses or individuals buy, and so that's a gap that remains. And I think I'd like to circle back on that once again. But before I go there, very quickly, we heard this from Jyotis in the morning that DLI and schemes like that have been very helpful in supporting the ecosystem, C2S and DLI both. They provide, lower a lot of the entry barriers by providing access to things like the EDA grid, providing financial support, the support that comes in from the Chip-in Center at CDAC, the support that gets through the MPWs at SCL and things like that. So very, very quickly, and I see that the timer is showing we only have 4 more minutes. We're going to exceed that for sure by a few minutes. I got a thumbs up there, so thank you very much. But really quickly, 2 questions. One is, if you can, of all the support that you got, what's been the most valuable to you? How has it helped you? But more importantly, where do you see there is further support required? Again, I want to sort of address 2 key stakeholders here. One is the aspiring startups and what they can look forward to, but also the policymakers, because I do believe that this is the beginning of the journey. A lot's been done, but a lot more needs to be done. And so we'd like to tap your experiences to capture both of them. So I'd request Neil, you, and then Sridhar to quickly talk about it.
Thanks. No, I think the DLI incentive was godsend, especially at the point that we were developing stuff, right? The EDA tools was amazing for us. I think that's the biggest thing that's helped us. It's helped us characterize our IPs, optimize them for different PDKs, for different nodes, build an ecosystem. As I said in my previous answer, right, my response, just doing the core, giving you the RTL was not the end of the story. I had to validate it across the tools because my customers could be a Cadence customer, they could be using Synopsys flows. Having access to all three of them with, eat as much as you can sort of a buffet. That was one of the biggest benefits. I think we still have, we are still abusing it to our best capabilities. Very proud of that. Couple of other things that we saw coming in later was what Chipin started putting up these tutorials, right? Now, as a startup, you don't get the liberty to go hire these veterans across the stack, right? You're going to be fresher heavy, you're going to be graduate heavy. And you can't do those trainings yourselves because that's going to take a lot of time and the contributions come in late. So having Chipin do that for us, that was a major benefit that we've tapped into as well. For us personally, I think what I would like to see next would be, we're an IP company, right? We stop at RTL, verification, collaterals, FPGA prototyping. But to do a first MPW, I need to do physical design. I could either outsource it, but if I could have CDAC or someone else as an aggregator, maybe a larger variety of aggregators rather than the few that exist today, if somehow we can break that, make those accessible to the startup, saying if your RTL is ready, they can support us to go to GDS, go to the fab, interact them, because we'll be doing a lot of MPWs just as prototypes, not as production. So supporting there where the ideas can translate to GDS, I think that's where, that would eventually become the need for the next wave of startups to come. Yeah.
I agree with Neil in terms of like the support provided by DLI and tools and trainings was phenomenal, because as a startup when you go, typically they ask what is the volume, and then like the time to get the tools and licenses, it takes quite a time, and DLI and the EDA has really made it very easy. What I would like to see is like testing equipments, like oscilloscopes, high-end oscilloscopes, spectrum analyzers, and these are some of the things if it is made available at the various local areas, because once you have the chips done, SOCs done, you really need to have access to those testing
equipments. So the labs for testing and validation.
Testing and validation, and also for debugging also. It's very, very critical. Okay. Thank you.
One thing that's a pleasant change for me personally is I've been in the industry for many, many years. Every time in the past I used to go as a representative of Cadence, the #1 complaint was always about cost of EDA tools. I think DLI has taken that out of the equation. So, the EDA vendors don't have to deal with that question anymore. That's a big relief. Okay, great. The next panel after this is going to be a VC panel, right? And we know that the fabless semiconductors, really to get to production, to get to volume, eventually requires you to raise funding, right? And Neil, you've raised some funding. Parag, you mentioned that you had raised funding in the past, long time ago. But what are some of the challenges in the process of raising the funding? And what advice do you have for startups? Because it doesn't matter what level of support DLI provides or ISM provides, it's never going to be enough to get to that level. Eventually, you have to get to a point where you have to raise funding, right? It could be 10 million, 20 million, 50 million in today's context. It varies, depends on the kind of chip you're building. So what advice do you have?
Yeah,
and anything to
No, don't believe the VCs when they sit here, right? They'll say something and something else when they go out. So they are all a herd, I'm telling you, in India. Well, that's my person. So between 2007 to 2011, they were laughing at us, right? Of course they would. The Valley plan trying to build it out of India. So I can have stories after stories that, from where I've learned, on how they wouldn't ever focus on, they would ask me to do sensitivity analysis on Excel sheets. So then anybody tells you to do sensitivity analysis right now at this stage, just walk away from that. There's no point in doing it. We stopped going to VCs because at one point in time, one of the VCs asked me, so you think you can build better silicon than Intel? I said, I lost that conversation. I said, yes, you don't understand how the startups work then, right? If that was the case, startups wouldn't have existed. So those are the conversations that we had. Then we realized the best way for us at that time was to go to strategic investors. And that's why we got Intel. We got General Motors. And they understood what they knew what we were trying to do. That is one thing. That is one of the things. I think initially, I think right now there are enough HNIs, there are enough, I would say, I would say angel investors that can actually take you to a round where you at least have a proven unit economics. You got some unit economics going, and then you get the VC or probably go to a PE. What VCs like, I realize now, are very good cash flows. Cash flows can be negative, right? And yeah, Flipkart is still making losses, right? And I mean, they pumped money after billions of dollars into that. But any long gestation businesses, I don't think even in India there's anybody who understands that yet.
Yeah. No, you're absolutely right. I think this is a very specialized industry. It has its own characteristics and dynamics, and sort of the VCs that understand this domain. And I think that the landscape is changing today, right?
And one last point: every time we've raised money from anybody or got a customer, first customer, were these one-look guys. They look at you for 15 minutes, listen to you 15 minutes, and they say, I'm going to work with this guy. And that will happen only if you have been an operational entrepreneur, not an IIT, IM guy with Stanford or I don't know whatever, and sitting there. You don't have operational experience. So you don't know, you can't size up a guy. How do you size up a guy? Only the guy who's done that before does that. We don't have entrepreneurs in residence there in the VCs who are actually guiding them. Probably that is required.
You're absolutely right. I think it needs to be a VC who either understands the industry or has somebody on their team or extended team that understands the industry, because this industry works differently from the businesses that they're used to. Neil, you raised money recently.
Oh, absolutely. Recent is just 2 years back, and I don't think I have too many differences, different opinions than what Parag has mentioned. Back in 23, we raised our first round with Peak 15. We were talking to all investors who were interested, global and local. But as he mentioned, it was like explaining rocket science to someone who is used to riding bicycles, right? They're happy, they like the cash flows in those SaaS and fintech startups. And then what happens is they try to map those into our, they try to retrofit our models into them, right? So they treat us as a broken SaaS company. That's what Semiconductor was at that point. But we spent a lot of time. We were very choosy. Yeah, that's what we are rebranding ourselves now. So we have to do that. But yeah, I think we were extremely choosy, and that's what I would suggest to all entrepreneurs, right? You want to go to a VC who can open doors, not just write a biggest check, right? Don't go behind high valuations. Find the VC who has the patience to stay with you, who can open doors for you, because I think the biggest challenge you're going to face is not the technology. Whether you're an IITian, a triple IITian, or NITs, wherever you come from, you're going to build amazing tech. What you're going to struggle is the market access, right? Government is doing its part. It's going to take its own time. But in order to go global, you need those investors to open those doors. And that's where we were picky. We sat with our investors for 6 months. We had near-death experiences back then. We were all, not drawing salaries. Everything was bad. But we waited 6 months before we took that check-in, because we wanted to make sure that they understand what they're getting into. And that's the first order of business. The next one is, what I would tell the VCs is, you have to treat us as a different clan, right? We are a different beast. Stop trying to retrofit us into fintech flows. Our growth profiles are different. Our risk profiles are different. And the patience level that you need is exactly what you saw yesterday, waiting from 9 to 12 at the entrance, right? If you had the patience to wait there, only then invest in the semicon industry, right? That's going to happen on a daily basis. That patience capital is exactly what we demand at this point.
I've been told that our time's up. We have to wrap up. So before I wrap up, I'll just one rapid fire question to all the panelists, which is, if you had to lay out a 5-year roadmap for scaling India's fabulous startup ecosystem, what would be your top 3 priorities? Really, really brief answers from all the panelists, starting with Kamaljeet, your end of the thing. Really brief answers, and then we'll call it a wrap.
I think the first and foremost, we should look into that whatever the need of the country should be in one place. So people should not turn around or run around for that. The second thing is we should have clear roadmap like IPs which were made by our own country startups and all should be available to all of the people who are working for the strategic or academia. The third thing is we should also, the schemes which are there, it should be continuing so that turnaround time should be very less. Whatever they are designed, it should come as a product very fast so that if there is iterations, needs and all to be done, it should be done very fast. And we should also concentrate on the reverse engineering. If there is any fault in the chip, how to diagnose that. So that capability also should be there in the country.
Thank you. Peter.
Provide greater ecosystem. Without design, there is no production. And second thing is better policy on finances, because banks and everybody are used to bring. I think
raising funding will always be a challenge.
That is one thing. And the third important thing is market access.
Market access.
At least proof of concept, because every company, they can at least take some of the chips that is made in India and then like try a POC. There is nothing that anybody is going to lose by doing a POC.
And so it's again incentivizing and stimulating the systems ecosystem in the country.
Yeah.
Excellent. Thank you. Easy.
You know, I already said, I think the market access where we create these top 10 needs for the country, I think the number one, I would say. Second, funding. I think the next panel, Parag and maybe Pradeep Vajram should be added to it. Pradeep just told me the VCs don't understand our valuation before this session. But I would say create a fund that even if 30% of that government puts it in that fund, rest comes from the market, right? Create a fund that solves the problem that Parag, Neil, and Sridharan
I think there are deep tech funds that are coming up, and there are VCs today who have been in the semiconductor industry. I'm myself advising a couple of the funds, helping them, look at their semiconductor investments. And the first order of the business is really to educate them that, hey, this is a different ball game, and you need to look at the companies through a different lens and not your typical spreadsheet P&L models that you're so used to.
And third one, Jesse, I would say, I think I'm just copying it, but I think we need to go semiconductor stack solution way, like we have India Stack, and that has created a lot of value. I think we need to create that semiconductor stack solution. And one of the things GF is trying to do is, we have an India Foundry program Connect program that we just started last year. And we are opening our PDKs, MPWs, IPs, and most importantly, we have selected 10 engineers within the company in different domains who are now working with the startups, 10 startups, to tell them even before what solutions they are creating, will they be manufacturable or not, right? So those are the kind of things I would say.
Sounds good.
So two things I have. I think one is on the buyer side, right? So most corporates don't invest in R&D. We know the market access. So incentivize market access. One way to do that is large corporates, public companies in India don't invest because the fear of write-offs. The write-off, if you say invest 200 crores and that write-off happens, in one particular quarter, your stock prices go down.
Quarterly financials.
Yeah. So instead of having a digital write-off, you have an analog write-off. So a very gentle roll-off.
It doesn't hit your quarterly financials.
That to me, that just one policy reform, I think will boost our R&D expenditure big time. The second one is incentivize. He knows it, right? Though he's from IIT, it's impossible to get talent for us, right? It's impossible to get. We have a social problem, right? Impossible to get, IIT grads or guys here. The IIT, in fact, is creating all the talent for the rest of the world, not for the Indian companies. So one way to do that is actually give tax breaks to people working in startups. Or in tier 2 cities. I think Jyotish is doing a great job. We have another company in Belgaum. We have the same problem. How do you keep people in tier 2 cities? Give them tax breaks.
Attracting and retaining talent is a challenge. Yeah.
Those two things would go a long way, I think.
Awesome.
I was going to say the same thing, right? We need some ways to motivate talent to choose Semicon and stay in Semicon. But my last point would just be India first policy, right? I think it's just not just to the government, but also to our community as well, right? If you have a local vendor who can provide that IP or that solution, choose them. This India first is not anti-China, please understand that, right? I think that's where we try to replace China, but we are replacing it with European, we are replacing it with someone else. And India first policy is, I am okay with 60% maturity, that's fine, I will improve on top of it. give your peers, the government gives us that ability to say, learn at our cost, right? And I think that has to come up in the next 5 years. Otherwise, we'll be building for the world, but not for ourselves. That would be a shame to end up at.
Awesome. No, thank you very much. I think that's going to be a wrap for the panel, and I'll just like to summarize that this is the beginning of the journey. There's a lot of progress that we've made in the last few years, especially from what Parag described as his experience versus what Neil and Sridhar are saying. But we still have a long road ahead of us. I think with the support that we are getting from MIT and ISM, I'm very optimistic, and I'll leave you with my personal signature line, which is the best is yet to come. Thank you.
Thank you very much, Mr. Jaswinder Singh Ahuja, for moderating the session. And also, we'd like to thank all the esteemed panelists, Dr. Neil Gala, Mr. Parag Naik, Mr. Jitendra Chadda, Mr. Sridhar Mani, and Mr. Kamaljit Singh. Thank you very much. Sir, it's already beyond schedule, sir. They'll come to you. Don't worry. Just be there. Thank you very much. We would sincerely apologize for the esteemed audience here because it has already gone much, much beyond the schedule. But definitely the panelists will be there offline and you can pose your questions to them. Yeah. We now move on to the next session, as already been indicated in the session about the VC and startup perspectives and priorities. Investing in India's chip future, VC and startup perspectives and priorities. Thank you, sir. Thank you. To discuss the investment opportunities in the semiconductor sector and role which venture capitalists and investors in shaping the semiconductor ecosystem in India. I would request the panelists to kindly clear the way in front of the stage, please. Kindly move to the left. And there's a room on the left-hand side. So, this session will be moderated by Mr. Pradeep Vajram, co-founder and general partner of Seven Rays Venture. He's a seasoned entrepreneur and distinguished leader in the semiconductor and embedded systems industry with more than 30 years of expertise. And since 1994, he has established and scaled multiple ventures across Silicon Valley and India, including founding Smart Play Technologies. And currently, he's the co-founder and general partner at Seven Rays Ventures, a USA-India investment fund. So without much ado, I would request Mr. Pradeep Vajram to kindly come over. Put your hands together for Mr. Pradeep Vajram on stage, please. Our panelists, Somshubro Sompal Chaudhary, I would request the co-founder and partner at BF Ventures Bharat Innovation Fund to please come over, sir. And is also a co-author of a book, New Kind of Computational Biology, that was recently published by Springer. Hearty welcome to you, Mr. Chaudhary. We will also be having Mr. Nikhil Rajpal, CEO of Hero Electronics. The CEO of Hero Electronics with over 2 decades of experience across Hero Electronics, McKinsey and Company, and so on. He is deeply focused on positioning India as a hub for semiconductor and product-led innovation. Hearty welcome to you. I would also like to call upon Ms. Vrinda Kapoor. Please come over, ma'am. The CEO and founder of Third Tech and recipient of the Army Design Bureau Award. And she represented Indian industry at the High Tech Handshake event, has been the unanimously elected to the GTWN Global 30-year-old organization, which acts as a forum for executive women in telecom and others. Hearty welcome to you, ma'am. And finally, I would like to call upon Mr. Shashwat TR. Yes. Hearty welcome to you, an accomplished electronics engineer with close to 2 decades of expertise in advanced and non-destructive testing solutions for critical industries, including aerospace. His career reflects a unique blend of systems, engineering, high-level machine vision, and software development. So, hearty welcome to Mr. Shashwat, and straight away it's over to Mr. Pradeep to take us through the session. Over to you.
So, good morning. The panel discussion is about investing in India's chip future and the perspective of VCs and startup founders. This topic is almost a third topic, very similar topics. Yesterday there was one on the product nation, and today, just before me, Jaswinder and myself, we are talking about a similar topic, but different perspectives from participants. So just to give you background, if you look at what's happening is today the semiconductors are backbone of any in any country's economics. And our Prime Minister Narendra Modi ji yesterday talked about, the day before yesterday talked about how he described is the chips are, the semiconductors are digital diamonds, and it's a perfect way of describing it. If you look at what's happening today, we cannot even imagine our life without electronics, whether it's a phone, automotive, a car, compute, whatever you do, and more importantly, national security as well. In the past decade, if you look at 3 decades, India has done extremely well. We've been a service industry, mostly in the software as well as in the hardware. And those we have done extremely well, and we created a huge companies and over the globe. And today, by de facto, if you have any services, India is a service hub. Everybody knows that we earned the world trust on that. But moving forward, now India has embarked on semiconductor mission to become a part of a semiconductor ecosystem. And if you look at the world, total revenue is about 600 billion, and is going to be about $1 trillion in very near future. But our contribution to that is very little. India's contribution is very small. But we consume today about almost 10% of that. Now, India has now made a mission to make sure that we participate in that ecosystem and contribute that. Now, moving forward, if you want to be good at that, it's going to be a very different ballgame. Now, the reason why it's going to be a different ballgame is it's going to be a lot of passion capital is required. We also need a very strong technologies. In addition to that, a good government policies are also required. So to me, what we are thinking is we are moving from service nation to a product nation. It's a very different ballgame. More importantly, there are many countries that are already well established in this market. So how do we play, how do we enter here and become strong? So I have a great panelist here. Combination of for any startups, semiconductor startup, the first thing you need is a vision, which are entrepreneurs. The second important criteria is the finance, which is the VCs. And third important thing is who is going to buy, and which are OEMs. So the panelists, all 3 or 4 of them are here with a great experience in all of these fields. So without delay, what I want to do is first question to you, Sam. Semiconductor investment is a very different ballgame. India has been ecosystem, VC ecosystem has been great, but they've been investing in a lot of software ecosystem, e-commerce, and all of that. But the playbook for the semiconductor investment is very, very different. Now, I do see there's interest from VC ecosystem in India. What changed, and why do you think it's more interesting now?
Absolutely. So, can you guys hear me okay? Yeah. So, yeah, I mean, we are one of the early pioneers in deep tech investment in India. And my prior background, I'm kind of an operator turned VC. Was managing director of analog devices prior to that. Ran system companies and had startups and so forth. So, kind of a new genre of VCs that are coming in. But again, compared to the discussion that we had in the last session, right? Obviously, the VCs, I've been put on the hot seat out here, right? But frankly speaking, see, at the end of the day, we are not investing our own money. We are investing our investors' money. So it is our fiduciary duty to scan through all and every aspect of deep tech, be it other sectors and so forth, and give the maximum returnable amount, ROI, right, out. So for us, a lot of things are about timing. A lot of things are in sectors and so forth. So we continuously scan multiple areas, all the time, right? So be it new kind of materials, we have made investments in deep science coming out from universities and research, right? And some of them have been early stages of being pretty successful. Now, coming back to the semiconductor world, obviously, being a semiconductor person, I've been looking at this space for a long, long time. So few things, again, timing, as Parag mentioned in the last session, timing is very important, very critical. So number one, obviously, thanks to all of the geopolitical climate and so forth, everybody can turn off the chip tap at any point, right? So it is very important for us to kind of have a homegrown entire chip ecosystem. And that's what the entire policies of the Indian government, I'm sitting on the DLI scheme and so forth, is extremely important, number one. Number two is kind of the entire market access. You mentioned about a close to $110 billion by 2030 chip potential market, the focus of indigenization and so forth, that adds to things. The third piece which we already have is the talent. Not going to elaborate on that, but we already have that.
Correct.
Design talent at least. We are lacking in sales, product management, product marketing aspects, which we can potentially fill up. The fourth and the most important piece is we need to look at what happened in China. I just, on Monday or Tuesday, I put up a quick post on my LinkedIn. If you just follow what happened in China, similar kind of a DLI incentives and initiatives of the Semiconductor China mission, 2014, by 2020, 2,000 have come in, right? Many of them went on initially for the homegrown Chinese market. Some of them expanded out. In India, we are tied very well over to the global ecosystem as well. So if we can do stuff in India first, using the DLI, PLI incentives and so forth, then take these designs to a certain extent out, maybe not in US or advanced markets, but South. That's a big. So the sheer quantum of startups that are coming in, and we gotta choose a couple of them, make them successful. Believe me, once we have some success stories, more and more capital is gonna open.
I absolutely believe in that, Vik. You need to have a success story to have more number of companies to come in. That's what happened to the service industry as well.
And frankly speaking, the investors rightly pointed out, to a certain extent, it's a herd mentality, right? But once you see success, believe me, money starts pouring in.
So one other thing, I'll just lead one more question on that. And you're taking the example of China. But the difference, I want to be here a little bit more clear here in terms of the way of course we have to learn from them, but the way they've done is the amount of budget or money they have put in is significant. If I understand, it's about 20+ billion, the big fund?
More than that.
Much more than that. And that's where I see the difference right now. And we have 1,000 crores, which is 100 million. Very different. So how do you, yes, we have to learn from them. That's how the countries have done. But what's your suggestion? We're not there. And how do we, in this environment, what do you suggest we should do?
I'm waiting for all of these deep tech fund of funds from NRF, the DLI 2.0 and so forth to kick in. So today, if you look at what China did, close to $47 billion of money they put in from the government coffers. In addition, the other aspects of the regional governments and so forth, they put in close to another 20-25. And the VCs also put in anywhere, initially they put in around 25 billion. On top of that, another 100 to 250 billion. So we are still, I would say probably it's a circa 2014, 2015, if you compare to where China was. So 10 years, at least 10 years behind.
It's a combination of the government, VCs, and private money coming together.
But de-risking many of these early aspects, which DLI scheme has done, right? That is very helpful.
So I'll go to the startup founders. For Shashwant and Vinder, first of all, congratulations on taking this journey. I've been an entrepreneur. It's not easy, especially in the semiconductor area. You've already heard what Parag said in the last session. By the way, congratulations for you guys are getting a good traction. That's also good. If you both, the same question for both of you, but either one of you can start first. If there is one thing that keeps you awake in this startup mode, what is that one? What challenges you faced, and what is the one thing that you want to see the industry or the VCs or the government should do for you to be successful?
So, well, the one thing that's keeping me awake personally right now is probably my daughter. She's 2 years old. But having woken up, what keeps me awake is the sheer amount of money that we are spending of our investors with a certain risk factor attached to it. And you have no option but to spend that and go ahead, because if you're not bold, you're getting nowhere. But if you do spend it, how do you know that you've actually made the right decision? That is probably a very short summary of being an entrepreneur, I think, as you very well know. Everybody here very well knows.
So I couldn't agree more, and I would add to that one more thing. The one challenge that we have as we go up against an economy like China, where there is a whole of nation, whole of government, whole of industry approach towards building an ecosystem, that is still largely fragmented. Right? And until all of those different trails start to converge. So just as an example, my CTO joined us from one of the largest Chinese semiconductor companies. And what he said was that a lot of these things were created in parallel. So you had an OEM manufacturing something. You had the 6 different semiconductors that were critical to be able to scale the supply chain of that. There was government incentives plus venture capital that was stacked up for each. Prior to the development or prior to tape out, you knew what your order book for the next 5 years was going to look like. And as the OEM scaled, everything else along with it scaled. Hikvision is a great example of that problem. Huawei is a great example of that problem. There's a fantastic book that I think everybody should read. It's about Huawei. It's called The House of Huawei. I mean, this company is on its way to becoming probably the most valuable technology company in the world, right? Once the GPUs come out. But if you think about it, at the end of the Cultural Revolution, they started off with developing telecom network switches. And they were given preferential sales of that product by every government department, by every private company across the board for a period of 5 years. Because nothing tells your investors that you are doing well, like profitability and a bottom line. And if we can create at least the first steps of that ecosystem, that's what really keeps me up at night, thinking about how to create that ecosystem, who are the partners we need to bring together, and how to keep everybody motivated in this long design cycle.
Very well said. Fundamentally, there's a lot of fragmentation, and we need to come together, right from the design and the supply chain, as well as the OEMs come together to promote this activity. That's fundamentally boils down to the revenue generation for you. Okay, understood. In addition to that, I have one more follow-up question. You guys have been part of the DLI scheme. And of course, we heard from the previous panelists that it was very helpful in terms of getting the tools and infrastructure and all of that. Is there anything, DLI 2.0 is going to come very soon. Is there anything that you guys feel that we should incorporate more changes or recommend more things to the DLI scheme so that it's just, the first step is good, but is there anything more that you can suggest or recommend to the DLI scheme?
So from my perspective, a lot of what we have been going in back and forth with the DLI people has already been taken into account. So I don't think, I mean, there is going to be incremental change in the scheme. It's an amazing scheme, and there have been teething troubles, I'm sure, but it's an amazing scheme, and it is going to evolve. It has been evolving, and it is going to evolve. Our feedback has been taken. I think the most important thing we need to do is stay on the course and not examine it 6 months, every 6 months and say, why have we not got chips? Because it takes 3 months to pattern the wafers. You can't expect returns in 6 months. So instead of thinking of what we need to change in the scheme right now, I think we've set a certain path, and let's continue on the path and evaluate at the appropriate time.
Understood. So there's a patient capital. Be
yeah,
patient when
I think it goes back, coming back to the intent of the panel, right? It's when you're saying patient capital, DLI is capital.
Understood.
And whether our funding is coming from VCs or Ps or government or just customers believing in us, that's capital too. It takes that much time to build something, and we need to have the ability, the strength in the gut to wait.
Understood. And I'm coming to Nikhil here. Nikhil, you wear multiple hats. You're a PE, you're also producing some very intelligent, smart systems to India. So why don't you describe a little bit of what you do, and then have a follow-up question for you.
Yeah, thanks, Pradeep. Important to give context on why I'm here and among these guys, right? So look, I run a company called Hero Electronics, part of the Hero Group. We set this up 9 years ago with the idea of catalyzing, not deep tech, but deeper tech companies in India, right? At that point, when a hardware product company was deep tech, where everybody was doing SaaS and sharing economy, right? So I've looked at this space as an investor, and we were trying to write bigger checks, not VC, but 30 to 50 million checks, right? And we made 3-4 investments, one being a semi-engineering company called Tessolve, which has done phenomenally well for us and I think in the industry. Also built a couple of product startups. One of them I run myself called Cubo, which makes smart devices, smart cameras. Today, one of the biggest players in the space. We shipped 1 million devices last year, so about 1 million chips. So I have some understanding as a customer how this space works, and I've tried to raise funding for that company as well. So I have understanding, forget, semiconductor, try raising money for even a product company in India is so hard. Yeah, so that's the context I come with.
Yeah, and you've been on the system guy. Where do you see the gaps? For example, if there's one idea or one startup you need, one chip that you need, where do you think is, I know there's always, camera is one of the biggest one. Do you have any other needs that you can give us, or you can tell where the demand is going to be?
Let me make a more generic comment first, and then maybe come to Cubo and how we see startups helping us, right? I think in general, one of the problems I see is as people build startups from India, right? They're trying to build semiconductors. You got to of course we have the talent. Of course we can build it. And as Parag said, maybe idiots like us don't get it, but at the end of the day, you've got to compete in the real world, right? With real established global companies.
Absolutely.
Right? And the problem is, as an OEM today, or most OEMs in India, nobody's even making modules in India. They're not deciding which semiconductor to buy. They're buying full kits from China. Let's be honest about this, right? So if I go to Hero Motors, which is a group company, they don't know. Bosch knows, somebody else knows, right? What chips are being bought, and they don't want to influence that. The first problem is, where does demand come from? I think that's a bigger challenge to solve for. There are sectors like defense or security where I think the regulation has created real opportunities. Right? I think that's where there is something real, but one of the ways I think you'll have to get scale. I think that's where maybe what would be ideal is a few of the OEMs like us come together, provide some initial scale for them to be price competitive. I think that's where the real opportunity is in my mind.
You bring a very good point. You're not deciding on the chip itself, but you're deciding on the module, because it's coming from completely, it's a module that comes and fits into your system.
And that's a few rare companies like us who actually build product in India. 90% don't. And let's be honest about that, right?
This is a follow-up question on that for the founding members here for the startup companies. Now, clearly it says that at least the local ecosystem, most likely others also doing the very similar thing. So just by doing chip, which you already there are incumbents that are with global presence, and by just doing the chip alone, looks like it's not going to cut it to be successful. So are you guys thinking any differently, or what is your plan to the solution, the problems he has today?
No, you're absolutely right, right? We need ODMs. We need design companies in India, that's one. The second thing that we need is system on module companies. And as we think through ISM 2.0, those are areas that we need to create capacity. So if we think about the 10-year electronics journey of India, what did it start with? It started with a PLI scheme, which managed to create domestic manufacturing. That was step one. The second thing that we need to start working on is local value addition. So in my mind, the next version of the PLI scheme for white goods and electronics should have additional incentives for local value addition, up to 10%, 10 to 20%, 20 to 30%, so on and so forth. In parallel, we need to create, and I think the first steps have been taken in areas like surveillance cameras, a module scheme, a PCB scheme. As we start to think through a lot of these end products in more details, and that's where I think we're going to need manufacturers to come to the table, work with the government, and outline what those schemes look like, or what the broad contours of the value addition ought to be. That's the only way I think we can create the kind of scale and capacity. The second, the flip side to that is wafer pricing. We can only get competitive on pricing when we have volumes.
Right, true. And
so I think your question also kind of builds up on what Parag said, right? You, in his time, he had to go from just being a chip maker to being a module maker or even a systems maker. And maybe 10 years ago, the ecosystem was not there to build systems, and you had to do everything yourself. It's still very interesting to think of things in a slightly more chip plus something. If I'm selling, either I have to, so I'm making microprocessors, right, and microcontrollers. I need to provide not just the chip, I need to provide the IDE, the entire software stack. Am I going to build it, or am I going to contract that out? I need to provide modules because nobody really wants to take the headache of putting memories and processors together, and sensors for that matter. You get them as finished modules, right? So who's going to do that? And I think there are two ways of looking at it. Either you can capitalize and build the entire stack in one company, which has happened before in the world, or you can try to build out an ecosystem. And I think that is a design choice of the ecosystem, which we can't take as individual companies. It has to be a consensus decision of the entire ecosystem. And a lot more dialogue is needed, a lot more testing of the waters of how it is going to work in the Indian ecosystem is needed. It will take a while to settle down, but I think we will, because we have all the pieces. I think the theme for the last 12 months is we have all the pieces, how do we bring them together?
Sure. So what I'm hearing is it has to be the more integrated solution, right? Help the customers to make their R&D lower cost, so thereby some of the challenges you have with the wafer pricing could be leveraged or could be mitigated.
Can I just say, because you said R&D cost, we spend a shockingly low amount on R&D in this country.
Absolutely. That's the reason we are importing all the modules, right?
Now, either you can, what we've been looking at through DLI, for example, is subsidizing that R&D effectively at the end of the day. Another way of looking at it is, this is the really hard part. Convincing corporates to say, by spending, another 0.25% on R&D, that's all I'm asking for right now. Can you unlock 10x market value? That is a hard thing to convince people.
I want to come back to you. Oh, please.
Add something to that. I think, it's a chicken and egg. It's the R&D capabilities are there. I mean, we also have test all 3,000 engineers. We do ASICs for large, ASICs for a lot kind of people. So capability is not the issue. I think the issue is you need scale to be competitive. Today, I can buy a camera SoC for $1.2 with everything bells and whistles on it, right? And I have to sell the camera for 1,500 rupees. I change the price for 50 rupees, I lose 10% market share, right? And who am I competing against? The same Chinese companies you mentioned, right? So you need scale to build, you get the prices down. I think so. I don't think VCs alone or government can solve it. I think the real answer is who has the big volume in India, right? The corporates, ecosystem. We've got to find ways to get the ecosystem work with startups, right? And put some risk, take some risk, put some volume, and to make this happen. And there can be creative ways to do that. I think that's the answer. I don't think VC money alone will solve it.
I think it's never one person cannot solve, especially the VCs. They can only enable you, but the real burden is on the founders and the ecosystem that needs to enable them as well. That's clearly understood. I want to come back to you on the semiconductor investments. If you look at semiconductor, to be successful, there's no way you can survive with the $5 or $6 million as initial funding. Any product we do in semiconductors is at least about $10 to $15 million. If you don't have that kind of decent money, it's hard to compete in the global world, and even here, in India. Most of the VCs that in India don't cut the check size that $5 to $10 million, at least the ones which I've known, unless you bring the outside VCs. Is that changing now, or is there a syndicating few VCs coming together and saying, yes, we need to do this ecosystem, let's go and put a $5 or $10 million as an initial check?
So let me answer you in kind of two phases. So one part is, I think to a certain extent, and you start seeing, the news stories and so forth at a very early stage, 2 to 4 million or 2 to. I think that piece, early stage investing, is coming, augmented by kind of 2 million from DLI 1.0, right? So that, to a certain extent, I would say early stage, if it's a commendable team, they have a very focused approach towards a very certain market, the market is big, there are some certain regulatory aspects and so forth facilitating that market, or these guys are coming up with some innovative solutions, that is not just an incremental, but a step jump compared to even global stuff. I think you are going to see, a lot of stories on that front. The second part, which is still a big struggle, is even if you raise that 3 million to 5 million overall, getting to that 10 to 15 million next stage, right? It's a chicken and egg. The second stage of investors want to see at least the chip out, right? They want to see certain lead customers and so on before kind of committing that size. That is where I think we are facing a struggle.
Correct.
There's a consortium of a very small number of deep tech VCs and so forth like us. We are obviously looking at this space in very rigorously. And once we see those signs and so forth, I think pooling in the resources and so forth should not be that big of a problem. But we need to see those early signs of success. The second part is a lot of strategic investors, right? That's a big pool, family offices, strategic investors, that's a big pool. I think founders should try beyond just the finance.
I think Vrinda want to say something, yeah.
So no, I agree. I just wanted to build on that point. I think seed investments are happening, deep tech all over the place. And I mean, from hypersonic engines to semiconductors, right? I think the challenge, and I think this is a founder and ecosystem challenge that we need to solve, is Series A and Series B. So there are two things to remember. Your early prototype chip is designed because it's a technology concept. Getting that into the hands of a customer at mass production is 2 tape outs away.
Minimum, yes.
Right? That cycle is normally 18 months. That is the challenge. What is the customer lock-in? Is the customer actually locked in?
And believe me, this is not just a semiconductor problem. We are deep tech investors.
I think
we see that across deep tech spaces.
Yeah, since I know this industry very well, I can understand where she's coming from to take to the tape out at least 12 to 18 months, thereafter to test this another 6 months, and then customer validating another 6 months. So no matter how you look at it, a 2 years gestation cycles is required.
And from there, so you need your Series A funding in place.
Exactly.
When you have a customer.
Absolutely.
Signing up for your first mass production. And then immediately after on delivery, you need to be ready with your Series B. So the pressure on the entrepreneur between that end of seed stage, early Series A and Series B, that's the valley of death, right? So, and there, the market access, not market access, OEMs supporting with contracts is the make or break of those companies.
Absolutely. So fundamentally, your input to the VCs is help us to go through this entire minimum 2+ years of cycle. And
I mean,
and an extension as well.
Extension as well, yes.
I don't think it's about helping us, right?
Yeah.
I think one of the points on the previous panel was that we need to come together. If we want to make a semiconductor ecosystem happen in this country, OEMs, VCs, governments, and startup need to be partners in this journey.
Absolutely.
We need to take decisions together, right? We need to have a certain amount of aggregation and focus.
Understood.
So, if I may.
Okay. Yeah, please go ahead.
Sorry, go ahead. Okay. I just want to make a very small point over here. Historically, the VC and semiconductor industry grew in lockstep. The first VC-backed semiconductor firm was Fairchild, which was the first semiconductor firm. Somewhere these two seem to have broken apart, but as you were saying, Series A, Series B, that structure actually comes from the semiconductor industry. So the two which grew apart need to drift back closer together, I think, in a certain sense. And Nikhil sitting in the center over here is very interesting because he's a linchpin. He has 1 foot in, how you have 3 feet, I don't know, but you have 1 foot in P, 1 foot in the OEM and 1 foot in semiconductor. So I would actually like to hear your thoughts.
Going to say that, look, building, I think one of the things I've seen, and I've talked to startups, right, is as an OEM, is, and this is the nature of the problem, it takes a while for the product to be built, to be proven, things to scale. But as an OEM, when I talk to startups, I never hear a compelling reason why should I shift. What I hear is I can do this. But that's not compelling enough for an OEM to commit, as you said, the volume or capacity, right? So I think that's, I know, and it's not easy for a startup early in his journey to be able to say that, but that's a problem. So I think that's what we've got to solve for. And there's got to be creative ways between an OEM giving volume, maybe investing in these startups, take more risk to sort of bridge that challenge of show me the value, or the startup saying, trust me, I'll do it for you.
Sure, even some NRE.
Yeah, you have something to say? Yeah.
I was just saying, right, to a certain extent, the basic problem what we happen, the chip is of course not ready, right? The seed investors have invested, right? And the commitment from the customer is not there. It's maybe just a plain simple LOI, right? But nothing more. Okay. So typically even back at Analog Devices and so forth, we had a very committed 5 to 6 or 2 to 3 lead customers, which we knew if we have the chip ready, it's working to spec. These customers are lined up, they're putting up their teams in place, their NRE dollars in place and so forth, right? So that's probably one push and so forth we need. To a certain extent, I'm seeing the strategic investors are starting to do that, right? The defense piece and so forth, but we probably need the Indian large enterprises, right? To start doing that to a certain extent as well.
So clearly the message is very clear. So right now we have a bit of a fragmented industry. And to be successful in semiconductor ecosystem, you have to have a very collaborative efforts, right from the VCs to the founding members and the Indian OEMs is very important. Potentially also corporates being part of this entire ecosystem. So that's very good. I wanted to, they know we are about 10 minutes, 11 minutes we have. I will have one question for all of you, but then afterwards I want to give some time to the audience to ask some questions because they've been waiting to ask questions for the other panel. So what I want to ask you, this is going to be a very open-ended and a very, kind of not easy to answer, but we are consuming about 60 billion as of today, 52, 60, depending on which report you look at it. And very small percentage of that is actually indigenous. It's really not much. If by 2030 you want to accelerate this, do you have any secret sauce that you can say that, oh, if we do this, it will accelerate? To increase to go from the single digit to double digit?
If there's a secret sauce, I think it is product design and product marketing. It's not, there's nothing technical that we need to do which we have not already done.
Okay.
I think it's the ecosystem, and I think the missing piece of the ecosystem right now is the electronics manufacturing.
No, I think similar lines. I think it starts from manufacturing, having more product companies in India, more module makers here, big boy VCs here. They need to trust more product companies. We can trust the startups. So it's an ecosystem. I think that's got to come together.
Very good.
So I'll take a slightly different tack, right? So see, we are kind of on the right track. If you ask me, probably 7 or 8 years back when I was selling chips out to the Indian market, right? Compared to that, I think the number of Indian OEMs, Indian designs happening out, even Mahindras and the Tatas of the world, strategic electronics. I mean, again, we would have expected a lot more, but I would say at least, depending on the sector, 5 to 10x more designs, more Indian designs, right, are happening today, right? And this
Absolutely,
actually translates in my conversation with many of my semiconductor sales folks, right? That piece is happening, 5 to 10x growth, number one. Number two is the quantum of money today the DLI 1.0 has put in. This is still comparatively peanuts compared to what China has done. China in 7 years, believe me, 2014 to 2020, created 2,000 startups. Today, I am personally tracking 120 startups, right? And that's a very big step jump from 2020. So in 2030, can we create anywhere from 500 to 1,000 startups? My answer is yes, provided we push in the money. The second part is thanks to all of these initiatives and so forth that's happening on the PLI, DLI, the entire Make in India scheme. The number of companies designing in India, producing in India, manufacturing in India is going up, right? So just let's put 2 and 2 together.
Understood. So very clear message. So we have 8 minutes. I wanted to open this questions for audience, and then we'll have a closing comments. Yes, please. Why don't you?
Namaskar. Good morning. I am Dr. Jagdish Shivahare, professor and ex-distinguished scientist ISRO. Sir, my question, how is the SEMICON India different than global in terms of value-added strategies, potential priorities, and nation-building challenges?
Sir, sorry, is it a question or answer? Are you going to answer that or? Let's go ahead, yeah.
Okay, Meri Helle, semiconductor entrepreneur from Finland. So we have had amazing people in our advisory board during my 10-year semiconductor entrepreneur journey. And one of them was a semiconductor company founder. They did IPO. And he said that he spends 1/3 of his time with customers, 1/3 with investors, and 1/3 founding a fab for the next production. Then I made a phone call to another advisor, and he founded a company called Heptagon. They had a pilot line in Switzerland, built mass manufacturing in Singapore, and AMS acquired them with close to 1 billion in 2017. And I said to this that 1/3 to go find money. And then he said, no, it's 50% of the time. And his experiences, it's not that he sold diffractive optics chips to camera modules for Apple and Nokia back in the days, but he was able to sell the idea to VCs multiple times. But what I'm saying, why should we spend 50% of our time explaining VCs the things when we have the Ferraris and they are driving bicycles? This is waste of time. How can we solve this and do the real chip?
I'm sorry. We couldn't quite understand because where the sound system looks like...
sound system is very difficult to understand, unfortunately,
yeah,
out
sorry,
here.
Unfortunately, we couldn't clearly understand.
We can barely hear you, guys.
Maybe I could help
come on the
rephrase
stage.
and-
Come on the stage, yeah, please.
Sorry, you have a question?
No, maybe I could rephrase and add on to the point that she was making, but you can go ahead, yeah.
Sorry about that. You want, maybe it's because of the echo.
Just a short question.
Is it now better? Is it better? Can you hear me?
Why don't you shout it out?
Oh, okay. Okay. Without the mic. The advisors, one of them did an IPO with a semiconductor company, 1/3 went to seeking money. And another advisor, founder of Heptagon, that had the pilot line in Singapore, mass manufacturing for diffractive optics in Singapore, once acquired with close to billion. And he said, no, 50% of the time goes to money. And this is waste of time. We should build the Ferraris and not sell to people who drive bicycles. So how can we build an ecosystem and fund this and make chip happen big time and in India?
No, so I'll take it. I think if I understand correctly, so most of the time and energy of the entrepreneurs go up in fundraising, right? Versus developing the product, selling the product, and so forth. See, unfortunately, that's the case, right? So as a founder, I mean, we are fundraising from our investors, right? Our founders are raising funding. I mean, see, to a certain extent, I would say just get the right team in place, right? As a founder, as the CEO, one of the big points essentially is the fundraising aspect. You know, you can decide, you can use a banker, you can use other pieces and so forth. You can use your board, your current investors to help make the introductions and so forth. But at the end of the day, unfortunately, the founder has to pitch, right? This is the nature, and this is not anything to do with semiconductor. This is true for any business, right?
If I may just add one small point over here. The nature of business is about supplying goods to people who want them. And that is a supply chain problem, and one part of the supply chain problem is how do you provision the money to actually make that work. I think that's, you can't just think of building, you can't just think of selling, you have to think of provisioning the supply chain as a founder, as a CEO, and that's part of my job. The only answer I can give is get a team, get a co-founder, and get somebody who will take, so you said one third. I have a top team of 3 people, including me, who handle each of the 1/3. It's as simple as that.
So just a classic piece we have typically seen. 2 co-founders in a box, right? One focusing on the technology side, kind of a bit inbound. The other person focusing outbound, sales, fundraising, and so forth. That works best. If it's 3, they get into a fight. very, very often.
Okay.
So 2 is often.
Fight very often.
My point
More than 3, it gets difficult. It will happen, believe me.
So the 2 things that I think I would say over here is, it doesn't matter what industry you're in, whether it's e-commerce or it's semiconductors, 50% of at least one founder's day job is to raise money or raise awareness to raise money.
Well, it's absolutely right, and that typically is the CEO who is the face of the company,
Exactly.
is selling and getting the money.
Exactly.
Absolutely.
So whether you're
I
getting a
agree with
customer lock-in, whether you're working with the
There's no
government
way-
or you're doing the fundraise, it doesn't matter. Bringing in the money is 50% of one person's job.
Sure. Deva, I can take one more question.
Pradeep,
because we are running
you
out of
brought in
time.
one very pertinent distinction, and in fact, Som was mentioning that the deep tech ones within semiconductors are the ones that get funded, and traditional semiconductor chips, like a replacement for an analog devices chip or some image sensor or anything, is where the current market demand exists. So now, the way I see it, the traditional systems which can be supported by the PLI schemes and other things, are they really VC fundable in the first place? And for the deep tech, if we don't have an ecosystem for the regular chips, whether it is power modules or ICs, sensors, basic stuff, or even processors, what ecosystem are we talking about for the deep tech ones which are VC fundable?
No, so it's slightly different, right? So if you look at the type of startups we are seeing, and I'm talking about from a deep tech lens standpoint, again, I mean, as rightly Pradeep pointed out, we went from a complete services first, right, economy. We then went into a consumption first economy. And now I think from 17, 18 onwards, when we started the fund, we were looking more from an innovation lens standpoint. And believe me or not, in the last, when we started our fund, the number of deep tech startups were hardly 500 to 600. Today, that number is 5,500 plus, right? So the ecosystem has clearly grown. We have got some early success stories and so forth. But frankly speaking, the specific question you asked me, I'd love to have a deeper discussion on this.
So,
Sorry.
I think you want to summarize, and there's a time up.
Okay. I'm sorry, we'll take this offline. We'll take this offline.
So
just
sorry,
a
guys.
last question.
If you don't mind, I think we're time is up on.
Half a minute.
Come back.
We'll take this offline.
Okay.
Okay.
Is that okay? Is it okay to take one more question?
Yeah.
One last question. Yes, please.
We just need a quick suggestion from your side. The construction sector in the semiconductor factory development. That is basically one single question we want to ask. Past 3 years, all the developments that are happening, those are at very low speed, and there are major issues on ground. We just need one kind of suggestion from your side, what needs to be done as far as construction part is concerned for semiconductor. A basic observation from your side.
Yeah, I think we were able to. Can I take that question? Okay, I think from what I understand is there's so much of manufacturing, construction is happening, factories. What is an opportunity here? So I think it's fundamentally IoT is a big thing. Anytime you do manufacturing or any of these things, IoT plays an important role in making the process much more efficient. And that market is pretty big, and there's an opportunity there, I feel. Yeah. If you want to ask. So we have time up. I just want to do the closing comments. So it's very clear to me and to all of us, it's a once-in-a-lifetime opportunity to build the semiconductor ecosystem in India. Obviously, there are some positive things. One is the most positive thing is we have a talent. There is no question about it. One of the largest semiconductor design teams in the world we have. The second thing we have, which is also fortunate, is we have the local ecosystem, which is almost $110+ billion in the next few years. Those are the positive things. The challenges is, I think what we hear very clearly, loud and clear, is the ecosystem is not a little bit fragmented. It has to come together, and whether it's a VC system, whether it's OEMs and the startup founding members have to come together to enable this ecosystem, number one. And if you look at from our world point of view, it's very important for us to participate in that. There's no choice. So far, we've been looking at it from sidelines, that we have to be part of it. And I think in the next few years, if we come together, there is going to be a definitely big impact that we can create in the global semiconductor ecosystem. Thank you very much.
Great. Thank you. Thank you.
Thank you very much, Mr. Pradeep Vajram, Mr. Sompal Chowdhury, and of course, Mr. Nikhil Rajpal, Ms. Vrunda Kapoor, and Mr. Shashwat TR. Thank you very much for that wonderful session, for giving us your strategic insights into fostering investment in India's semiconductor startups. We'll now move on to the next panel discussion of opportunities for Global Investment Alliance in India. Well, ladies and gentlemen, we'll now all set to explore opportunities for global investment alliances in India. Now, this will be a panel that will highlight how international investment and strategic partnerships are key catalysts in advancing India's semiconductor ambitions. As we are all aware, with the growing global interest in India's evolving policy landscape, this discussion is going to uncover how cross-border capital can fuel infrastructure, innovation, and long-term growth in the sector. Well, the panel is now, I would request all of you to kindly move to the room on the left-hand side. Request the esteemed delegates not to crowd in front of the main stage. I request you, there is a room which 3 exit boards are visible on the left-hand side. Request you to kindly go inside those rooms and have your offline questions so that the panel will not be disturbed. Yeah. Now, this panel discussion is going to be moderated by Shireen Bhan, the managing editor of CNBC TV 18, with over 2 decades of experience in the field of television broadcast, tracking corporate, policy news, and events that define the business landscape in India. Please put your hands together and let's welcome on stage Shireen Ban, a known face, anchor and editor of the award-winning show Young Turks, one of the India's longest-running shows. And she's also the author of Young Turks, a book published by Random House India. And she has received several awards, and she needs no introduction. So put your hands together for Shireen Ban on stage, please. Hearty welcome to you. We now move on to the panelists. Mr. Sriram Vishwanathan, a founding managing partner of Celesta Capital. Please come over, sir. A global deep tech venture capital firm based in Silicon Valley, has more than 30 years of experience in technology, business operations, and venture capital. So put your hands together for Mr. Sriram Vishwanathan. He is an active advisory board member of the India Semiconductor Mission, an initiative led by the Indian government. I would now like to call upon Mr. T.K. Kurian, the Chief Executive Officer, Premji Invest. And it's the investment office sponsored by Mr. Azim Premji, founder chairman of Wipro. Request Mr. Kurian to please come over. An influential speaker, TK is a chartered accountant by training and has several technology patents to his credit. He has an abiding interest in strategy and history as an avid runner. Dr. Arogya Swami J. Paulraj, emeritus professor. I think you want to come together. Okay. Stanford University, is also the member of ISM Advisory Committee, former Indian Navy officer, and has got several short-term naval assignments against his name. Pioneered MIMO, the foundational technology enabling modern 4G, 5G mobile and Wi-Fi networks, which are crucial to the 10 trillion global digital economy. Welcome to both of you, sirs. Mr. Omkaran Nalamasu. Mr. Omkaran, are you there? Yeah, please come over, sir. Yes, he's a transformative business and innovation C-suite leader with extensive experience driving profitable growth at Fortune 150 Global Corporation and 100 investments in 19 countries. Welcome to you, sir. And finally, Dr. Apurva Ranjan Sharma, with 11 unicorns and 100 plus unicorns, is one of the pioneers of the startups ecosystem in India. He has over 20 plus years of expertise in startup ecosystem, in investment mentoring and acceleration. Please put your hands together for the name itself. We have Apurva, Dr. Apurva Ranjan Sharma. Welcome to you. Ladies and gentlemen, again, it goes without saying, only on the audience on the left-hand side are clapping. Please, all the audience participate and give a huge round of applause for our panel. And straight away, it's over to Madam Shireen Ban to take us through. Over to you.
Well, thank you very much. Good morning, ladies and gentlemen. It's wonderful to be back here at SEMICON India 2025. And I think over the last few days, you've probably gotten a sense of where things currently stand in India with the government's efforts to really open up this sector, to invite private sector collaboration, participation, and investment. You've also got a glimpse of what's happening in the startup world. And on this panel today, we intend to marry the two, what is happening with the private sector, what's happening in the startup world, add a VC layer on top of that, and really talk about the global opportunities and the global alliances that can be stitched together to take the agenda forward. We've got an eminent set of panelists here with us. I'm not going to waste any time and get right to the heart of what we are here to discuss. And it is particularly a privilege for me to speak with these gentlemen. I wish we had more women, though, on this panel, but it is a pleasure and a privilege to speak with these gentlemen because they really have been part of the ecosystem that we've been discussing, not just here in India, but globally as well. So without further ado, Sri, let's talk about the global alliance, the Global Investment Alliance, the India Deep Tech Global Alliance that you've decided now through Celesta to push forward ahead. What is the aim? What is the aspiration? What do you believe it could do? What is the needle that you hope to move with this?
First of all, thank you, Shireen, for having me at this panel. So as you've seen over the last few days, there's been a lot of positive feedback on this alliance that we've actually announced. That's sort of a testament to people recognizing the need for it almost. And so what we really try to do is to bring together a bunch of investors and corporates really with a view towards creating a platform for promoting and providing the catalyst for creation of this ecosystem of deep tech companies. There's lots and lots of investors, lots of opportunities for people to do things, in startup world for delivering groceries. But there's not that much effort and focus around deep tech, which is crucially important. So that's the first objective, to really create this ecosystem with broad support from the industry. Number two, we're also committed to actually working very collaboratively with the government. And as you know, the government has actually proposed a very large scheme of 1 lakh crore, almost like $12 billion, to go into the sector. We believe as industry, it's crucial that the government actually takes inputs from the ecosystem, from the industry, to really drive the highest possible outcomes that they can get with collaborative, feedback from the industry and entrepreneurs and investors and such. So there are two of these objectives: bring everybody together to drive the ecosystem forward and have a meaningful dialogue with the government, ensuring that they provide the right incentives, remove the right bottlenecks that exist for the industry, and do it very efficiently and with, ultimate speed, if you will. So those are the key objectives.
Those are the key objectives, and I will talk to Professor Paul Raj about some of the experiences we've had through the ISM as well as the Quantum Mission, where we've seen this collaboration take off, and we've actually seen capital being deployed by the government to promote Indian deep tech startups. But on the collaborative aspect, Sri, and I want to get a realistic understanding from you, given the geopolitical dynamics that we're seeing today, specifically with what is happening in the US, the issues of tariffs and so on and so forth, is collaboration going to be constrained on account of geopolitics? Because at the end of the day, let's be clear, capital is a coward, it goes where it feels safe. With the export restrictions, export controls, not knowing what is going to happen when, does that constrain the ability to collaborate?
Yeah, I'll respond in sort of three brief ways, right? One is, technology knows no bounds. Today, if you take your cell phone or your car or your microwave or whatever, you'd be hard-pressed to find most of these components coming from one geography, including, telecom equipment that comes from somebody else, the chips that come from somebody else, the display comes from somebody else, and so on and so forth. So there's no way in the current environment of the technology progress, any one sovereign can really hope to, become a leader. So cross-collaboration is not just an option, it's inevitable, number one. Number two, I think the current geopolitical environment drives the urgency for national security. So it's almost like orthogonal to the first statement. So you have to depend on resilience. You have to depend on self-reliance. So as a consequence, you have to find partnerships because there's an asymmetry in competence, asymmetry in capability. So you have to depend on collaboration so that you can become self-reliant. And the third point is, business as usual is over in the technology landscape because artificial intelligence is completely changing the rules and the pace at which innovation happens. So you've seen tens, if not hundreds of billions of dollars going into artificial intelligence that is going to fundamentally disrupt various industries, the least of which, arguably is, IT services. What happens to the core engine of technological dependence that Indian economy has could be disrupted pretty dramatically. So if you put these three things together, collaboration is important, self-reliance is essential, artificial intelligence is disrupting. So all of these things bode well for the need for a cross-collaborative platform like IDTA. And there will be many more, and there will be many participants. All of that has to come together, and the time is now.
Well, the time is now, and that is crucial. But TK, many things that Sri just spoke to us about, I would like to get your point of view on what happens to Indian IT services, because the existential question is back staring the Indian IT services sector again. But before that, on the point about collaboration being inevitable, do you truly believe that it is inevitable? If it is inevitable, what do you believe alliances like the IDTA can do to ensure that we actually go past the friction, that we amplify the momentum that we're currently sitting on? And what do you believe should be prioritized for an alliance like the IDTA today?
So, Sharon, a couple of things. One is that, technology goes through inflection points. And if you chase the past, ultimately what will end up happening is you'll go where everybody else is going and you'll compete like crazy. So in a way, the alliance itself is trying to address those inflection points and trying to be ahead of that. That's one. Second is that if you look at collaboration, is collaboration inevitable? I think the answer is pretty clear. We will compete in some areas, we'll collaborate in others. And I think there's enough room to collaborate today, because for effective companies to scale up in a country like ours, where typically risk capital has not been easy to come by, there are another two components which are very, very important. One is the ecosystem. You know, the ecosystem has to come together. And ecosystem is a big word, and it's, you know, badly used sometimes.
Very loosely used.
Very loosely used. But the academic collaborations which are required for this, the ability to fast prototype something, the ability to kind of have markets where you can deploy and test, those are components that we are very used to because we deploy money across the world. I mean, if you look at us together in this room, both of us together, I know both the numbers, I don't know the rest of the numbers, just both of us together would probably have AUMs, you know, well north of 17 billion. So that's a lot of money. And we also have ecosystems across geographies. I mean, we have an ecosystem in Israel, we have an ecosystem in India, we have an ecosystem in the US. So bringing all that together, both the academic collaborations as well as the technical groups together, I think is where the real value would come in.
You know, you talked about inflection points, and I want to talk to you about that because at this point, I mean, all the headlines are chasing AI and everything to do with AI. And the question is, has India fallen off the wagon as far as AI is concerned? And what could be some of the other inflection points that India could potentially look at where the herd is not there yet?
So a couple of things. One is that, you know, I think the foundational model of what we've seen today, that battle we can fight, but the reality is it's pretty much gone.
Should we fight that battle?
I don't think so. I think more and more open source is going to be available there, and we should just kind of jump onto the open source bandwagon and see what we can do with that. There's a second piece, and especially, you know, given the fact that most of your content that you have in the country, both visual content is lying on YouTube, rest of it is lying on Google or some other, or Facebook, it's very difficult for us to kind of replicate that in India. So jump onto open source, I think we are far better off as far as that is concerned. The second part, which I think is more important, is that as we pass this phase in the next 2-3 years, you would find newer models coming up. For example, right now we are seeing diffusion coming up, especially around text. That's a new area. There are very, very few companies jumping into that. There's a third area that's going to come down in another 5 years maybe, which is around neuromorphic computing. I think these are the areas where today we can take a lead. And you'd be surprised. You know, the original AI group, which I've been working with now for many, many years, there are about 40 people globally. 13 of them are Indians. And I think the talent exists. It's just unfortunate that they're not in the country and they've gone outside the country to actually do what they're doing today. So I think there's a big opportunity to actually bring people back, foster research today in the country, and work with academic institutions. And given what's happening in the US right now, especially with funding getting cut, this is the time to do that.
Well, this is the time to do that, and can we benefit from a possible brain gain as opposed to losing out because of the brain drain? That's a question that I want to put to Professor Paul Raj. And sir, let me start by asking you about that. To TK's point, can we bring back people to India, benefit from him? This is the time, this is the opportunity for us to do so. But also importantly, from your experience of running the ISM, what are some of the key learnings that we can take away for this alliance to focus on?
Thank you, Sharon. Can you hear me?
Yes, loud and clear.
Yeah. So let me start with making a couple of points. I'll come back to your question. So, you know, we look at ICT in our country. We have 3 layers. Right on top is services layer, which runs on the internet, and I think much of revenue is probably from the foreign companies, the Googles and the Metas, but we also have Indian companies. We do very well, and so that layer is pretty strong. We are doing very well. Then the network infra layers like Jio, Airtel, I think they have to, we have good participation from Indian companies, we're doing well. The bottom layer, which is called the core ICT layer, is semiconductors and systems. There, our share is very, very, very low. And that's what I think all this current effort is around building that share. So a goal for us, I think, in about 10 years should be about, let's assume it's going to be about 2% of global value-added revenue. Currently, the VAR is about 1.6 trillion. And let's say by 10 years, it's going to be 2.5 trillion. So 2% is 50 billion VAR. So gross margin is, say, 30%. We're talking about something like building $150 billion top-line revenue companies in our country in core ICT, semiconductors and systems. It's a long, long way to go from now, but that's the challenge in front of us. If not 2%, even 1% is still 75 billion. So it can be done, and I think involves many, many things. So just on ISM, I'm the chairman of the ISM scheme. We are very, very beginning, and in general, which I think is very relevant to the people and the folks here, is that the companies I see, we probably have funded about 30 or 40 of them, are not, semiconductors or core ICT is a global ecosystem. It's not one country. There's no such thing as self-reliance. Impossible. You take a fab, it's got something like 5,000 supply chain members all over the world. So even in fabless, we depend on so much tools from outside and so on and so forth. So essentially, I would say is that the knowledge of our startups of what is happening in the globe, who's doing what, and connecting with them to learn from that or be a part of it is still very small. So typically, a fund would come to me for funding, say, I'll build automotive radar, give me $3 million, I'll do it. Well, I'm on 2 companies in the United States. We have funded 150 million, and we are failing. So it's a very tough industry to enter. Our industries have to understand the global ecosystem better. That's one point I would say about ISM. But we are very good entrepreneurs, and also with mostly all VCs. I'm an academic. But the real thing to make me successful is that entrepreneur who can squeeze water out of stone, because it's extremely difficult to enter, very difficult. I know China, I know United States, full of failures. So it's very hard to enter. So we too will have to learn. It's hard, but we are people. I already look at Dhirubhai Ambani, who could go from petrol assistant pump to building this empire. So we need those people to come up. For every 100 entrepreneurs, one of those guys will do it for us. So that's my hope, to find those people. But don't underestimate how difficult it's going to be. The role of VCs is to provide the funding. And I think in general, I think in deep tech, it's not so strong in our country. There are quite a few, but not so strong. So I think this initiative by the government to invest from fund of funds and also invest in venture capital, some of them have US roots, is useful. And the US roots are particularly useful because they tend to know what's going on in the United States. So I think that knowledge is important, because I don't see that knowledge strong enough in our own country. So I think these are good things. Now let me come back to Shirin's first question. That was about what? I've forgotten now. Shirin, remember my first question?
I've kind of forgotten as well.
Okay.
Okay. Talent. How do we bring back talent? Thank you, Shri. How do we bring back talent?
Oh yeah. So that, so China took back about 30,000 people. At one time, I think about 15 years ago, Xi Jinping came to Beijing.
Sir, could you hold the microphone up, please? Thank you.
China has taken back about 15,000 people back from US in, I would say, in areas like related to what we are doing here, core ICT. And just one question. I've been involved with China for many years. So I think Xi Jinping came by, I think, maybe about 10, 15, 12 years ago. And he had a big event in the Bay Area, and to talk to the Chinese people to come back to the United States. And I was one of the speakers, because I've been I'm a professor in China, saying they should go back to China, and China has opportunities. So Mr. Modi should come to Silicon Valley, and I'll get a Chinese guy to tell them to come back. So, but in order to come back, we need to do a lot more things here. So the Chinese did a lot of things because, people know that it's, in general, it's the ecosystem well developed in the US, the opportunities of success are much better there. The coming back is a very difficult jump for them, apart from family reasons. So we have to do a lot more to bring them back. So it's good to say I'll bring them back, but it's not easy. And I think, so that's a different discussion. Therefore, and the question is, I think right now, even by the way, in the last 5 years from Stanford, maybe 10 profs have gone back to China. Nobody's come to India from the Indian side. So I think that is a great opportunity, but it's not going to happen by just talking about it. We need to do a lot more work.
Yeah, absolutely. It's not going to happen if you just talk about it. But, Om, let me take that point forward. We just heard there from Professor Paul Raj about the headroom for growth and the opportunities that exist. But the point now is, what do we put together as far as the prescription is concerned? What are the next steps that both the government, the private sector, the VC ecosystem need to focus on to ensure that we get to that 35 billion, 150 billion that Professor Paul Raj was actually talking about? What's next?
So we have certain richness in this panel. There are different folks, pure financial VCs, VCs who are focusing on India. I'll take the position of a corporate VC, how they operate differently. So we are part of Applied Materials. We are Applied Ventures, which is the corporate VC arm. And we have been a pure play deep tech company. We've been 25 years old, invested in about 100 companies in 24 countries. And we redefine the semiconductor technology as atomic engineering on an industrial scale. And if you begin to think in those terms, that's a fundamental capability to address multiple challenges facing the humanity. And quite a few of them are actually in the deep tech. And one of the things corporate VCs do, by definition, it is a strategic fund, and you're investing in companies where you can make a difference in collaborating with them. So out of the 100 companies we have invested, about $500 million, I would say about 90% of the companies that we actually deeply collaborate with them. So it is providing technology. And fundamentally, we are about going from lab to fab. If you can make a cool device in the lab, maybe dozens of them, what we typically like to do is to work with them so you can come up with high volume manufacturing compatible technology, so you can go from tens of devices to billions of devices in creating enterprises. And so there are some examples about similar things that are done elsewhere with the fund of funds to be able to attract the talent, have the boots on the ground, work with the entrepreneurs, work with the universities, and look at those nuggets and collaborate with them. So we have done 3 funds, 2 in Korea and 1 in Taiwan, with the organizations that are part of the government, very similar to the fund of fund concepts. With our Korea fund, we have actually invested in 6 companies, 5 have gone to IPO. And so this is about enterprise building. And coming to the infrastructure you were talking about, so the fund of funds attracts the VCs into the country, but we should also be thinking about vehicles like Star Exchange in Shanghai, where you are providing liquidity for the companies, technology-focused companies, that they can go to IPO. So as a consequence, they are grounded in the country, and they're building the organizations. The second thing the VCs also bring, and I'm an academic like Paul, but I also happen to be
also a former VC.
Former VC vice chancellor, but that's a different kind of VC. But the point is that you bring the talent and you nurture, you mentor people as a result of a mechanism like that. So what you essentially need to create is a virtuous cycle. We typically say back in the United States, if you have a couple of students in the university driving Lamborghinis because they had a successful exit, that does a lot of good with respect to entrepreneurship.
Well, we've started to see successful exits here in India as well. The IPO market has been buzzing. 2024 was a record year, and we've had a whole host of new age tech listings, but not deep tech necessarily, but consumer tech listings have taken place. But that's a enviable record that you spoke of there. 4 out of 5, or 5 out of 6 companies IPOing in Korea, the companies that you're backing and supporting. Apurva, let me come to you now for how you'd like to add to the conversation and the points that we've heard so far. Through the prism of your own investments, you've invested in a bunch of unicorns and many unicorns, as we just heard, but what's the big nugget there in terms of lessons that we need to build on?
See, India is currently on the cusp of, I will say, deep tech revolution, right? Because in the last 2-3 years, we would have looked at close to 2,000 companies and invested in 35 of them. We've never seen, the kind of technologies which are coming now, and these are very high growth companies, potentials. And these are coming from the smallest corner from the India, not just the metros, So what I understand, the deep tech is a complex engineering startup. And, these are companies which are creating something very, very innovative. So it has around 9 to 10 years to reach to a certain level. India at the moment do not have that environment to foster them beyond 100 million value. And this alliance, of course, is bringing capital access to capital, as well as access to corporates, and as well as the knowledge, like Professor Powerhouse said, a lot of things which has happened in the valley and other parts of the world. That will be actually very helpful for the companies. But I want to tell you one thing, that, not necessarily the deep tech which has been successful in the US, India has its own focus because we have our own priorities. For example, advanced manufacturing is one of our priorities. I'm seeing very, very good startups in advanced manufacturing, in advanced materials, especially. That's our requirement also. The companies who are replacing steel, the companies who are replacing cement. And we are saying, advanced manufacturing, it's like a lot of IP-driven companies there, which are making into precision manufacturing and all. Yeah. And defense especially, because that's our current need after this Operation Sindoor. There are companies we've invested where, they are seeing the borders from here 250 kilometers using deep tech AI. So, there is a need for global investment and global knowledge transfer, these companies to become big. And that's what we, as a startups in India, looking at. And that's what this alliance can probably provide. And that's what we see it.
Well, that clearly is the part of the plan as well as the priorities. And, I was having a conversation with one of India's most prolific investors, also a startup founder, Sanjeev Bikhchandani, yesterday on this issue of deep tech investing. And he said, for now in India, the concept of deep tech investing is if you need a PhD to be able to tell you whether you should invest in that company or not, it's deep tech. Tomorrow, if you don't need a PhD to tell you, it's not deep tech enough. But, that was in jest. But Sri, let me come back to you now. Speed is of the essence, time is crucial, and I think that's what everybody seems to be alluding to at this point in time. There was a meeting that happened with the Prime Minister here at SEMICON, where the government is soliciting feedback in terms of the pain points, the areas of friction that need to be smoothened out. For this vision that has been painted by each one of you on this panel to actually be a reality, what needs to be done today?
It's actually a very good question, because this is exactly what the Honorable Prime Minister asked yesterday at the round table when you had a whole bunch of CEOs from ASML to KLA-Tencor to others. I think there are you have to frame this in two parts. One is, okay, this all sounds great. It sounds like motherhood and apple pie, fantastic. How do you make sure this happens? That's one question. The second question is, what can go wrong, right? I mean, you really have to pin it down, right? So the first question, what do you need to do to make these things really happen and accelerate? I think there are two parts to that. One, the government is not a picker of winners and losers. As much as the government is interested in supporting, the government shouldn't decide whether the fab that comes about is a 5 nanometer fab or 4 nanometer fab or 2 nanometer fab. The market has to decide. Because the government doesn't have the resources.
But that's not how the support and the subsidies are designed. For instance, you're backing specific technologies. You're batting for EV versus hybrids. I'm just giving that as an example in the automotive sector. So in a way, the government is picking the winners and the losers, right?
It's different. Even in the US, there's this concept of ICET, critical and emerging technologies,
yeah.
right? Which is okay for the government to set priorities and say these are fundamental areas where, as Paul said, you know, self-reliance is almost an impossible. It's like perfection. It's a good goal to try to aspire to get to, but you'll never get there. Self-reliance is almost impossible in technology. So the government can actually say these are 3 or 4 critical areas that we need to focus on. My point is, don't dictate how that evolves. Let the industry do it.
Right.
So the government should provide the, you know, it's invariably what you measure improves. And you put the right incentives for the right outcomes, the outcomes you intend show up. So the government should really ensure that they are providing the right incentives and they're measuring the right metrics of how effective they are. That's what they have to do to ensure that this happens well. Now, what can go wrong? So what can go wrong is that when you actually, it's like peanut butter. If you spread your interests all over, it just becomes a lousy sandwich. You have to really think about it and say, how do I focus it on a few areas and not try to do everything? If you look at the sectors of focus, you know, everything from, you know, putting a man on the moon in space and having our own indigenous rockets to robotics to quantum to biology to everything else, that is fantastic as a laundry list, but pick 5. Pick 5 areas and put your muscle behind it, because as TK said, it's easy to be a follower. It's hard to be a leader, and you cannot be a leader in 50 areas.
Yeah.
Just pick a few. So that's the reason why many of these programs could end up not being effective, because you're just spread too thin. So that's the one thing that our recommendation has been, to just focus, 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 and then I think you can measure it better.
You know, TK, to pick up on the second point there, and I think that's an important aspect that that Sri brought up. You talked about the experiences that you've had with building out these ecosystems or being part of these ecosystems in the US and Israel, for instance. You know, what do you believe we need to be mindful of as we go about this? Also, the prioritization aspect. You know, I think Sri is absolutely right. How thin do you want to spread yourself? Because we do have limited fiscal room and fiscal space. It's not as if you know, we've got a never-ending tap as far as capital is concerned. So what do you believe should be the priorities that we bet on?
So, you know, I'll just give you an example of how some other countries have done this, and maybe we can learn from that. So if you look at China, for example, at the bottom end of the pyramid, where there are thousands of companies working in different areas, the Chinese government does not interfere. They allow companies to compete and probably die in the process. But the few that stand out, which they believe are truly world-beating, those are the areas that they pick up and say, we're going to put our muscle behind it. You look at batteries, for example, today, or rare earths, or permanent magnets. They've just kind of completely owned the supply chain end to end. When they started it, it was something the West was not interested in, for pollution or whatever other reason there was in terms of rare earths. But now they have a dominant presence there, and they're not going to give it up, because there's nobody else in the world. So you should allow extreme competition at the bottom, and then decide where you want to focus your attention. The second, as far as China is concerned, which is positive and also not a great thing for us, is if you look at the government in China, most of the people who sit there are engineers, especially in the Politburo and in the central committees. In India, most of the people who sit there are not engineers. So to that extent, the ability to understand technology, at least at the government level, is significantly higher. But it's not a problem that can't be solved, as long as there are enough engineers in this room and outside who can kind of add to that. So I think it's a question of tapping into the population that can help you achieve the objective, which comes back to the ecosystem. Ultimately, you know, for example, if we go to a new country, one of the biggest things that we do is we build academic, you know, alliances. That's very important for us. Because if you have to assess new technology, you can't do it on your own. You understand markets. You as a VC have to understand markets well. You have to understand evolution of markets. If you start getting into the base level technology and how that's going to work for you, you will get stuck to one particular industry. So we build those collaborations with people on the marketing side, with people on the academic side, and people who've actually worked in that space before, because they can tell you much more about the industry than you can ever understand sitting outside. So that's extremely critical for us to build in the alliance. And each of us have to pick the areas of expertise. For example, us as Premji Invest, we have enormous expertise in AI. Today, we are probably the biggest investor out of India in the AI space globally, by far. And you know, everybody from the top names that you see globally, in some form or shape, we are there. So from that perspective—
What's the AI AUM for you?
Our AUM overall is about 15 billion. If you just take AI itself, it'll probably be in the region of about 2 billion, 2.5 billion.
Okay.
So it's pretty substantial because it started in the past 2 years. But just to give you a sense, that's how we built it. And I think that's what is important for us to do. In India, if you just pick up AI, we may not have foundation level technologies available here, but you go one level above, the amount of work we do here for global giants, the process knowledge sits in India. We should really exploit that to a hilt. Because if you talk about the transition from IT services to something new, this is the area, because the application knowledge and the knowledge of the particular area that people are working on, that knowledge sits in India. Almost 3 out of 5 healthcare claims are processed out of India. The US doesn't have it, that knowledge. So that's what we have to really exploit here.
Well, yeah, and I would imagine that that's the transition that Indian IT is going to have to look at this point in time as well. But, you know, Professor, let me come to you on the points that both TK as well as Sri made on the role that the government should play and the role that the government should not play. You know, to Sri's point that the government should not be picking the winners and the losers in this space, let the market or the consumer at the end decide. You know, the government likes control, and especially when it's giving capital, it likes to ensure that it has control. In your experience, again, with the ISM and what you're seeing happen now as far as, you know, the quantum mission, et cetera, is concerned, what does the government need to be mindful of? Because now the government is also picking up equity stakes in some of these companies.
I think a very good question, Surin, and a very good points made by my co-panelists, so all excellent ideas. To answer your question, I think you know, I would just say that the government's role is largely to create an ecosystem which would allow entrepreneurs to come up and flourish. And let me say a few things that we might do. One, of course, is the government can, actually writing checks. In fact, the government wants to write checks directly to companies. It doesn't have the knowledge to do that. So in some sense, the idea of fund of funds, of going through second-level fund managers, a good idea. So I think that's one good idea. The other thing that government can do is really an important thing and opportunity now is to, because to build a company here, remember anything we touch is really a global technology. We take an iPhone, it has technology coming from all over the world. So it's a global ecosystem and we got to join it. And bringing back people will be very important. I think there, of course, is not going to happen with our startups. The government has to play a big role. I think bringing back talent, and I think now there may be an opportunity. The other issue I would say for the government to play a role is in, again, connectivity. For example, much of the startups that I'm involved with do not have mentors from countries which have this. For example, if we take an automotive radar, or you take an AI chip, we can bring board members and mentors from US or from Israel where it's going on. China may be difficult. We do not have that. So I think creating an ecosystem is where the government can do and can do much more. But they're beginning to do things. And I would say certainly the fund of funds is a very important part. But again, my message is that this is not about make in India for India. So we have to join the global ecosystem, get a share. I think when the Prime Minister says Atmanirbhar Bharat, what he really means is we buy about $70 billion of core ICT. We should produce $70 billion ourselves. Some of it we'll export, or maybe more of it we export, some of it we'll buy. So we become a part. But today we're not a part. So I think government can do many things, but I think it made a good start. And we have to thank the Prime Minister for his encouragement and assistance.
No, and I think that's a very important point that you make, that when we talk about self-reliance, we're not talking about an isolationist or an inward-looking India. We're actually, at this point in time, it is a sense of urgency that we need to connect with global ecosystems across different sectors if we really want to be part of the global supply chain. And that's the point that I want to put to you, Om. You know, a lot of the conversation is also focused on the need for supply chain resilience, for instance, and that has become even more critical given the geopolitics that we're seeing today. From that perspective, how does India become more and more integrated as far as global supply chains are concerned, and the things that we need to be mindful of from a resilience perspective?
Yeah, first of all, I'm very excited to be here. I didn't come for the last two ISMs. Just looking at the vibrancy and excitement and participation, I think is very contagious. There's certainly reason to believe that India is on a path to become a semiconductor player. We would have advanced chip fabrication, advanced packaging in India. But to build a sustainable industry, you really need to have a supply chain that goes hand in hand with the manufacturing ecosystem. So if you're looking at a semiconductor fab, there are equipment makers, there are materials providers, there are gas provider. So there is that entire ecosystem that is going to have a multiplicative effect on the whole economic development. So many of the companies, including ours, are here basically is thinking about building supply chain in India. Incentives bring companies to start manufacturing. Supply chain is actually going to ground them in giving them basically sustainability and grounding them in the country.
You know, if we had a game for how many times ecosystem has been used at SEMICON 2025, we'd all walk away very, very rich from this. But Apurva, I want to come back to you again now. Where are you, besides, of course, being part of this alliance, where else are you going to be putting your capital to work?
See, space tech is something, and space tech, advanced manufacturing, defense, and health tech, probably. These are the areas where we are looking companies from deep tech, and we are really seeing amazing companies coming out from India and smaller towns. We invested in close to 52 cities in India, around 500 investments which we made in India, and and these are the areas which are seeing a lot of innovations. I mean, I invested in a company which is into health tech, AI. They got 67 patents, Partex. And invested in a company into defense, which is optimized in India, 37 patents. A lot of high quality, good companies are coming into this. And we are looking these companies to get a lot of access from the global markets to this alliance. And that's what we are here.
Well, not just access to capital, but also access to the network that this alliance can provide. We've got about 5 minutes. If there is a specific question, then please raise your hand and we'll try and get a microphone across to you. And hopefully we'll be able to hear what you have to say. There's two there. Sir, request you to stand up so they can bring the microphone across to you. Okay, we'll go to that gentleman first and then we'll come to you. Thank you very much. Go ahead. Maybe it's switched off. I don't know. Can you try again? Yeah.
Hello.
Yeah, go ahead.
Good morning, everyone. I have two questions. Many industries are growing in India, but students have skill gap. How can we overcome?
Okay.
And second question, if Indian founders come from USA due to high tariff, will they migrate again? If USA reduces tariff, how can we stay them in India?
Okay. Well, we don't know what's going to happen with tariffs. Only one person knows, and he hasn't tweeted so far this morning. So we'll have to wait to see. But on the talent and the skill gap issue, Sri, you want to take a shot at that?
Well, I think Professor Paul Raj and Dr. Om are far more qualified, given the fact that both of them have been academics.
Yes.
And I think they have some phenomenal programs to work with the IITs and ISCs and all of that. I think there was a comment about ensuring that there is a steady supply of skilled labor. And I think there has to be a national priority for that.
Absolutely. Yeah, Purvi, you want to
So
make
there's a
point?
program which is on Saturday getting launched here in Delhi. That's called Campus Tank. All AICT institutions, students who are becoming entrepreneurs, the large scale, they're being shown to the investors there. So that for a student, they should be part of that.
Okay.
It's a very huge program at the national level.
And it is
with the support of the government, Department of Science and
It's a
Technology
pressing
support.
need that requires the government and the private sector to also to collaborate in a much meaningful and robust way. Professor Paulraj, do you want to come in on that?
I just want to say about bringing people back. I think I wouldn't worry about current geopolitical situation. We have to convince them they're going to make more money here than in the United States, and that is possible. You convince them, they'll come. Om?
Yeah, from my perspective, I think there are three things you need to create this primordial soup to create a Silicon Valley, right? And the first one is the availability of capital. Certainly some interesting things are taking place in India that would allow companies like ours to come and set the shop here. The second one is the infrastructure. This is where government can play a role. If you go back to the United States, almost 25, 30 years ago, they created this national nanotechnology infrastructure network in about 20 different universities, state-of-the-art facilities. So, students have access to state-of-the-art capabilities. And the third one is essentially talent. This is where role models are important, mentoring is important, and that needs to be nurtured. And actually, there's a very interesting program in the United States started by National Science Foundation called ICORE. And what it essentially does is mandates that university-developed R&D need to find a way to have a commercial impact on products and services. And they actually train the students, the postdocs, people who actually get the grants. So there are quite a few good role models that are out there that could be emulated here.
Absolutely. Many templates there that we could learn from. There was a gentleman there who had a question. Yes, go ahead.
Hey, good morning. Thanks for all the valuable information. So there was a time when there was a clear demarcation between a chip company and a system company, whereas today it is not there. In fact, most of the system companies are trying to build their own chips to keep their price points low, manageable. So in that context, how do you see the future of a chip-making startup?
I think you're absolutely right. Large industries have a tendency to be vertical, and then they end up going horizontal. This has happened in the computer industry. IBM used to make the chips, they make the systems, they make the software, they make the services and everything else, only to find over a decade, Intel made the chips, Microsoft made the software, and Oracle made the database, and so on and so forth. And now what you're finding is back to almost to the reversal to the mean. Everything is getting back to vertical. If you look at Microsoft or Google, is it a software company or is it a hardware company? So inherently, everybody is wanting to have greater control and architectural freedom at the large company level, right? So that's the trend. NVIDIA has got, more number of software people in it than some of the largest software companies, and vice versa with hardware. However, when you're a small company, depending on private capital, you cannot do it all. I think I continued, and I'm sure, Om as an investor and TK and myself will tell you, just focus. Don't try to, boil the ocean. It's much better to have a greater share of a smaller market than hope to get a smaller share of a very large market. Because that's great. But, from a product and technology standpoint, you just cannot do it all. So you have to really be narrow. And as a semiconductor company, just do some narrow things and become good at it, proficient at it, and become profitable at it. Then you can expand.
TK?
I just give you a very simple example. And Meta, why do you think Meta took Llama open source? There's a very simple reason behind it. The day Apple shut them out, from their own ecosystem, Meta decided that it could not have reliance on Apple, and it couldn't depend upon the Apple ecosystem to give them anything. So the reaction to that was, let's go out there and get the developer ecosystem to work for us. That's why Meta took Llama open source. And so that same thing exists for a company like Meta. If they couldn't do it, it's very unlikely that a small company out of India is going to take on the whole world. I mean, it's great to have that ambition, but not exactly the place where all of us as VCs would put our money behind. So I think that's an important point that Sriram just raised.
Yes, Om.
I'll give you what an entrepreneur should be thinking about for your question. They should go where the money is, where they can start an enterprise with lower risk.
Start an enterprise at lower risk, and these gentlemen will put the money behind it. Where our time is up, we would have liked to continue this conversation. Okay, one very quick question.
Yeah, this is Shivanand. So even Google CEO says hardware is not easy. So this is my baseline I want to put. And now when we talk about design startup hardware, is it audible there?
If you can just move a little closer. Yeah. Yeah, go ahead. Go ahead, go ahead.
So even Google says the hardware is not easy. Now, if we are talking about SEMICON as a strategic and all, without India being a chip designer and putting their logic inside, it's not really going to make this what foundation or whatever we are trying to talk strategically. That's not easy. So now when we are talking about the talent in semiconductor, especially chip design is getting higher, even acquiring of junior resources is getting very costly, especially post-COVID it's become tripled the hiring. And the technology, if you see the technology is a lot dependent on EDA tools, and the cost of the tool chain and total is high. Now, what are the strategies for the chip designer startups or as a founders, how they should align equity? Because the cost involved towards that and proportion you want to claim, like which is not a software, you can claim something and you can have higher stake, whereas here the cost involved is very high and you are working more based on a talent. How the equity strategy and the founder combination, and typically to sustainable development and make the chip, because any chip you take, at least you will spend around 300 crores in Indian context. So how you would like to advise from the EVC point of view or experienced people who are done the startups and all?
Sure.
Thank you.
Thank you. TK, you want to try and address that?
I didn't understand the question at all. I'm very sorry.
It's hard and expensive to make chips in India. So as a founder, looking at this, what would your advice be?
Well, you know, like I said earlier, it's a place when you're a startup founder, there are only two things you're looking for. Number one, money to kind of fund your enterprise, your idea, of course, money to fund the enterprise, and probably markets. These are the three components that have to come together for you to succeed. My sincere advice would be, it's great to kind of run at the wall, but all it does is you end up hurting yourself. So pick spaces, pick niches that you believe you have where the market opportunity exists first and work backwards, rather than looking at a whole gamut of seeing how can I kind of break through the glass rather than just walking out of the door.
And I think that's a very important point. They're often underappreciated, but the profit really lies in the niches. Gentlemen, we wish you the very best of luck with the Deep Tech Alliance and your aspirations to fund Indian deep tech startups. Thank you very much for your time. And thank you very much for all of you coming together and showing us that collaboration is possible and hopefully will be inevitable in many, many significant ways. Thank you very much, ladies and gentlemen, for joining us here this morning.
Thank you very much, all the esteemed panelists. Thank you, Ms. Shireen Bhan, for moderating this session. And we would also like to thank Mr. Sriram Vishwanathan, Mr. T.K. Kurian, Professor A. Paul Raj, Mr. Omkaram Nalamasu, and Mr. Apurva Ranjan Sharma. Let's give a round of applause, ladies and gentlemen, for this wonderful, thought-provoking session. And of course, they will be available offline, and a couple of questions can also be posed to them offline. Thank you very much. We now move on to the next session, the last session prior to the lunch break. And this is another fireside chat on challenges and demand in the semiconductor industry to explore the current challenges faced by the sector and the demand for new technologies and solutions. Once again, panelists, please move to the room on the left-hand side, please. This session will be moderated by Mr. Sanjay Gupta, the Chief Development Officer and Global Head of Engineering, L&T Semiconductor Technologies. Before Sanjay Gupta comes on stage, a couple of lines about him. He's a seasoned semiconductor technology professional with more than 29 years in the global and high-tech industry and holds distinguished experience in the semiconductors, embedded software, and electronic system design. He's a technologist at heart and holds multiple US patents and numerous technical and business publications. Well, ladies and gentlemen, he has been working extensively with the government bodies, industry stakeholders, and academic institutions for advancing the Indian semiconductors and electronics ecosystem. And also, he has also been a key industry advisor and stakeholder to government MITI for various policy formulation and launches and an active member of various startup incubator forums. So please put your hands together and let's welcome Mr. Sanjay Gupta on stage, please. And joining him in this fireside chat is Mr. Jan Krolls, CTO, Cient Semiconductor. So let's give a round of applause for Mr. Krolls, who received his MS degree in electrical engineering way back in 1992. And in 2018, Ansem NV became part of Cient Limited. He's currently active as a Chief Technology Officer, a spin-out of Cient established on April 1st, 2025. Hearty welcome to you, Mr. Jan. Kindly take your seat. And finally, Dr. Naveen Yanduru, CEO of Axiro Semiconductor, is, of course, a fabulous semiconductor company specializing in high-performance RF and wave integrated circuits. And he has held executive and technical leadership roles at various organizations and is the inventor of 26 US patents. So please give a round of applause for Dr. Naveen Yanduru. Kindly take a seat. I'm pretty sure this will be a very engrossing fireside chat before we all break for lunch. I would now straight away hand over the session to Mr. Sanjay Gupta to take us through. It's over to you, sir.
Thank you very much. I hope I'm audible. And thank you, all the audience, for this last but very interesting, I'm sure. The discussion that we have two very eminent and the newcomers in the space of semiconductors. While I represent L&T Semiconductors, which is also a startup within the umbrella of L&T. And I have my two co-panelists today who have a very similar kind of a background. They are from very established companies, and within this year, their semiconductors journey has started. So this topic is very relevant, that as we are getting into India's journey to make it semiconductors powerhouse for the world, what are the challenges and what are the opportunities that are ahead of us with respect to the demand? And we had very interesting sessions that happened yesterday and today about we have the capability to build some of the finest chips for the world, but eventually who is going to buy them? Do we have the customers lined up? Do we have the ecosystem ready to consume them? And we all discussed about the cost of development of one chip. Unlike a software application, the cost of development of one chip can anywhere range from $5 to $10 million all the way till $50 to $100 million, depending upon which kind of chip you are targeting. So the initial investment is so high, and that is why this question is very relevant, that where the demand is going to come from. Not long back, there was a point about the supply, how the supply is going to come from, and thanks to Government of India, MITI, and the entire machinery that is working, we have more than 10 semiconductor entities, be it upcoming fabs or the OSATs, which are coming up in different parts of India. And that is great. Everything has happened in last 3 to 4 years. So we are kind of getting there from the supply side. And that is where I am going to ask my first question to my panelist. We have Dr. Jain. He's a CTO of Cyient, and Dr. Naveen, CEO of Axiro Semiconductors. So my first question is, from your vantage point, where this demand is going to come from, not to mention we have many sources. First source is obviously direct customers. They can be local customers, they can be global customers who are directly going to give the contract to buy the chips. The second source could be the EMS companies. We have a lot of EMS companies which are doing the contract manufacturing, and they have kind of flexibility to pick up the semiconductor supplier. And then obviously we have the startup ecosystem that is flourishing, not to mention the intermediate tier ones, which are supplying to the OEM. So maybe starting with you, Dr. Naveen, what is your starting point on this very basic question?
Thank you, Sanjay. Hope I'm audible. Thanks you all for coming to the fireside chat today. It's a very relevant question, and many people have already mentioned that India is huge from a market point of view. We consume a lot of electronics as a nation. The challenge is, how do we dip into this enormous demand that is fueled by the great country we are? And it's not an easy question to answer because, ecosystem is a word that is often overused, but there are a lot of players that come in when it comes to putting a semiconductor IC into a final end customer equipment, be it a phone or IoT device or anything else. Yes, having all of these pieces being developed inside the country will help, where you have the foundries, OSATs. Now a lot of OSATs have come up to speed. Product companies like Axiro, as well as OEMs and tier ones, so that we can rub off of each other's experience and figure out what is the device, what is the chip we need to put into the market that the market can accept. But be very careful. Even if we develop the entire ecosystem inside the country, if the product by itself, each of these component or each of these constituent ecosystem parts, if it is not competitive by itself, if you don't have a competitive foundry and a technology node, if you don't have a competitive OSAT, if you don't have a product or a part that you can put on the table that can fly on its own merit, everything is meaningless. That's what is ultimately going to fuel the demand. If you have a compelling product that you put on the table, how much ever we talk about the ecosystem, how much ever we talk about the government support, how much ever we talk about the demand that we have as a country, if the constituent products or the components or the foundries are not competitive, game over, period. And that is very important to keep in mind. If you see Taiwan, for example, small country, but they fuel a lot of the demand across the world. Why? Because they make compelling products. And that is the one message that I want to give today. If you don't make compelling products across all of these verticals, foundry, OSAT, products, modules, you take it, and ODMs, OEMs, game over.
Thank you. So, Dr. Naveen, your point is, no matter what, the product has to be globally competitive from all angles, otherwise you cannot survive, which is a very valid point. Dr. Yan, from Cyient Semiconductor's perspective, you're building a lot of mixed signal chips and entering into this niche market. What is your thought process going on in your company?
Yeah, on this topic, I fully agree with Naveen. So it's really, you have to be have compelling products which are cost competitive. That is, in the end, the only thing that counts. The only thing of what I want to add to that, and that what we see as a company, which as a fabless AC company, is that what Naveen also said is that let's not forget that the India market as consumers is huge. Yeah, and India has also some very strong OEMs. Strong OEMs in automotive, strong OEMs in white goods, in industrial applications. And what we see and what's actually happening today is that apart from, let's say, standard components that they use, these OEMs also have a need for custom solutions that are optimized for the India market. So a car made by an India OEM is not the same as a car made as a German car. Yeah, it has different needs, it needs a different chip, and we see this. We have developed, as an Indian company, we have developed a specific version of an automotive chip for an Indian OEM, because it needs to be tailored to the needs of the market. Yeah? And this gives opportunities for India, because obviously such Indian OEMs, they will see extra benefit if they can work with companies in India that understand their needs, their markets. And we have other examples. We have developed recently like a smart electricity meter chip, really optimized for the India market, because again, the market is huge and it has its specific own needs. So there is the opportunity to do this.
Absolutely, I agree. Indian market demands its own challenges from whether it is cost or power. Indian consumers are the most demanding and discerning consumers. So the innovation level I'm talking about has to actually go up a notch. You know, do not underestimate or don't underestimate the power of the Indian consumer.
Exactly, and so they have their specific needs, and there is, apart from a wide range of standard components that is needed, of course, in the India market, and it's consumed in the India market, there is also optimized solutions for the India market needed. And that is a good starting point, and we see that happening today.
Sure, thank you. So your point is it has to be optimized for the Indian and the local customers, and that will kind of make it a sweet spot. But very important point linked to that is Indian market is one of the most price sensitive markets in the world. So if you build the best, most optimized product, which is globally competitive, but it is not meeting the price point of Indian market, then it is a very relevant challenge that I believe companies like us are facing as we are entering into this space. And there are reasons for that, because at this point in time, while we are scaling up as fabless companies, there is a dependency on global suppliers, whether it is the wafers, it is a fab, processes, OSATs, because Indian ecosystem is yet to come to that speed. So how you are trying to cope up this price challenge linked to your previous point?
Maybe I go first? Yeah, okay, thanks. It's a very good point. As a smaller companies and new players into the market, we do face some headwinds of sort, because our partners like foundries that we use outside of India, as well as whether it's CAD tools or whatever, we get a little bit of a disadvantage, or more than a little bit of disadvantage from pricing. That is a fact of the matter. But again, I feel it's the story. I think the previous panels were also talking about the story you sell to these vendor partners on how we are going to be big one day, and the relationships that you have with the key folks out there in these companies. These come in very handy, and that's what I have used. Is I call up my key counterparts in these vendors and say, hey, you know, we have worked in XYZ companies, Qualcomm, Samsung, Texas Instruments, Renesas, whatever, and now I'm here and we are going to make it very big. Look at what Modi ji is saying, etc., and give me the same price that you have been giving at some of the bigger behemoths that you have been providing. And more often than not, I have been successful.
So your point is perseverance with the same suppliers to somehow convince them that today we may be small, but tomorrow we are heading for a big growth.
Exactly.
Valid point. How about you, Dr. Jens?
Yeah, I can fully confirm that. Don't despair. This is possible. Yeah. Maybe as a starting point, you will focus on some niche where there is and you'll carve out a piece in the market where there is some room for margin, and you can buy your wafers at a bit higher price. But it is possible to really convince your suppliers and show with that beginning point, show your potential and get the relationship, get the pricing you need, get their confidence and move forward. And yes, getting to the lowest price point is very important and is always a challenge. And this is nothing specific to India. If today you talk to a US company having standard components in some area like power management chips or something like that, they will say like, we are getting competition from China and they're undercutting our prices and how can they do this and we have fierce competition. Everybody has these challenges, and yes, don't despair, work hard on it, and it's possible.
Okay, so basically the consensus that is coming out is price is going to be a challenge no matter what, but this is a necessary evil we have to get over with the focused customer approach and the focused design approach. Taking this lead further, right? Yesterday we had a long, very interesting debates and conversations around if we need to be a product nation, if we need to be a semiconductors product nation, one of the mindset that we need to shift is move from a service mindset into a architectural mindset, where we can be more creative from understanding customer requirements, translating them into what kind of architecture it will lead to, which is within the quote-unquote price bands, quality bands, right? We can build the NVIDIA of a chip, but if it is not going to be more than $1, right? You cannot sell it for $1,000 for a $1 application. So that is one of the challenges we are going through. How to get there's no dearth of talent in the country, but to create a talent which can have the mindset of product design, product creation, not from service, but from architectural perspective. And I'm sure you have the similar challenge, so would love to hear how you are handling that design challenge.
It's a very good point again, Sanjay. I think that's what we are always fighting against. But I have to say that Axiro comes with some advantage here. So it's kind of unfair because we have all of that already set up as a company because we have strong legacy over 12 years that we have been developing these chips and have strong relationship with our customers. So we are always with our customers whiteboarding, whether in Europe or in US or even in Japan and China. So we have those relationships already set up. So the playbook that we're playing with Axiro is a little bit different than everybody else who are kind of starting up from ground up. We're already we hit the road running. So we have all of those relationships, we understand, and we come with that thought process of circuit level engineers have to solve a system problem. That's a very important revelation. You cannot just work in your box. You have to understand what your customer's pain point is and use your circuit level innovation to solve that pain point. And that's where you make innovative and differentiated products. Further, it's very important for the development teams to be very conversant with every aspect of technology. Because if you start with the wrong technology, you're stuck. How much ever innovation you put on it, it's not going to get going, right? Duck is a duck and eagle is an eagle, right? Eagle cannot do what duck can do and the duck cannot do what eagle can do. So you have to be very conversant with all technologies in the context of RF and millimeter wave and mixed signal. For example, Axiro team is very well conversant with all technologies, whether it's gallium arsenide, gallium nitride, CMOS BCD, RF SOI, silicon germanium, and that comes in very handy for us. And when we layer it with very good understanding of the system and our own circuit level innovation legacy, we come up with parts that you can see on our website that are one of a kind.
Great. Dr. Jens, your views on that?
Yeah, as you said, India has the talent and is actually very well placed to make that jump, which I believe now is a small jump because the design capabilities are for sure here within India. There is no doubt about that, of course. There's a very large community with all the skill sets at the highest level within India. But doing a product is more than just a design. Yeah, and that is this last step. Well, this step that needs to be taken. It involves, of course, the system architecture work, the sales work, the purchasing work, and so on. But also there is opportunities. There are capabilities here that come from companies that also have already done these things in India. But also I do see a potential for the Indian community outside of India, which has for sure, this is a very large community which has these skill sets, to do some real innovative startups out of India that can convince these people to join the design talent that's here, to do innovative work and to create real value and make money here in India, either combining, working together with the people outside of India, or having them come back to India to do this. And that last step, the potential is there. It's really very close to, so here and there are the opportunities.
I have a rebuttal on this one. I know a lot of people are speaking about Indian community, Indian engineers, and so on, but I don't know what the whole fuss is all about. You know, X0 is a global company. It's an Indian company, but we have sites in San Diego, California, in Europe, even in China, you know, and my CTO is not an Indian, and you are not an Indian either. So I think there is not really, you know, Indian company doesn't mean Indian people necessarily, right? You know, when we talk about Chinese companies or Japanese companies, they have sites everywhere in the world, and that's the mentality we need to be thinking about. You know, we treat our Bengaluru site on the same level as our site in San Diego, for example, right? So to me, in my opinion, we are kind of pigeonholing ourselves, thinking in the context of India, semiconductor, you know, developing as a semiconductor behemoth or whatever. We don't have to think India-centric. We can be global mindset.
So I think that's a very interesting point, and as you rightly said, in some way you have advantage of having a pre-global presence. But you know, just to make it more controversial, 90% of the Indian startups which are coming up, right? They are like 2 people company, 5 people company, based out some remote place in India. May not be a tier 1 or tier 2 city, right? For them, it is actually impossible to have a global sites with multiple senior people around the world. So the realistic test bed for India is actually the people who can scale up with the global ambitions, but for the first few years, they will be completely on their own in the Indian rugged environment, and I think that is one of the challenges that probably we are throwing it out in the open.
No, I agree. No? Thanks for straightening me up on it. Yes, we need to keep the larger context in place here. Yes.
And I can tell you one of the biggest challenges that most are Indian startups, and that is I'm leading into the startups now. Most of the startups are facing is, you know, huge firepower, huge dreams, but no exposure. How to create a product which can be a customer-fitting product. And price is obviously an important element we have discussed, but whether it meets the customer specifications, right? And sometimes you can realize that at the end of the day, a product that does not sell or sell for zero profit is also going to have a very short runway, right? So eventually something, a sweet spot. And that is where another point that comes is the global partnerships. So think about a company, an Indian company, 10 college students, but having the right mentorship, the right global partnerships to scale them up. Here I would like to have some thoughts, you know.
Come to X0 if you are one of those. We will provide the mentorship, we will provide the guidance. And not everybody has to be an independent company. If you think about how the Chinese and everybody else developed, you know, they kind of synergizing all the talent into 1 or 2 big companies. Think about, in the context of China, HiSilicon and Unisoc, right? A lot of startups and a lot of smaller companies, but initially, these were the 2 companies. Everybody started all the energy started channeling towards them in a way, right? So, you know, yes, startup world we value, but we can also provide some mentorship. And if they want to join forces and become part of X0, you're welcome as well. If you have good ideas and everything, we can open up a product line and kind of go about it together, right? There is no problem with that.
Dan, your views on that?
Yeah, so it's not unique to India, I have to say. I myself am located in Europe, and then also there in Europe, I see that for startups, it's like we all know we need to think big from the beginning, or maybe big is not the right word, global. It's not that you need a huge amount of money. It's more you need to be global, you need to be unique globally in what you're going to do, and not just locally. And also there we see, like, in the US, we think, oh, in the US it's so much easier to have access, to have visibility, and so on. Yes, I talk with startups here in India. I see what you mean, but asking for mentorship, looking for partners, this is that can guide you, that can support you, is key to find that place, and that is possible here. What I'm a bit worried about is, like, you have these local initiatives that stimulate the young students to think about entrepreneurship and to do startups. Are these local agencies, I don't know exactly, are they really thinking and sufficiently capable of thinking global for them and bringing that message? There I sometimes have a bit of a concern, and I think, like, look at more at contacts at companies that are willing to mentor, that are willing to support. I think you'll see a very big willingness on that.
Sure. So I think the key that both of you are mentioning, that the right global connects from a mentorship, from a partnership perspective, is the key for any Indian young startup and have the global ambitions. Now, the next question, very practical question that I would like to throw at you, again from the shoes of an Indian young startup. Any SoC eventually has a lot of IPs inside, right? So it's like a wall with a lot of bricks. And we all know that some of the IPs take years to build and to reach a point where you can declare it a golden quality, and it has seen silicon many times. Now the advantage the MNCs and the established companies have, they already have a library of those IPs, whether they are big digital compute IPs or analog, mixed signal or RF, whatever case may be, they have the decades of history where these IPs are existing. You just take it from the shelf and create your SoC. For Indian companies, they have to build even those IPs from scratch. Now, if the market is waiting for you, and if you take 2 to 3 years to build IP, you lose the market. So they are forced to buy those IPs or license those IPs. That takes away the entire profit margin that otherwise, so it's not a level playing field with any global MNC. Now, getting into those shoes, what are your thoughts and advice?
You always have a way to corner me here, so I understand where you're going at it, but it's very fair. I think it's very fair. This is a very fair question, and it is, let's call a spade. It is an uneven battlefield. Let's not try and sugarcoat it. But there are some things startups can do, and some things new entrants can do to overcome that, and some maybe the government can help as well. First of all, if you're a startup, you probably have to build a moat where you are starting off with something differentiated enough that you are able to overcome that barrier because of the differentiation that you're bringing. But I also take a little bit of issue with this IP. I think it is in our mindset that, oh, big companies have this lot of IPs, they are just pulling it from the libraries and all. I think it is a little bit of an overstatement when it comes to, like, proven IPs that are very well rounded by be it ARM or anybody else, that IPs, SerDes IP or things like that. They are all available. You can always license them. Yes, maybe as a startup you may get dinged with a little bit more cost from the licensing fee point of view. But when it comes to all other IP, over the past 25 years, I started my career as an engineer, design engineer. It's very, very hard to reuse IP. Every time I designed a circuit, Texas Instruments, Qualcomm, Samsung, so many libraries, so much IP that is available. Do you think I ever use any of those? No, I just look at them, maybe get an idea, and you can get the same by looking at some of the IEEE Explore papers and other things that are available. Because the minute you change one parameter in the design, the entire IP that was built for some other purpose, for something else, completely falls apart, because once you add a new parameter, the entire design space changes. So this is a little bit of a mental kind of block that we put, that big companies have a lot of IPs. It's engineer to engineer. If you really think about it, it's head-on engineer to engineer battle more than anything else.
Okay, good perspective. Dr. Yan?
Yes, I think it's not so much an issue of IP. When you're building an SoC, it's always a question like, what is the differentiating IP here, which I want to own and where I want to make the difference, and you want to do that investment anyway. And the rest you want to buy and not build, yeah? And it costs money, so there is an investment budget needed for that, and that's a challenge, but that IP that you use there, which is non-differentiating, as Naveen is saying, also the large companies, they will be going to ARM, to Cadence, to Synopsys to get that IP at maybe a bit better cost than you. So what you're looking for is, and that's the real issue, are you looking at an area which is a consolidated market? And yes, in Semicon there are of course quite a number of consolidated market, meaning that there are some dominant players in there which occupy the field, and that is getting in there brings all these challenges that you're competing with that. But there are also many different areas, smaller areas, niche areas, which are not consolidated, where there is not like a big player occupying that field, and that's where you have to look at. Because then you get an opening to make your business case and to make the numbers fit, such that you can go for an SoC implementation where you have your differentiating IP, and the rest is indeed built on accessing IP that's readily available.
Sure. My experience has been in my previous life, in big digital SoCs, we were reusing 70% of the IP portfolio. So they only need to worry about the 30%. Here, I have to worry about all 100. The other thing is, all the business cases that we are doing, IP cost itself is like in millions of dollars, in double digit, especially for complex SoCs. So we are finding definitely this as a deterrent, and thinking on behalf of all the startups, they will have the potentially similar challenges. This leads me to another key element. Any SoC or any design requires EDA tools. By the way, on the IP front, thanks to DLI scheme, a lot of startups are getting IP repository from Government of India through MIT, and they can get advantage of that. Of course, that needs to grow, but that is in the right direction. So there's a very positive support coming from the government. And so as on the EDA tools. Government is providing a lot of EDA tools so that you can build your chips from a startup standpoint. One disruption that is coming in EDA industry, the whole world is talking about the generative AI, the agentic AI, and a lot of future predictions that in a couple of years, the entire semiconductor design will be driven by things like ChatGPT equivalents with the dedicated agents trying to do place and route verification. I know it's a very interesting thought. It has already disrupted a lot of industry in last 6 months, and it is going at a super exponential phase. Any predictions from your standpoint?
Yeah, maybe I'll take this one. I just talked about consolidated markets, and if I have one worry, it's about how consolidated the EDA tool market is. Yeah, Cadence, Synopsys, Siemens, dominating. Yeah, and for sure, generative AI is coming towards the EDA tools will be integrated, and chip design methodologies are changing, will be changing significantly. My big worry is that the only ones who can realize this are the big players which are already dominating the market, because you need to have access to all the example designs to train the models, and only the big ones have the power to really have this access and to really have high quality differentiating AI tools for chip design. Yeah, so this is something where I would love to see, like, there are also innovative, challenging solutions to come, not just from the big players, but I'm worried about this.
Sure. Naveen?
I really am a big cheerleader of whatever you're saying. If agentic AI can really make these EDA tools, or it can reduce the cost that I'm paying for the EDA tools, because they do charge an arm and a leg, and I can see why, but they do charge an arm and a leg, and that's becoming, I mean, out of the labor OpEx that I have, EDA tool OpEx is the largest, and every time we cut the check, it just pains me so much. So whoever is working on this agentic AI to take over the EDA tools and provide with the open source, all power to them. I really want to see that day, and then our operating margins will improve by a huge magnitude.
So I met some companies in US which are the early birds into this agentic AI-based semiconductors design, and they are predicting a 70% reduction in the resources in engineers. And of course, EDA tools they will still use, because what they are trying to do, agentic model, which on one hand have an API with the Cadence, Synopsys, Siemens tools, and the other hand with the LLMs, which are trained for a specialized semiconductors job. And that engine is working as a extended teams. So it will be very interesting disruption.
Oh, they will be my angels. God bless them.
Yes.
But my worry is that the tools will reduce the resource needs to run the tools with whatever 70%, and what will happen? The main players that are there, they will increase the tool cost. They will be offering the AI-based EDA tools, and they will increase the tool cost again with a factor 2 or 3.
Zero-sum game.
Because they're going to tell you, I have a new tool for you, and you only need 1/3 of the people, but yeah, the tool will be twice as expensive. That's my big worry.
You could be 100% right, Jan, on that, yes. There are some really good business guys out there on these EDA tool companies.
So maybe a year from now, if this prediction is right, we will have a different problem to solve, right, in the next SEMICON. Now, leading to my last question is about, all that is possible with the excellent talent pool, right? Now, India is one of the largest country with largest number of engineers coming out. How we get them into a mindset of, number one, creative for converting customer problems into systems and architecture. Number two, how they are agile to work in a mindset for fast-moving time to market. And number three, mindset to compete globally, not just a me-too product, right? So what are your suggestions or thoughts about Indian engineers? Because the context is India right now. Whether it's the educational system, whether it is the finishing schools, anything that you have in your thoughts which you are trying to implement in your companies.
Yeah, for me, I think, so we just talked, let me link to that, like EDA-based, AI-based EDA tools coming up, which is like, could be seen as a significant threat for especially India, because we're talking like a reduction of the resources needed with maybe 70%, if that was your number, which could for sure be true. And especially India has these very good resources, talent pool, which are like on digital verification, on back-end work and so on, which is the talent pool which will in this case be replaced. So we could say this is a threat to India, more maybe than other countries, and we need to shift to more creativity, more value-based work. For sure, this is true, but I see this as an opportunity, especially for India, because what will be needed as we get these new design methodologies, coming in, what we need is, of course, a young generation of eager engineers that are very eager to jump on these new capabilities that will be introduced by AI-supported design flows. And if anywhere I see young talent that is eager to jump on that, to adopt it, it's here in India.
Great. Your thoughts, Naveen?
Call me biased, but Indian engineers are the best. There is no two ways about it. Jai Hind. So I'll tell you what, right? Ultimately, if you think about it, this opportunity, this initiative belongs to Indian engineers. Because, you know, let's look at it, right? If you open your eyes, who are the companies which are making the most money in the semiconductor market? What are the top 10 companies that you think of? These are the fabless semiconductor product companies which are driven by innovation, right? NVIDIAs, Qualcomms, Broadcoms, AMDs. These are the companies that you think when you think of semiconductor market. You don't think of Amkor or Stars Micro or something, TSMC being an exception. Other than that, it's all fabless semiconductor companies. And what is the bread and butter of fabless semiconductor companies? Innovation and innovative engineers. Now, all these companies that I'm talking about, right, look at their workforce, especially the top talent workforce. They are all Asian, and within Asian, and I mean a huge proportion of it, come from Indian origin. We just have to change the script a little bit, and as these things start changing, thanks to what Modi ji has set up and all these things that we are discussing today, I think once, and engineers, they don't work for Indian company or a Japanese company, or they work for a company. If they like the leadership, if they like the vision, that's all what the engineers care. And we just have to come up with those companies, and the engineers will come, and then we will make hay. And you know, the DNA of Indians reeks of this, and it is a pity that it has taken so long, but it won't be too long before the fabless semiconductor world belongs to Indian companies, which again takes the cake when it comes to semiconductor industry.
Sure. So the general consensus is this is going to be the India's decade and maybe century.
Absolutely.
And a lot of young talent that are looking for semiconductors as a future. The sky is the limit to excellence and growth. So with that positive note, maybe the last question: if India has to succeed as a product nation, as a semiconductors superpower, in next 5 years, 2030, 2032 maybe, when we are saying we'll be about $100 billion plus of semiconductors consumption from the current 10 to 20, which is 5-fold. What will be your success criteria for India, whether we have lived up to the opportunity or not? So one indicator in brief to both of you.
You know, all it comes down to putting your head down and making things happen. We can talk and talk and talk and talk, but I think the engineers have to put their head down, put the work-life balance, or whatever, the wokeness aside a little bit, and just become the absolute best in the art that you're doing. And the rest will slowly fall in place sooner or later.
Thank you. Dr. Jain?
And for me, if you want to look, then you said 2030, or like, how do we measure success for India in the SEMICON space? It is very important that there is, at the moment, all the production capacity installation, but I do think it's irrelevant to measure how much production capacity does India have by that time. The question is, how much products run on this capacity by that time? That's the key question. That's the measure that we have to look at. That should be the focus.
Great. And if I have to put my 2 cents by 2030, it is make in India products, design in India products, with the whole supply chain from OSAT to manufacturing, all happening in India, and we can be at par in quality and export levels to any other country. If we can have multiple products by multiple companies, I think that will be a good mission to accomplish.
Competition is good.
Yes. And with that, we wrap up this fireside chat. Many thanks to Dr. Naveen and Dr. Yan for this discussion, and we can now open it up for...
No, I think the time is up, sir. We'll have to take questions
Offline?
offline. Maybe you can take one question.
Okay, so maybe one question we can take from the audience.
Okay. Yeah, question there. Yeah, you can give the mic. A quick question, yeah. Both of you, yes, finally. But
yeah, this is a question for Naveen. So he mentioned that he doesn't distinguish between the engineers in San Diego and Bangalore. But clearly there's a talent difference, especially when you look at the bigger companies. They give the designs of the mature designs to engineers in Bangalore. So how do you do that? Like when you say that you treat the engineers in Bangalore and San Diego the same?
We don't do that. I mean, engineer is an engineer from our perspective. If you're hinting that sometimes the top-notch work or the most innovative work is not given to the engineers in Bangalore, I think again that's really the past. I think it has changed. If you look at Texas Instruments, for example, I know for a fact that the most cutting-edge technology when it comes to their converters and transceivers comes from their Bengaluru site in India. When you talk about Qualcomm and many other companies, that is the case. You know, that engineers in India are now running with the cutting edge. You know, there was this 2-nanometer design that was recently being started by Renesas out of their Indian site, right? I think that's a thing of the past, in my opinion. I think we crossed that bridge. If we are still hanging on to it, it's only because of our biases. I think the Indian entities of multinational companies are very well in position to go and challenge the business heads and say, hey, the next big chip that is state of the art, please send it our way.
Yeah, one last question, yeah.
So anyway, thanks for the discussion. I think a good number of times we heard competitive products and competitive systems, right? Now, what is a product we are calling a chip, I guess, right? And system applications, highly, yeah. So my question is, to what extent do you shop for a good chip, a competitive, because the product is chip now. To what extent? I understand a good design are the brains of that, but where do you get the good heart, which is a foundry? So do you shop for that?
Oh, absolutely. If you don't have a good starting point, like I mentioned, or the heart or whatever the system that is central to the whole thing, game over. And that's why fabless semiconductor companies are really overtaking IDMs. If you know what IDMs mean, they have their own fab and they're trying to make it work somehow. So X0, that's one of the very first thing we do. First, find the right technology choice, foundry and the technology node of the problem that you're solving. Without that, like you said, you're operating without a heart.
Yeah, sorry, just to follow up on that. So I take out just the foundry. I consider only the foundry. So you have a fantastic design out there. You go to a foundry. Which foundry would you choose now? Because they're not designing anything. It's an A, B, C, D foundry. Do you shop for any of these foundries to get your good competitive product?
Sorry, I didn't understand the question very well. Maybe, Jan, you understood?
No,
yeah,
I'll just clear it, sorry, if you don't mind.
So your question is like, will you really shop and for purely look at technical properties of
a good foundry.
of a technology at a certain foundry? And the answer is no, you need both. So you need a foundry with which you build up a commercial relationship. We talked about this earlier in the discussion here. You need best pricing, and for best pricing you need to have the commercial relationship, you need to build the volume. So you cannot shop around every time, but it must be end-to-end. You need to have the commercial relationship, to get your pricing right, but it must be with a foundry which also has its technology top-notch.
Exactly.
At a low cost. And so it's very important to find that point and have that relationship with a selected number of foundries with which you want to work.
And just to add to this point, a very important angle, in addition to commercial, in the current geopolitical situation, the supply chains are very, very important lifeline for any country. So from an India standpoint, the foundry has to be something that we can believe that next 10, 20 years, if it is a very important product for national importance, we do not get any disruption because of some decision done by somebody. True. So it should be a friendly country. It should be a country where we can leverage for a long term. And precisely that is the reason we are trying to build our own foundries in the country.
That's right. Thank you.
Yeah. Done, sir? Yeah. Thank you very much. And I'm pretty sure all of you might be having a few questions that can be posed to them during the lunch break. Let's give a round of applause for all our esteemed panelists, ladies and gentlemen. Mr. Sanjay Gupta, thank you, sir. And also we would like to thank Mr. Jan Krolls as well as Dr. Naveen Yanduru. Well, ladies and gentlemen, we'll now break for lunch. Do come back by 1:50 so that we'll be able to start the session at around 2 p.m. And you're all fully aware because since the last 2 days, the lunch plan is same. You need to go, the dignitaries, pass holders will need to go to Juhi in the second floor, the delegates in Amaltas at B1, and all others in the food court behind the exhibition hall. So all of you enjoy your lunch and come back by 1:50. See you all then. Take care.
of over rupees 100 crore and a robust policy framework. O-Chip is designed to spearhead the semiconductor revolution in the state with strategic support from industry, global semiconductor innovation.
8 billion people worldwide touched by semiconductors. With over 1 trillion chips manufactured in a year, the impact of technology they enable is accelerating. At SEMI, our member companies advance life-changing technologies, and we help them connect, collaborate, innovate, grow, and prosper. We offer unrivaled market intelligence to power timely business decisions. Together with our members, we push technology limits to reshape industry segments. Mobility, geopolitical uncertainties, and supply chain disruptions. Together, our impact is stronger. We go faster and further than ever before.
Global semiconductor supply chains.
Driven by the vision of the Honorable Prime Minister, Shri Narendra Bhai Modi, Government of India has launched several progressive policy initiatives as part of the SEMICON India program. Gujarat, under the leadership of the Honorable Chief Minister, Shri Bhupendra Bhai Patel, is synergizing with the vision and policies of the Government of India. In 2022, Gujarat became the first state in the country to announce a dedicated semiconductor policy. Gujarat State Electronics Mission, GSEM, is the nodal agency of the state government that promotes initiatives to develop semiconductors, electronics, and display manufacturing ecosystem. Gujarat's specially curated electronics policy supports the upstream and downstream ecosystem partners. The state has also recently announced a dedicated electronic components manufacturing policy with crucial support to ignite growth in this industry. Gujarat's first of its kind space tech policy 2025 to 30 will power a $5 billion space economy in the state by 2033. Gujarat is leapfrogging as India's gateway to Silicon, with over $14 billion worth of projects under the SEMICON India program. India's first commercial semiconductor fab is being established by Tata Electronics at Dholera SIR. India's first chip packaging cluster is emerging close to Ahmedabad city in GIDC, Sanand, where Micron Technology is setting up India's first ATMP facility. CG Power and Kane Semicon are setting their OSAT facilities. A world-class Semicon city is being developed in Dholera, featuring state-of-the-art infrastructure, seamless 360-degree multi-modal connectivity, and cutting-edge common facilities, all designed to foster a thriving semiconductor ecosystem. Gujarat is establishing as a preferred destination for high-tech manufacturing with its proactive model of governance, excellent connectivity, huge reservoirs of skill and knowledge, and vast business and investment potential. The government of Gujarat reaffirms its commitment to supporting semiconductor, display, and electronics manufacturers and their supply chain partners. Welcome to Gujarat. Explore your next business opportunity. Suswagatam.
Tamil Nadu is India's most industrialized state, driving double-digit economic growth with more than 39,000 factories and 2.7 million people in manufacturing. It's the nation's electronic powerhouse, responsible for 1/5 of India's output and leading the country with over 14 billion in annual exports, representing 41% of India's total. Beyond electronics, Tamil Nadu leads in scale industries powering 70% of India's electric vehicles, anchoring 20% of its data centers and accelerating growth across aerospace, defense, network equipment and rail manufacturing. Tamil Nadu is not just a market, it's a launchpad for global growth. When it comes to semiconductors, Tamil Nadu has the strengths that matter most. From materials to manufacturing, Tamil Nadu has it all. In materials, leaders like Macadamit Alpha, Marwa and QMI set the foundation. In equipment and testing, giants like Applied Materials, KLA, ASMT, Yield Engineering Systems and Mindox Techno drive breakthroughs. In design and R&D, innovators such as Qualcomm, Dissemi and Microchip power the future. In assembly and packaging, SPEL, India's first OS80 stands tall. Global leaders trust Tamil Nadu. In less than a year, Yield Engineering Systems shipped India's very first advanced semiconductor equipment from Coimbatore. Mindox Techno is already close to its 100th shipment from the state. But Tamil Nadu is not stopping here. To shift from a service nation to a true product nation, we are home to dynamic startups driving chip design, R&D, stock development and testing IVP Semi, Incore, Mindgroove, Edvion and Inix. This is more than an ecosystem. It's a place where innovation moves fast, products reach global standards from day one. In Sulur and Palladam, semiconductor equipment parks are under development to serve India and global markets at scale. The state is investing in modular fabs for R&D prototyping, supported by the School of Semiconductors and the Center for Advanced Semiconductor Technologies with IIT Madras. Together, they will train and upskill more than 4,000 engineers every year with hands-on experience in advanced fab design and product engineering. This roadmap is clear: to make Tamil Nadu the semiconductor partner of choice and the product capital of India. And today, Tamil Nadu extends its invitation to global semiconductor leaders like you. Come partner with us and power the next era of semiconductor excellence.
Every great revolution starts with a spark that spreads its energy and changes the landscape around it forever. Semiconductors. The tiny silicon marvels that beat at the heart of every device. Semiconductors are the new oil, powering intelligence. In the last 10 years, under Prime Minister Shri Narendra Modi's visionary leadership, transformative policy reforms have driven exponential growth in India's electronics manufacturing sector. India's semiconductor market is projected to reach $110 billion by 2030 in the $1 trillion global semiconductor market. India's semiconductor mission started with launch of SEMICON India program in December 2021 with a vision of positioning India as a trusted global partner in the semiconductor supply chain. This landmark initiative marked a turning point for India's transformation into a global semiconductor hub. DLI scheme empowers domestic companies with support up to 50% cost for chip design and 6 to 4% of net sales turnover, along with EDA tools, third-party IP cores and post-SI validation.
हमारा सपना है कि दुनिया की हर डिवाइस में इंडियन मेड चिप हो.
10 projects approved. These include Silicon Fab, Silicon Carbide Fab, and 8 packaging facilities producing 24 billion chips annually. With focused investments, policy support, and collaboration across industry and academia, India's semiconductor revolution is taking shape across the country. There are 20% of the world's semiconductor design engineers in India. Under DLI scheme, 23 startups have been approved for designing semiconductor chips. 60,000 students trained under the Chips to Startup program. Together with Design-Linked Initiative Scheme, electronic design automation tools provided to over 280 plus institutes and 72 startups, making it the world's largest centralized EDA tools facility provided to students. These transformative projects will open up thousands of new job opportunities for startups, technicians and engineers. Revised semiconductor curriculum implemented by AICTE in more than 500 institutes. MOUs and MOCs with the US, Japan, Singapore and the EU. Partnerships with multiple countries for R&D and workforce development. Under New Bharat, industry will be encouraged to do R&D and setting up manufacturing facilities for equipment, semiconductor-grade chemicals, gases and materials for the development of complete ecosystem.
और अब भारत अगले 25 वर्षों के लक्ष्य पर काम कर रहा है.
From spark to silicon, from ambition to achievement, Bharat is rising and emerging as a reliable and trusted partner in global supply chains. This is Bharat, building the next semiconductor powerhouse. Jai Hind.
the leadership of Honorable Chief Minister Shri Mohan Charan Majhi, the government of Orissa is steering bold initiatives in next-generation industries. With semiconductors at the heart of its vision for Viksit Orissa at 2036 and Viksit Bharat at 2047. Introducing O-Chip, the Orissa Semiconductor Fab and Fabless Innovation and Acceleration Program. Designed to spearhead the semiconductor revolution in the state. With an investment of over rupees 100 crore and a robust policy framework. O-Chip is designed to spearhead the semiconductor revolution in the state with strategic support from industry, global semiconductor innovation.
8 billion people worldwide touched by semiconductors. With over 1 trillion chips manufactured in a year, the impact of technology they enable is accelerating. At SEMI, our member companies advance life-changing technologies, and we help them connect, collaborate, innovate, grow, and prosper. We offer unrivaled market intelligence to power timely business decisions. Together with our members, we push technology limits to reshape industry segments. Mobility, medtech, AI, manufacturing. Working in tandem, we overcome the toughest industry challenges: the talent gap, the environment, geopolitical uncertainties, and supply chain disruptions. Together, our impact is stronger. We go faster and further than ever before. Making life better for the 8 billion and generations to come. SEMI.
Semiconductors are playing a critical role in the world in more ways than we can imagine. It is our collective aim to establish India as one of the key partners in global semiconductor supply chains.
Driven by the vision of the Honorable Prime Minister Shri Narendra Bhai Modi, Government of India has launched several progressive policy initiatives as part of the SEMICON India program. Gujarat, under the leadership of the Honorable Chief Minister Shri Bhupendra Bhai Patel, is synergizing with the vision and policies of the Government of India. In 2022, Gujarat became the first state in the country to announce a dedicated semiconductor policy. Gujarat State Electronics Mission, GSEM, is the nodal agency of the state government that promotes initiatives to develop semiconductors, electronics, and display manufacturing ecosystem. Gujarat's specially curated electronics policy supports the upstream and downstream ecosystem partners. The state has also recently announced a dedicated electronic components manufacturing policy with crucial support to ignite growth in this industry. Gujarat's first of its kind Space Tech Policy 2025-30 will power a $5 billion space economy in the state by 2033. Gujarat is leapfrogging as India's gateway to Silicon, with over $14 billion worth of projects under the SEMICON India program. India's first commercial semiconductor fab is being established by Tata Electronics at Dholera SIR. India's first chip packaging cluster is emerging close to Ahmedabad city in GIDC, Sanand, where Micron Technology is setting up India's first ATMP facility. CG Power and Kane Semicon are setting their OSAT facilities. A world-class Semicon city is being developed in Dholera. featuring state-of-the-art infrastructure, seamless 360-degree multimodal connectivity, and cutting-edge common facilities, all designed to foster a thriving semiconductor ecosystem. Gujarat is establishing as a preferred destination for high-tech manufacturing with its proactive model of governance, excellent connectivity, huge reservoirs of skill and knowledge, and vast business and investment potential. The government of Gujarat reaffirms its commitment to supporting semiconductor, display, and electronics manufacturers and their supply chain partners. Welcome to Gujarat. Explore your next business opportunity. Suswagatam.
Tamil Nadu is India's most industrialized state, driving double-digit economic growth with more than 39,000 factories and 2.7 million people in manufacturing. It's the nation's electronic powerhouse, responsible for 1/5 of India's output and leading the country with over 14 billion in annual exports, representing 41% of India's total. Beyond electronics, Tamil Nadu leads in scale industries powering 70% of India's electric vehicles, anchoring 20% of its data centers and accelerating growth across aerospace, defense, network equipment and rail manufacturing. Tamil Nadu is not just a market, it's a launchpad for global growth. When it comes to semiconductors, Tamil Nadu has the strengths that matter most. From materials to manufacturing, Tamil Nadu has it all. In materials, leaders like Macadamit Alpha, Marwa and QME set the foundation. In equipment and testing, giants like Applied Materials, KLA, ASMT, Yield Engineering Systems and Mindox Techno drive breakthroughs. In design and R&D, innovators such as Qualcomm, Visemi and Microchip power the future. In assembly and packaging, SPEL, India's first OS80, stands tall. Global leaders trust Tamil Nadu. In less than a year, Yield Engineering Systems shipped India's very first advanced semiconductor equipment from Coimbatore. Mindox Techno is already close to its 100th shipment from the standards from day one. In Sulur and Palladam, semiconductor equipment parks are under development to serve India and global markets at scale. The state is investing in modular fabs for R&D prototyping, supported by the School of Semiconductors and the Center for Advanced Semiconductor Technologies with IIT Madras. Together, they will train and upskill more than 4,000 engineers every year with hands-on experience in advanced fab design and product engineering. This roadmap is clear: to make Tamil Nadu the semiconductor partner of choice and the product capital of India. And today, Tamil Nadu extends its invitation to global semiconductor leaders like you. Come partner with us and power the next era of semiconductor excellence.
Every great revolution starts with a spark that spreads its energy and changes the landscape around it forever. Semiconductors. The tiny silicon marvels that beat at the heart of every device. Semiconductors are the new oil, powering intelligence. In the last 10 years, under Prime Minister Shri Narendra Modi's visionary leadership, transformative policy reforms have driven exponential growth in India's electronics manufacturing sector. India's semiconductor market is projected to reach $110 billion by 2030 in the $1 trillion global semiconductor market. India's semiconductor mission started with launch of SEMICON India program in December 2021 with a vision of positioning India as a trusted global partner in the semiconductor supply chain. This landmark initiative marked a turning point for India's transformation into a global semiconductor hub.
DLI scheme empowers domestic companies with support up to 50% cost for chip design and 6 to 4% of net sales turnover, along with EDA tools, third-party IP cores and post-SI validation.
हमारा सपना है कि दुनिया की हर डिवाइस में इंडियन मेड चिप हो.
10 projects approved. These include Silicon Fab, Silicon Carbide Fab, and 8 packaging facilities producing 24 billion chips annually. With focused investments, policy support, and collaboration across industry and academia, India's semiconductor revolution is taking shape across the country. There are 20% of the world's semiconductor design engineers in India. Under DLI scheme, 23 startups have been approved for designing semiconductor chips. 60,000 students trained under the Chips to Startup program. Together with Design-Linked Initiative scheme, electronic design automation tools provided to over 280 plus institutes and 72 startups, making it the world's largest centralized EDA tools facility provided to students. These transformative projects will open up thousands of new job opportunities for startups, technicians and engineers. Revised semiconductor curriculum implemented by AICTE in more than 500 institutes, MOUs and MOCs with the US, Japan, Singapore and the EU. Partnerships with multiple countries for R&D and workforce development. Under New Bharat, industry will be encouraged to do R&D and setting up manufacturing facilities for equipment, semiconductor-grade chemicals, gases and materials for the development of complete ecosystem.
और अब भारत अगले 25 वर्षों के लक्ष्य पर काम कर रहा है.
From spark to silicon, from ambition to achievement, Bharat is rising and emerging as a reliable and trusted partner in global supply chains. This is Bharat,
building the next semiconductor powerhouse.
Jai Hind.
Under the leadership of Honorable Chief Minister Shri Mohan Charan Majhi, the government of Orissa is steering bold initiatives in next-generation industries. With semiconductors at the heart of its vision for Viksit Orissa at 2036 and Viksit Bharat at 2047. Introducing O-Chip, the Orissa Semiconductor Fab and Fabless Innovation and Acceleration Program. Designed to spearhead the semiconductor revolution in the state. With an investment of over rupees 100 crore and a robust policy framework, O-Chip is designed to spearhead the semiconductor revolution in the state with strategic support from industry, global semiconductor innovation.
8 billion people worldwide touched by semiconductors. With over 1 trillion chips manufactured in a year, the impact of technology they enable is accelerating. At SEMI, our member companies advance life-changing technologies, and we help them connect, collaborate, innovate, grow, and prosper. We offer unrivaled market intelligence to power timely business decisions. Together with our members, we push technology limits to reshape industry segments. Mobility, medtech, AI, manufacturing. Working in tandem, we overcome the toughest industry challenges: the talent gap, the environment, geopolitical uncertainties, and supply chain disruptions. Together, our impact is stronger. We go faster and further than ever before, making life better for the 8 billion and generations to come. SEMI.
Semiconductors are playing a critical role in the world in more ways than we can imagine. It is our collective aim to establish India as one of the key partners in global semiconductor supply chains.
Driven by the vision of the Honorable Prime Minister Shri Narendra Bhai Modi, Government of India has launched several progressive policy initiatives as part of the SEMICON India program. Gujarat, under the leadership of the Honorable Chief Minister Shri Bhupendra Bhai Patel, is synergizing with the vision and policies of the Government of India. In 2022, Gujarat became the first state in the country to announce a dedicated semiconductor policy. Gujarat State Electronics Mission, GSEM, is the nodal agency of the state government that promotes initiatives to develop semiconductors, electronics, and display manufacturing ecosystem. Gujarat's specially curated electronics policy supports the upstream and downstream ecosystem partners. The state has also recently announced a dedicated electronic components manufacturing policy with crucial support to ignite growth in this industry. Gujarat's first of its kind space tech policy 2025 to 30 will power a $5 billion space economy in the state by 2033. Gujarat is leapfrogging as India's gateway to Silicon, with over $14 billion worth of projects under the SEMICON India program. India's first commercial semiconductor fab is being established by Tata Electronics at Dholera SIR. India's first chip packaging cluster is emerging close to Ahmedabad city in GIDC, Sanand, where Micron Technology is setting up India's first ATMP facility. CG Power and Kane Semicon are setting their OSAT facilities. A world-class Semicon city is being developed in Dholera, featuring state-of-the-art infrastructure, seamless 360-degree multimodal connectivity, and cutting-edge common facilities, all designed to foster a thriving semiconductor ecosystem. Gujarat is establishing as a preferred destination for high-tech manufacturing with its proactive model of governance, excellent connectivity, huge reservoirs of skill and knowledge, and vast business and investment potential. The government of Gujarat reaffirms its commitment to supporting semiconductor, display, and electronics manufacturers and their supply chain partners. Welcome to Gujarat. Explore your next business opportunity. Suswagatam.
Tamil Nadu is India's most industrialized state, driving double-digit economic growth with more than 39,000 factories and 2.7 million people in manufacturing. It's the nation's electronic powerhouse, responsible for 1/5 of India's output and leading the country with over 14 billion in annual exports, representing 41% of India's total. Beyond electronics, Tamil Nadu leads in scale industries powering 70% of India's electric vehicles, anchoring 20% of its data centers and accelerating growth across aerospace, defense, network equipment and rail manufacturing. Tamil Nadu is not just a market, it's a launchpad for global growth. When it comes to semiconductors, Tamil Nadu has the strengths that matter most. From materials to manufacturing, Tamil Nadu has it all. In materials, leaders like Macadamit Alpha, Marwa and QME set the foundation. In equipment and testing, giants like Applied Materials, KLA, ASMT, Yield Engineering Systems and Mindox Techno drive breakthroughs. In design and R&D, innovators such as Qualcomm, Visemi and Microchip power the future. In assembly and packaging, FPEL, India's first OS80, stands tall. Global leaders trust Tamil Nadu. In less than a year, Yield Engineering Systems shipped India's very first advanced semiconductor equipment from Coimbatore. Mindox Techno is already close to its 100th shipment from the state. But Tamil Nadu is not stopping here. To shift from a service nation to a true product nation, we are home to dynamic startups driving chip design, R&D, stock development and testing IVP Semi, Incore, Mindgroove, Edvion and Inix. This is more than an ecosystem. It's a place where innovation moves fast, products reach global standards from day one. In Sulur and Palladam, semiconductor equipment parks are under development to serve India and global markets at scale. The state is investing in modular fabs for R&D prototyping, supported by the School of Semiconductors and the Center for Advanced Semiconductor Technologies with IIT Madras. Together, they will train and upskill more than 4,000 engineers every year with hands-on experience in advanced fab design and product engineering. This roadmap is clear: to make Tamil Nadu the semiconductor partner of choice.
Participants in the balcony, you can all come down and participate. Yeah, if you are a part of this, please come down. All of you can come down and occupy your seats here in the front rows. There's no issues. So please come down, I would request. And also, delegates behind the border also can come forward. I can see some delegates there. You can come forward and occupy the seats. We'll start in the next 3-4 minutes.
Every great revolution starts with a spark that spreads its energy and changes the landscape around it forever. Semiconductors. The tiny silicon marvels that beat at the heart of every device. Semiconductors are the new oil, powering intelligence. In the last 10 years, under Prime Minister Shri Narendra Modi's visionary leadership, transformative policy reforms have driven exponential growth in India's electronics manufacturing sector. India's semiconductor market is projected to reach $110 billion by 2030 in the $1 trillion global semiconductor market. India's semiconductor as a trusted global partner in the semiconductor supply chain. This landmark initiative marked a turning point for India's transformation into a global semiconductor hub.
DLI scheme empowers domestic companies with support up to 50% cost for chip design and 6 to 4% of net sales turnover, along with EDA tools, third-party IP cores and post-SI validation.
हमारा सपना है कि दुनिया की हर डिवाइस में इंडियन मेड चिप हो.
10 projects approved. These include Silicon Fab, Silicon Carbide Fab, and 8 packaging facilities producing 24 billion chips annually. With focused investments, policy support, and collaboration across industry and academia, India's semiconductor revolution is taking shape across the country. There are 20% of the world's semiconductor design engineers in India. Under DLI scheme, 23 startups have been approved for designing semiconductor chips. 60,000 students trained under the Chips to Startup program. Together with Design-Linked Initiative Scheme, electronic design automation tools provided to over 280 plus institutes and 72 startups, making it the world's largest centralized EDA tools facility provided to students. These transformative projects will open up thousands of new job opportunities for startups, technicians and engineers. Revised semiconductor curriculum implemented by AICTE in more than 500 institutes. MOUs and MOCs with the US, Japan, Singapore and the EU. Partnerships with multiple countries for R&D and workforce development. Under New Bharat, industry will be encouraged to do R&D and setting up manufacturing facilities for equipment, semiconductor-grade chemicals, gases and materials for the development of complete ecosystem.
और अब भारत अगले 25 वर्षों के लक्ष्य पर काम कर रहा है.
From spark to silicon, from ambition to achievement, Bharat is rising and emerging as a reliable and trusted partner in global supply chains. This is Bharat,
building the next semiconductor powerhouse.
Jai Hind.
Welcome back, ladies and gentlemen. Hope you all enjoyed your lunch. And now we are moving towards the post-lunch session. As we are all aware, this is a very important session in terms of India's semiconductor mission and the way forward. And at the same time, we are regulatory marketing perspectives that are shaping the semiconductor ecosystem. So several topics will be discussed in this all-important panel discussion. Moderator of this is, it's gratifying to note that Mr. Neelkant Mishra, the Chief Economist of Axis Bank, Head of Global Research Axis Capital, Whole-Time Director Axis Capital, and member of ISM Advisory Committee, He is moderating this. Put your hands together for Mr. Nilkant Mishra. Has worked in several, and his leadership quality is known to all of us. So, hearty welcome to you, sir, and good afternoon. And our panelists consists of Mr. Surendra Babu Mandava. Put your hands together for this accomplished semiconductor industry executive with close to 4 decades of experience in the field. He had held the position of Senior Vice President and General Manager of the IP Group at Cadence Design Systems from 2017 to 2021. And he successfully led it as an IPO, where he served in engineering and general manager roles at Centillium Communications. Hearty welcome to you, sir. I would also like to call upon Mr. Martin Chu, the President, Chip Semiconductor Manufacturing Corporation, PSMC. Welcome to you, sir. He's also got close to 3 decades of experience with Chip Group. And Martin, has a round of applause, please. And his efforts led to a significant growth in PSMC's logic business, increasing its contribution to the company's total revenue from 30% to 60%. He's also recognized for strong leadership qualities. I would now like to call upon Mr. Viresh Patel, the Vice President of Renesas, heading the global team of assembly and packaging worldwide, has got more than 35 years of packaging background with chiplet, advanced flip chip, and so on. Is holding many patents in various packaging and sensor technology. Hearty welcome to you, Mr. Viresh Patel. And now I would like to call upon Mr. Shuichi Sawamoto, Corporate Officer, AOI Electronics, handling legacy to advanced packaging technology, currently a Corporate Officer at AOI Electronics. And Mr. Sawamoto is working as a sales top at AI. His career started as an engineer, and now with 15 years of experience there, is the role of a technical program manager at an overseas OSAT before joining here. So give a round of applause for Mr. Shuichi Sawamoto. Another gentleman will be there so that we'll be able to understand what he's communicating to all of us. And he's also, so let's give a round of applause to him also, because he'll make us understand what's going on. So with this, I would like to straight away hand over the session to our esteemed moderator. Over to you, sir, Mr. Ji. Yeah.
Thank you. Yeah, good afternoon, everyone. I'm quite honored to moderate a panel with such elite partners that we've got. So as we all know, semiconductors are some of the most complex products that humans have ever built. They're also the most research intensive. They're also the most collaborative and products that require a lot of partnership. So even the most advanced of companies need a large number of global partners. So as India tries to kickstart its industry, so we are at least 25 years behind China and maybe many more decades behind the others, we definitely need the support of partners. And so we are quite fortunate, as someone who's been part of the advisory council and the Techno-Financial Advisory Group, which reviews the fab projects. I must say we are quite grateful that we have partners of such a high caliber now. In the first year or so, it was very depressing. So that is very required. But at the same time, as we think about the industry, which is brutally competitive. So Schumpeter talked about creative destruction. This is an industry where very few companies last a long time. So there needs to be continued research, continued development. There is a lot of threat coming from China. So we'll discuss all of that as to not just how do we see the gentlemen here work with their partners in ramping up in India, but also in solidifying the setup here. So maybe I'll start with the first question. The last 5-7 minutes I'll leave for audience Q&A in case you have any questions. So I'll start with a very basic one. What made you come to India? I mean, what were your apprehensions initially, and how did you address them? So maybe I'll start in alphabetical order of surnames. So Mr. Chu, Martin, maybe. So what made you come to India? What were your apprehensions before you signed on to the Tatas?
Okay, thank you, Neil. We are PSMC. We are a foundry maker
We have a joint venture with Tata Electronics. So currently we are building the first 12-inch fab in India in Dholera, Gujarat. Okay, so 2 years ago we started have the joint venture with Tata Electronics, and we found that India is a big market. Okay, especially for recent years, due to the geopolitical issue, China is actually, their policy is China for China. Okay, so the foreign company like us is getting more and more difficult to doing the business in China. So for sure that we need to develop another new market. Okay, so in India, India's population is even larger than China. So I think that that's the reason why we come to India, to work with Tata. I think the market is the main concern.
Were there any concerns, apprehensions? I mean, the fact that TSMC didn't want to come to India, UMC didn't want to come to India. So clearly, in Taiwan, your peers had issues and concerns about India. So did you have any apprehensions about India as well?
Yeah, this is a very good question. Yeah, from the beginning, my understanding is the Indian government actually talked to Taiwanese government and said, well, okay, please help, right? So the Taiwanese government asked TSMC, TSMC said, no thanks, right? They don't share technology with anyone, right? And after that, they talked to UMC. UMC, there's some discussion between the Tata Electronics and UMC, but my understanding is that they can reach the deal because UMC would like to control the fab in India. So our chairman, Frank Huang, is very open-minded, and when the Taiwanese government come to him, he said, okay, so we are free to talk, we're open to talk. And then we started a dialogue with the Tata Electronics. That's the reason, the background. Okay.
Hello. So for me, there are, I would say, many reasons, but I'll call out four. Okay. One is, of course, the incentives are phenomenal. They're the best in the world, and thanks to the government for that. The second one is that the talent pool here, I'm from India, born here and spent first 26 years of my life. The talent here is world class, no question, right? You can see that Indians go outside and succeed and be CEOs and very successful. So talent pool is very important. And then the third one is the market potential. It's not there today, but it will be there. And you got to look ahead, right? You got to go where the puck is going, not where the puck has been. So that's another attraction. The fourth one is personal for me. The desire to give back to the country that educated me. That's important to me. And also, most of you may not know, my first job was at a company called Semiconductor Complex in Punjab, Chandigarh. So first fab in India. Back in the late 70s, early 80s, no TSMC, there was no UMC, there was absolutely no China as far as semiconductors are concerned. And that's an opportunity lost, and I still feel guilty about it. Not that I could have done anything, I was out of school, just first job. But these are the four reasons, and there are many, many more, but these are the most important.
Thank you. Videsh?
Thank you, thank you. I'm part of the Japanese conglomerate Renesas that has a joint venture with Moragappa. Why we came? I think India is the next China, in my opinion, from the demand perspective. So having that market, and as Babu said, that the market is emerging here, I think we were looking at how do we address this market? Do we put factory here? Do we start with small? Many years ago, starting the back-end factories was quite feasible. With today's cost structure and competitiveness and the capacity worldwide, it's kind of difficult to start something on your own. Having a joint partner in Moragappa allowed us to play the ecosystem here, as well as trying to participate in the demand that will be required to be fulfilled. Today, I think we see about 110 billion projection. Even the back-end projection of, let's say, 10%, that's a $10 billion opportunity for manufacturer. That's huge. So having that foresight, and then on a personal level, I left about 45 years ago this country as a little boy. Coming back with a 35 plus years of experience in the industry, coming back to my home state where I was born, and being able to do something that I've been passionate about several years. That allowed me to be part of this. Having a right partner was very important. Renesas is not only a partner in a sense, we are a joint venture with an investment, technology transfer, as well as being a customer of Moragappa CG Semi. So for us, it was a lot more commitment at a hybrid level, whether we build our factory or we go with somebody. So in order to participate in this semiconductor ecosystem being built out in India, this was the right approach for us instead of going out and doing something on our own. So that's how we came about.
Yeah, and I'm sure the fact that the incentives made the IRRs much better would definitely.
Having a government subsidy in today's days and ages for building a very, very capital intensive ecosystem definitely helps. The idea is to model it after Taiwan. Best in the class. Over the 30, 40 years, they've become the best in the class. If we can reach even 80% of what Taiwan has reached, we will be ahead of many other Southeast Asia countries. And starting so late, catching up very, very fast as the government wants us to do. I think it's the only way to do is to come up with a right partnership and bringing that experience of 50 years of Renesas as a partner in technology and our proven business model where we can address the need of India demand.
Thank you. I'll have some questions on how do we move forward with this. Sawamoto-san, can we have your opinions, please?
Thank you very much. I'm Sawamoto of AOI Electronics. AOI Electronics is a Japanese OSAT. Today I am speaking to Japanese, then translate to English. 青井電子はですね、日本では非常にメジャーな OSAT でありますけども、海外に関してはですね、経験値が非常に乏しい会社です。工場もですね、現在国内のみにとどまっておってですね、海外での生産経験というのも基本的にはないと。インドに関しても当然ですね、知識というのはほとんどないというような状況です。その中でですね、今回パートナーであるケインズセミコンの方から技術サポートに関するオファーをですね、今回いただいてですね、約2年間、長き時間を使ってですね、検討を進めてきました。これがインドとの関わりの最初になります。ケインズ、こちらの企業の一つの企業だけでなくてですね、インド政府も含めた非常に大きなプロジェクト、これに関わるということで、経験値の少ない青井電子にとってはですね、大きなプレッシャーを受けての検討となっておりました。その結果、多くの会話をですね、必要としてですね、長い時間をかけて、進めてきたという。今回取り組みの中ではですね、日本のトレーダーである三井物産、こちらの協力も得てですね、青井が不足している海外でのコミュニケーション、こういうものを補ってですね、いただいて、合意に至ることができたというところです。私がですね、今回インドプロジェクト合意に至らせようと思ったきっかけというところがかなり多くあるんですけれども、強くに感じたポイントというのがですね、インド政府のプロジェクトメイクインインディアというものに対する半導体関連の強力なサポート体制、それと日本との親和性というところ、それから、ケインズセミコンさん、こちら多くの話をしてきたんですけども、将来を描くビジョン、こちらの実現性が非常にかなり高いなというところ。材料装置メーカーなどですね、多くの関係者から最近多くヒアリングをしているんですけども、インドの半導体の可能性というのが非常に高くなってきているなというところ、この辺も含めてですね、今回インドの方のプロジェクトに参加をしたと。インドのこの半導体成長というところの一環にですね、関われる このまたとない機会をですね、直接感じながら楽しみたいと、このプロジェクトの方を進めさせていただくということになりました。
AOI Electronics is a leading OSAT in Japan, but it has not much opportunities and not much experience outside Japan. Their factories are only in Japan, so we have not much experience in overseas. So of course, when it comes to India, we had not much of experience and also intelligence in this area. When we received the offer of technical support from Kane Semicon, we were discussing this with them for more than 2 years to put this project forward. So not just Kane Semicon, but also this is a project which relates to the Indian government as well. So it was a very big step forward for AOI for this project. With the help of the Japanese trading and investment company Mitsui, AOI was able to go through all the communication with Kane Semicon and was able to come to a close of this new agreement with Keynes. There were numerous things that AOI was, which affected AOI to make AOI come to India. So one of them is the Make in India scheme, which the Indian government is releasing, and also the future vision that Kane Semicon has, and also when it comes to the discussion that AOI had with the material and also machinery manufacturers, we were able to find the big opportunity in Indian semiconductor. So these are the reasons why AOI has decided to collaborate with Kane Semicon.
Thank you, everyone. So the second question, which follows through from the first one, is, like travel writers say, you go to a new place, you discover yourself, you discover new things, you're surprised positively by a few things, you're surprised negatively by a few things. So now that you've been here for a year, maybe Babu, of course, you've been here for a long time, but Odisha, again, you won't associate with technology by a mile, but you've chosen to be there. Videsh, again, for you as well, while you're back to your home state, but working as a partner, setting up a business in India, I'm sure there are challenges and positive surprises. So sometimes you go in fearing that, oh, the food won't be great, or the weather won't be great, or you'll get sick, and those things won't happen. So what would be on from the business perspective, the positive and negative surprises that you have felt? So maybe we start with Martin again.
I think that the most important thing, for the Taiwanese to enter the Indian market is to choose the right partner. Okay, so Tata Group is a very large group. They have their own automotive business, and also there's a Tata Motors, and also they have a EMS. All right, these two business is very important for the semiconductor, because both of them consumes huge amount of the chip. So that is inside of the group, they have such kind of the business channel. And as a foundry maker, you have to have the channel. Okay, so choosing the right partner as Tata is the very important step for PSMC to enter the India market. Okay, so that is I think the main concern from us. We choose the right partner, and the partner has a very good channel by themselves. So this is a very important step to us.
So over the last year and a half, as the project has taken off, and you were mentioning while we were having lunch that now 20 of your engineers are here, 100 engineers from Tata are training. So as you see the ground operations here, and you've had the experience of seeing how China grew, and of course Taiwan as well. So what are the things that have surprised you positively? Clearly the Tata Group's internal demand itself is a huge boost, and I think you're absolutely right. But what is it that surprised you positively, and what is it that you were negatively surprised by? You didn't expect it to take, something would take so long, and it did.
All right, so we are on the stage of the construction now, okay? And then this is the first 12-inch fab in India. So the whole ecosystem is not ready yet. All right, to build from our experience, we need at least 1,400 vendors, which might covers 25,000 items to purchase for building a 12-inch fab, which means that the whole ecosystem is very complicated and need a lot of support, especially there's no such kind of ecosystem domestically, so we need to import, right, from outside. And then you have to make sure that there are so many foreign engineer and worker will come to India. And if we set up the fab in a very rural side like Dolera, right? There's a very it's not a big city, it's a very rural side. You have to have a very good social infrastructure. Okay, so that is the very basic and the fundamental for the foreign engineer or foreign worker can work in India, right? That's the basic one. And then we also, for example, we need a logistics system, right? So the semiconductor, if you build a fab, you need a logistics system, you need a special vehicle to carry the very precise production tool like a lithography tool. And you need a warehouse. It's a modern warehouse with the temperature and the humidity control. Okay, that kind of system has to be prepared in advance in order to be ready for the, again, like I said, the more than 25,000 items imported from outside, right? So this kind of a basic and very fundamental social infrastructure and also the ecosystem is important.
Thank you. And given that yours is the only wafer fab, so I just want to persist a bit more on this. One of the apprehensions we had, or at least when we were looking at the first proposals, as you can imagine, we had nothing more than a PowerPoint presentation to go on. The capex numbers were higher than normal, in the fear that exactly as you were saying, that there's no ecosystem, so it'll take longer, it'll add on to costs. I heard from one firm yesterday that their clean room, that's a 10,000 category clean room, but was, I think, 80% cheaper than their Arizona clean room. So are you seeing that at least on some of the things, the costs are turning out to be lower? Because these are things that we'll also discover as we go along. Are you finding any such surprises as well?
You're talking about the cost?
Yes.
So the import has to be higher cost because you have the transportation.
Import is fixed cost. You can't do anything about it. But at least all the local costs, which earlier we felt, or there was apprehension that let's give some buffer and let's clear some higher costs just in case.
The domestic, maybe labor cost is cheaper, right? Compared with the other country. So I think the important things are the efficiency and the productivity. So this is to need to be observed in the future because I don't know how, because there is no experience yet for the wafer fab, right? But again, There's lots of the experienced Indian engineer from US, right, from Singapore. Okay, so I think that it will help to overcome the learning curve very quickly. But the important thing is that how do you attract those talent and would like to stay here for long term?
That Mr. Trump will help us with that. So, Babu, your response.
Yeah, for me, it's the intent, the excitement, the enthusiasm, the dynamism of the people I've dealt with. People in the sense, MIT, ISM, Odisha, has been phenomenal. They're all extremely professional, want to do this. You know, that's from a government employee, that's a lot, right? So, and for me, that we needed to be on the East Coast, closer to Singapore, Korea. For obvious reasons, the ecosystem is not there. That's the biggest worry. The closer we are, hopefully, to the port, and we can, get engineers from outside and maybe get material faster, etc. So that's been the thing. And in terms of no negative surprise, I would say we already know the ecosystem is not going to be there. So it's not a negative surprise, but that's a reality and has to improve. You have to start somewhere, right? That's okay. We can deal with it. And I think the bureaucracy part of it, right? So it's gotten better from what I knew 40 years ago, but still has some room to improve, I would say. Yeah.
And do you sense that the urgency that the Honorable Prime Minister has, or the METI Minister has, or the ISM folks have, or I have, or you have, is that, or maybe the Odisha government has, is that same urgency understood by the local administration?
The Odisha government, yes, absolutely. So,
meaning the district magistrate and the people who actually will give you a lot of approval.
I haven't gone there yet, so
yet.
I hope the trend, the tone setting starts at the top, right? The Prime Minister is so impressed. He's so much into it. He wants to learn. He's focused on it. So obviously that means, okay, the big boss is focused on it. Everybody lines. So that's important, right? So I hope they turn around, and I believe that they would. Yeah,
I hope so.
I understand.
Videsh?
Yeah, so I think you asked about what surprised me. My impression of India when I left to when I came back for this real project. How swiftly the government at the center, government at state level, whether it's a land acquisition or permitting process or getting clearance on equipment and things of that nature, that surprised me the most. We live in Western world. We think India is slow. Nothing happens that fast. That was the biggest surprise. How swiftly we were in Delhi meeting with minister. It was decided that we're going to be looking at Gujarat and other states. Very next day, we got a call from Gujarat Chief Minister's office to be there on Monday, and they rolled out a red carpet. I mean, unheard of the impression I had. So government entities like ISM or MIT or state, missions, they are in sync and they are moving so swiftly. And we started the groundbreaking about a year and 2 months ago, and we just opened a factory Thursday, last week. So that, I think, is a very surprising factor. The only negative throughout the whole process was, as much as Prime Minister mentioned the paperwork to the Silicon where I think that still needs to be improved at every step of the way. There is still so much paperwork. There is still quite a bit of bureaucracy. I think it's going to get better and better, but that was the only experience that I had that I think we can still continue to improve, and with more projects coming, I think we'll get there.
Understood. Because I was at this event last evening, related to SEMICON, and there were concerns raised that when the equipment was being imported, there were debates on whether
last night, yep.
Yeah, so that the duties are right,
Yep.
and lots of, and so many of these, that this is a strategic project, this is not just some random import of chips, is something that perhaps is not appreciated by the last mile officers.
Yeah, so when you look at the last mile access, I think the disappointing is the people that are trying to do their job, not quite technically capable of comprehending what they're working on, what they're trying to approve, and what the impact is. I think that's a little bit disappointing. We need to do a better job there.
Yeah, and I must say that in my own experience of working with ISM has been that, the learning curve of the organization has been like steep. There's a lot of body of knowledge that is being created, and as the fabs start getting built, as more and more action starts, and the hope is that we get 12 to 15 major plants running, in which case then some of those teething troubles should disappear.
Yeah, that talent will develop. It will take time, but the faster we get there with any government push would be probably the right thing.
That's a great suggestion. Thank you. Sawamoto-san?
はい、そうですね。私はですね、驚きという意味では、ちょっと違う観点で少し話をするんですけども、インドに関しては2年前にですね、初めて訪問したというところになります。一番驚いたのはですね、日本の方はそうかもしれないですけども、街中に牛がいるっていうのが一番驚いたことなんですけども、インドの、文化をですね、理解するっていうことがですね、インドの方たちについてはですね、当然その理解をすればですね、当たり前のことが日常起きているというところです。だからそれを含めると、今あんまり違和感を感じて私もいないというところです。驚きという意味ではですね、やはりその今まで自分が経験してきたことと違うということが、その部分に関わるということだと思うんですけども、いわゆるポジティブ、ネガティブというところに分けられるものではないというふうに考えています。やはり受け入れるということが一番重要なことだというふうに考えています。この改善すべき点ということに関しての質問なんですけども、前提としてはですね、インドの現状を受け入れたということになりますけども、今回我々ケインズさんにですね、テクノロジーサポートをするという観点のことから考えたときに、我々日本のサプライヤーとしてですね、品質に対しては非常に強い誇りを持っております。しかし日本の品質管理がですね、決してベストなものだというふうには全く思ってないというところです。ワールドワイドの品質賞ということもですね、日本の管理とはかなり異なっているというところです。要するに国や地域ですね、この辺にある文化とかですね、教育、そういうものが異なる人たちと一緒にやっていくということに関しては、その日本オリジナルの手法をですね、コピーしておいても基本的にはうまくいかないというふうに考えています。日本的な管理手法、ワールドワイドの品質要求、こういうものをですね、インドの方たちのそのような背景、文化とかですね、考え方、こういうものを、特性をですね、ミックスして新しい品質管理基準ということを作っていきたいというふうに今考えています。その中でお願いしたいというのは、やはり自分たちの考え方を決して押し付けるということではなくて、より良い方向に目的を共有してですね、一旦受け入れたというような上で議論すると、このような柔軟な姿勢をですね、ぜひ持ってほしいなというふうに考えています。
I will explain to you about the surprises in a different perspective. 2 years ago, it was my first time visiting India, and the biggest surprise was that the people are living together with the cows. So that was the biggest surprise that I first encountered. However, understanding all those cultures in India, I really feel that this is a normal thing for the Indian people. So I am very used to it right now. In terms of surprise, it's more about the difference of what you have experienced. It's a difference about your experience. So it's not a thing which could be easily said about, whether it's positive or negative. So accepting the culture is the most important thing, I believe. Regarding the things that could be improved, first of all, I would like to emphasize that it is important to accept what the current situation is in India. But overall, as Japanese suppliers, we have strong pride in our quality. This is not to say that Japanese quality management is the best, but and also it's different from worldwide quality management ways. But to understand that there are different types of quality management ways, so as AOI, we would like to collaborate between Japanese management, quality management ways, and also worldwide quality management, and also the Indian way of quality management. The collaboration between all these three is an important step forward. Thank you.
Okay, and given that we are taking slightly longer than I had budgeted, so I'll keep it to the last question, and then we'll open up for audience questions. So you see, this is also an industry which keeps changing, which is evolving very rapidly. And one of the biggest changes I see is the rise of China and the amount of money that they're throwing in. So when China had surplus labor, they destroyed labor-intensive industries globally. Now that they have surplus capital, they're out to destroy capital-intensive industries globally. So autos, we've already seen. Compound semiconductors, we were discussing at lunch, they've already done a lot of damage. There are scary reports of the capacity build-up in the 28 nanometer and higher nodes in China. And same in wire bonding. I mean, so there's some thousands of companies that applied for subsidies and all that. So as we prepare for the next 5-7 years, and of course, this is while the Chinese threat is emerging, is also new technology development. Some products are becoming obsolete. So what are you and your partners doing to safeguard the future? So I know, Martin, your view is that first get the fab up and running, and then we'll figure out the future. But my sense is that you may have to start preparing for it a bit in advance. Maybe Babu, your company, given it's already kind of cutting edge, you have different concerns. But would love to get your opinions as well. So this time maybe we'll start with Sawamoto-san and then go in reverse.
この話はですね、いろんな視点で考える必要があるかなというふうに考えています。で、例えば国家レベルの話をしたときにですね、貿易、WTO というところに関してなんですけども、公正な競争というものが、どうあるべきかということについて、やはり市場経済とですね、国家資本主義との関連、中国という話ですけども、ここを踏まえての検討が必要だというふうに考えています。あるいはですね、そこだけではなくてですね、例えば同盟国間で同じ課題意識を持つ国々とですね、連携強化、経済的な連携ですね、こういうことも対応の一つかなというふうに個人的には考えています。これを企業という視点で見た場合なんですけども、日本の半導体もですね、やはり労働集約型のですね、中国に大きな影響を受けて、非常に苦戦を強いられたというのはもうご承知の通りかなと思います。これに対する対応としてはですね、コスト競争にですね、やはり無理に応じるというようなことは必要ないのかなと思っています。やはり高付加価値の製品、高信頼性、環境規制対応、こういうものがですね、キーワードになって、差別化する領域の製品へですね、集中させるということが重要なポイントかなと思っています。質問にもあったんですけども、今半導体という分野に関してはですね、非常に多くのイノベーションがですね、提案されてきているというふうに思っています。その中でもですね、何を選択して集中していくのかということに関して選択するっていうのはすごく難しいことかなというふうに思っています。多くのテーマをですね、選択するっていうことはですね、逆にその機会を増やしますけども、マンパワーを含めてですね、そのリスクということも生じてくると。今、青遺伝子、これは OSAT になるんですけども、現在、日本国内のですね、にある、OSAT とですね、今、大きな連携強化をですね、始めているというところになります。従来、青遺伝子はですね、ラインナップを増やしてですね、ビジネス拡大というチャンスを増やしていう戦略をですね、取ってきましたけれども、やはり今後はですね、その不足する製品とかプロセスはですね、連携した協力会社、こういうものに委託すると いうことを含めて進めていきながら、自分たちで得意とする分野、それから製品ですね、こういうものを絞ってですね、開発、をしていくことで、資源の集中をさせると。これによってですね、効率的な対応を進められるというふうに考えています。そういう意味では、そういう、いわゆる資本主義的なところのですね、考え方、ここに対しては、いいアプローチかなというふうに考えています。
I personally believe this has to be discussed from different perspectives. For example, regarding WTO, how the fair competition should be is something that which has to be discussed, of course. And also, for example, if you have the countries which are in ally partnership, if they have the same difficulties, those kind of economic collaboration is something that which could happen between those countries. As AOI, as a private company, Japanese Semiconductor has been affected deeply by China, which is a country which is a manpower concentrated country. So we did have big difficulties. In order to get over that, it's important to not just concentrate on cost competition, but also high quality, high reliability. These are the things that we would like to concentrate on as a OSAT. Yes, and also there were a lot of questions. There were some questions about how we innovate semiconductors. So something that we have to do is to select and also concentrate on something. So not just as AOI, we are not having a lot of lineups in our business. We are concentrating on something which is highly competitive in our area. So as AOI, right now we are collaborating with other Japanese OSATs in order to enhance our competitiveness as a global OSAT.
So my take is a little different. So as in the past, the ecosystem worldwide in semiconductor has developed. There are pockets of research area and a collaborative effort that has happened. Example, in US, it's Semtech. In Europe, it's Fraunhofer or IMEC. In Japan, there's ASRA. I think India needs to set up something like that. That covers basically advanced material, advanced reliability, advanced interconnect, advanced packaging technology. Not only that, but in the front end as well. That has to be collaborated and supported by the industry, and to some extent some government support, but it is purely a research institute that each of the stakeholders in India has a role to play in it, with support of the resources that they can station for several years in that facility, and they get some of the latest and greatest technology from the best and the brightest equipment maker in the world or the material suppliers. And they get to do that pathfinding, and as a benefit, the participant who are stakeholder in the ecosystem in India get to access those IPs or some of the advanced capability of testing, reliability, and so forth. So I think that would be the future. Each of the companies should be looking at that already. I know CG Semi is already looking at advanced packaging, and this is how we're going to catch up 20 years of gap that we have in hopefully less than 10 years. So that would be a way I would approach the future advancement.
All right, China's competition is very bloody. We are actually facing the very serious challenges from it, especially the China's government subsidy They give subsidy not based on the profit loss, they're based on the revenue. You sell more, you get more, all right? So, but they don't care that much about the profit loss. So in Taiwan, many companies like us, we are also facing the big pressure from them, all right? So there are two ways. If you want to avoid this kind of strong competition, it's just like one way is like TSMC. You have to have the advanced technology, right? But the advanced technology take a long time and is not so easy to get. The other way is that by using the legacy technology, you do the different application, all right? You hit the different market. There's a China for China market, but there's also out of China market. Right? China's economy take about 1/3 of the worldwide economy. So there's still 2/3 you can try to approach. Again, like I said earlier, I said the work with the Tata Group, and they have their own channel for the chips, and India is a new development market. I think this is another way. I think that's our thinking.
So in terms of the development, say beyond 28, so there is this desire that when the next phase of subsidies or the next plan is launched, that should we target 7 to 12 nanometers, because that seems to be, see, by the time some of these fabs will come up, will be, 5, 7 years later. So does it make sense then for the government to actually prioritize some fabs which will then come up at that node, because that will be the most common node and the most commercial node 5, 7 years later?
Yeah, of course, from the beginning, you can aim high. You can aim to 5 nanometer, 3 nanometer, right? But it's not easy as a beginner. It's not easy to enter such kind of advanced node from the very beginning. So the majority of the consumable market is mature technology. So even there's a AI, even there's a robot, but still lots of the small IC in the market is there's a great demand from that. So I think that to use the legacy technology as the entrance is not a bad idea. Okay.
Thank you, Babu. Your views, please.
So this is a difficult question. So at the end of the day, I believe strongly, to survive in this industry, you got to be world class. Otherwise, you're going to perish one day, sooner or later. That has to be the goal. Well, how do you get there? That doesn't mean you have to go develop 2 nanometer, 3 nanometer. That may not be the answer. But you got to have a 25-year plan. That's absolutely critical. You got to have a top-down game. What are you doing? Why are you doing? Where is the puck going to go? Having said that, and you got to play to your strengths. Well, your strengths are intellectual capital. Your strengths are the market that, yeah, it's not there today, but it'll be there. You got to play to those strengths and figure out a way to build world-class products. No matter what you do, where you do, packaging, fab, maybe quantum computing, maybe something else. You got what is the next inflection point? You cannot play the same game as what people have played 20 years ago and hope to succeed. That's table stakes, right? Where you go is very important. I strongly believe in that. I mean, I'm an aggressive guy by nature. I always want to do it. Sometimes I fail, sometimes I succeed. But the mindset has to be, we're going to create the highest IP, highest intellectual property, user capital, brains to do this, not just money, not just dumb way of doing it.
Oh, thank you. And in fact, that's something that markets have anyway sort of suggested that, like, in bulk chemicals, things like fertilizers, China is way ahead. In key starting materials for pharmaceuticals, they're way ahead. But when it comes to precision chemicals, when it comes to active pharmaceutical ingredients, then India, because there's a lot of chemistry required, sophistication required, India is actually dominating that market.
Yeah, the fundamental sciences are very important. I keep saying this. Don't go do programming and think you're going to succeed in life. You're not. You got to be very strong in math, physics, chemistry, engineering. You have that. How do you utilize that? And that's where the government and the strategy is in, right?
Right. We only have 3.5 minutes left. So I can see some hands going up. We'll start with the lady first, and then we'll come to you. Can someone hand over the mic to her, please?
Good afternoon, sir.
Hold on. Did I just not say that let the lady go first? Okay.
Hi. So thank you for the very interesting discussion. I was wondering that while we say that India starts late and silicon is a very intensive industry to be in, while we have the leverage of very high quality engineers, what do you think should India probably focus on so that while we arrive at the point, we are not still kind of catching the late trains? As we are saying that, you know, the 2 nanometer kind of nodes, reaching there straightforward is not the way. We'll have to go step by step. So what are the leverage or inflection points do you see India can leverage?
Okay, so what we'll do is, we'll take maybe 2 or 3 questions and then one of the speakers can address each of them. So there was another question from the lady back in blue, I think. Can you give the mic to her, please?
Hello. My question is for Martin Chu, President PSMC. India has its quote-unquote first made in India chip, which is essentially an assembled and packaged chip. You have partnered with Tata to build India's first fab in Dholera. How soon can we expect that unit to be inaugurated, and how soon will a chip come out of that fab? And if you could give us an idea about how many nanometers that chip will be. It's Sejal Sharma from Hindustan Times.
Good afternoon, sir. How Indian startups and international partnered companies are equally benefited in this process, sir?
Sorry, can you elaborate that a bit?
How Indian startups and international companies are benefited in semiconductor industries in further, sir? I mean,
didn't
equal
understand your
benefits.
question. Maybe we can take it offline once we are off the stage. So
Okay,
maybe,
sir.
Martin, there was a specific question to you, and then I'll point to that.
All right, quick answer to that question. We plan to get the clean room ready before the middle of 2027. Then we can move into tool, and most likely 1 year later we have the mass production. Okay, and then for 28 nanometer, my understanding is that before 2030 we need to complete the technology transfer and make the mass production.
Yeah, and the question on inflection points, maybe Viresh, if you could take a shot at it.
Yeah, I think it is not how fast can we catch up, what is the differentiator? And those aspect of, you know, we are behind, let's just face it, right? We come to the party late. We're going to have a differentiator to catch up. It is not that we're going to start 2 nanometer. We're designing those chips already. In Noida, Renesas is designing 2 nanometer ADAS chip already. So it's not that we are completely out of it, but when it comes to manufacturing, back end, front end, there's got to be a differentiator, but there is a step-by-step process. It's going to take time. The surprising thing is that the people we are bringing in, partners with a lot of vast experiences, that will accelerate that learning quickly. It will still go through the methodical process. The surprising fact for me, specifically for CG Power and Renesas experience, is that the people that we are bringing in from rural and bringing into the factory, training them, sending it to our factory in Malaysia, getting them trained, they're coming up. If you looked at the video of 3 young girls coming from rural India with a, you know, single parent, some of the, you know, challenging stories. These young ladies are taking over and confidently running processes, and every day they get applauded saying, yes, this is the right way to do it. More confidence comes. That's a differentiator. That will get us quicker. But the technology aspect of it, it will have to go through step by step.
Yep, thank you. So I think we'll have to close on that count. The time's up has been flashing for a while. Thank you for being an alert audience after a reasonably heavy lunch. Thank you to the panelists for being partners with India and for sparing time to share your ideas with us. Thank you.
Thank you, Mr. Nilkant Mishra, for ably moderating the session. We are all aware the industry demands massive capital, cutting-edge technology, and global value chain integration, which would forge strong cross-border cooperation will be the key to accelerate India's journey towards becoming a global semiconductor hub. Well, indeed, it was an enriching discourse on strengthening international ties in the semiconductor domain. The importance of international cooperation in advancing the semiconductor industry cannot be overstated, and we have gained a lot of insights. Thank you, sir, for moderating the session. Thank you very much. Once again, please, there are 3 exit boards seen on the left-hand side. Please go inside the left room. I request all the fans of the panelists to kindly move to the room on the left-hand side of the stage. You can, it's a fan moment. So please, once again, sincere request to all of you. Well, the request was a little vocal, understandably so, because we are now going towards a fireside chat. So it will be more vocal there. And this is a very important session. And moderating this session will be Mr. Aarti Shivanand, a distinguished corporate lawyer with over 23 years of experience, a senior partner at AZB and Partners, a top-tier national law, and serves as the head of the Taiwan desk. Please put your hands together and let's welcome on stage Aarti Shivanand-ji. Please come over, ma'am. She has built a prestigious practice advising marquee clients in the semiconductor industry as they evolve from setup, counsel on strategic transactions, negotiate cross-border intellectual property arrangements. She works on the intersection of technology, law, trade, and geopolitical considerations in the semiconductor sector. Please come over. The 2 esteemed panelists of this particular session, I would like to call upon Mr. Vimal Anand, Joint Secretary, Department of Commerce, Ministry of Commerce and Industry, to please come over. Kindly come over, sir. Mr. Anand is currently holding the post of Joint Secretary in the Department of Commerce, Ministry of Commerce and Industry. He is responsible for the territorial charge of Latin America and Caribbean, special economic zones and export-oriented units in India, and export promotion of engineering goods as well as leather, sports goods and toys. He is also the chief negotiator for the ongoing India-Peru FTA. Hearty welcome to you, sir. And finally, Mr. Anant Rathakrishnan, to kindly come over. Mr. Anant R, functioning as Director Customs in Central Board of Indirect Taxes and Customs, Ministry of Finance, Government of India. And as he has worked in various capacities, and today he is joining us as Director Customs in the Central Board of Indirect Taxes and Customs. Ladies and gentlemen, if you've forgotten to clap earlier, here's an opportunity. You can do that now. I would straight away hand over the session to Madam Aarti to take us through, and it'll be an interesting fireside chat for the next 30 minutes or so.
Hello. Hello, everyone. I know we're at the end of a 3-day seminar, and we've all been chipping away at the topic of semiconductors for quite a while. So as a lawyer, I have to start with 2 disclaimers. One is I don't have to know the answers. I only have to ask the questions here. So all the Q&A goes to my esteemed co-panelists who have been introduced. Mr. Vimal Anand from Department of Commerce and Mr. Anant from Department of Revenue. The second disclaimer is I don't even need to know the questions because based on the answers, we'll keep developing questions. And we'll keep it really interactive. So at any point in time, and we don't even have to wait till the end of Q&A, at any point of time, if any of you have a question, sort of just raise your hand and we'll keep it interactive. So we'll start with just an introduction to say that, in today's world, as all of you have been seeing in the newspapers and media and so on, this panel is not just about policy in a very vanilla sense, because policy has really become a tool for economic wars. It's really become a way in which countries gain competitive edge over each other. And policy has really become a tool both to incentivize, companies to come in, and equally it's a deterrent for why you don't go into some countries. And so I think it's a very timely and important panel that SEMICON is having for the first time. We didn't have it the previous 2 years, policy and regulatory challenges. So let's dive right in. And my first question to Vimal, and we'll take it from there, is apart from all the policies that METI has been bringing out to encourage both participants in electronics and SEMICON, there have been other initiatives that, of course, other ministries have been, departments and ministries have been taken, like the Ministry of Commerce and Ministry of Revenue. So could you highlight, maybe 2 or 3 of the top changes that have come in? And we've heard a lot about, DLI, PLI, what ISM has done, etc. So this is an opportunity to hear what Department of Commerce has done. And here I know the answer, but I'll let Vimal go, and we'll take it from there.
Thank you, Aarti. Thank you, SEMICON, for having us over, me and Anand. You must be wondering what are we doing here as part of the Commerce and Industry Ministry, interacting with you on a subject, a complicated subject like SEMICON and wafers and OSAT. There's so many abbreviations recently that we are yet to mug up the full forms of these acronyms. But then, once an investor decides that we are getting into semiconductors and we want to set up base in India, and the initial facilitation is done by MIT and some other relevant ministries, the final, the real groundwork, the brass tacks, comprise of setting up the industry in real. And for that you need fiscal and some certain non-fiscal incentives and facilitations. So that's where we have come in. I handle special economic zones in the Ministry of Commerce and Industry. The overarching framework of special economic zones, they provide various fiscal and non-fiscal benefits to the investors who plan to set up an industry in India. It started just a few months back. I was listening to the panel discussion that was happening just before us, and there was a lot of discussion about bureaucracy and paperwork and the speed with which the government works. The kind of actions that we have taken in the last few months, that is, in a way mind-boggling by the perspective or the perception that people in general have about how the government works. We have gone out of the way to clear out policies. Some of the investors felt that certain policies, certain issues needed tweaking, some rough edges in the existing policy needed to be broadened so as to accommodate them, because there are certain very specific attributes of the SEMICON industry. Very high investment, a lot of imported capital goods, very long gestation period. So these are, then inputs from the country also, not only in terms of capital goods, but also raw materials from both India and abroad. Then you have the need to export your products outside. And maybe you would also like to utilize the big Indian market for your products. So we had very fast and very expeditious discussions with MIT and all the investors. And we have recently come up with quite a few policy changes in the SEZ regime, which has paved the way for many more semicon companies to come and invest in the country. Micron paved the way for it, and I must appreciate Micron for taking the initiative. And now there are so many semiconductors. Just last week we approved 2 new semiconductor plants in the country, one by CG, we were just listening to them, and the other Keynes. Both of them have chosen SEZs to establish their units. And many other companies must be in the pipeline. We also are, I would also like to utilize this platform to initiate dialogue with the semicon industry, with the prospective investors, and to offer them various incentives that the country already has. And if you have certain specific requirements, the entire government is willing to listen to you. And if we talked about the very top leadership, if the topmost leadership is so focused and motivated, then it must and it will percolate to the very bottom. And we are right there. We are also very focused, and we would be here to support whatever demands that you have, whatever requirements you have. So, in the beginning, it took some time, a couple of months, because there were so many legal issues which needed to be smoothened out with MIT, with Department of Revenue, the Customs Department, and of course our ground units, the SEZ units, the SEZ developers. But finally, the policy is customized for you, and the 2 other companies that we just recently approved, it happened in a day. In the Ministry of Commerce, it came 2 days before, it came day before yesterday, and today we have approved the proposal. So this is the speed with which we are working, and we have not. It happens in a very faceless manner. I never even met CG or Keynes, anybody. So that is the way the bureaucracy. That's what we have been talking about. That's where the bureaucracy has changed. It's not changing, it has changed. And it's all very transparent and very fast. The decisions are very fast. There's hardly any paperwork. Some of the paperwork that we require in the SEZs is relating to mostly land. And that will take some time, but many of the state governments, because land is a state subject, so many of the state governments are moving on to completely paperless offices as far as land records are concerned. But it may take a bit of a time, but our approval systems are very paperless and transparent.
So, and like Bimal is saying, I'm also happy to contribute here a point in saying, the SEZ authorities under Mr. Bimal, they've been super proactive. So, they've looked at initially the land requirement in SEZ, Bimal, used to be 50 hectares. And, they have on their own looked at saying that the land requirement was too much. Semicon companies didn't need so much. And they have tweaked it to say, 10 hectares would be sufficient. And after saying 10 hectares, they made very quick changes to say, if that land was allotted to you from the central or state government under the SEZ scheme, they've also clarified that it's supposed to be encumbrance-free, right? Even though state or center hold it, you could get financing, etc., and they would give you, proof that this was encumbrance-free land. So they've been really proactive, especially with the semicon sector, in saying, let's do what it takes to make the industry move forward. So thanks, Vimal, for that comment on SEZ. And similarly, there are advantages for export-oriented units and whichever, mover, the different schemes that you go under them. I'll go on to Mr. Anand to say, do you want to highlight one or two of the changes that your department has focused on for semicon industry from a revenue perspective?
Thank you. Good afternoon, everyone. So from the revenue, from the customs perspective, we are very much involved with the industry and with MIT to understand their issues. In fact, we the way semicon industry or electronics industry works is something very different from the way traditionally the import or export happens. So keeping sensitive to that changes or where there is a need for a very complex supply chain, we did several changes. One, one is in terms of making the schemes. Let us say we have something called mover, which is a custom bonded warehouse. So that is one where we did many process changes to accommodate the needs of a semiconductor industry, and we have also seen that every industry has a unique requirement. So it's not like we say you will have to go to particular tax regime. So we do have a multiple set of tax exempt regimes, which could be EOU, which could be SEZ, which could be, let's say, mover. In some cases, it could be advanced authorization or IGCR. So industries can actually see what is best for them and then choose for it. We are willing to guide this one. And from the exemption point of view, we had seen those products which require which require tax concessions. So it could be capital equipments or other things. So we have provided a very calibrated approach, and we are with MIT. Wherever MIT announces, let us say PLI, MIT announces base manufacturing. So we are with MIT or with a design-linked incentive. So there is a complementary tax concession which goes on with it, and also see that the process is very simpler. One more thing, apart from the tax, it is also about procedural simplification. One thing which we have done, especially for electronics industry, is to allow the cargo to be taken to the factory. We understand that semiconductor, the components are very, very pristine. So it could be, let us say, if at all it needs to be examined in the customs area or in the port or in the airport, it could become, it could attract a dust, it could attract something else. So we had allowed the semiconductor units to take it to their factory, and if at all there is a need for any customs related interventions, that will be done at the factory. So this is one which we have done, because it is a very bold step, let's say, because traditionally there is a need for, there has been a lot of behavioral or mindset change to enable this to happen, because allowing the goods which is not cleared to take it to their factory was not done in customs in India at least. So that's one which had been extended for semiconductor, and we hope to see that that will facilitate the confidence of more investment into semiconductor. Thank you.
Yeah, go ahead.
Anand just said, when an investor or prospective investor comes to India, the government of India, apart from the state government, the respective state governments, the government of India offers a kind of a garland of various schemes and incentives for the investor to choose from. And depending on the unique requirements, the unique attributes, the unique demands of each investor, the investor is open to choose which of the schemes or regimes are they going to choose. For example, he has named more. There's, of course, we have the special economic zones, the 100% export-oriented units. The Moore scheme is there. Then we have EPCG scheme, the export promotion capital goods. We have advanced authorization. All these schemes are there. And if you are import heavy, of course, semiconductor industry is requires a lot of import of not only capital goods but also raw materials. So very, very import intensive industry. So if you have, and then maybe an investor would like to make India as a base, make in India and make for the world. So they would be export heavy. Some of the investors may do export and would also want to utilize the Indian market, domestic sales. We call, in SEZ terminology, we call it domestic tariff area. So on one side we have SEZs, and outside SEZ we have the domestic tariff area. If you have just the requirement of incentives on the capital goods that you import, so you have EPCG. So you have all these things to choose from, and maybe a particular investor may not get everything that he wants from any particular scheme, and for that we have already shown you the way. I mean, we have done so many reforms in the SEZ regime, and many are in the offing. Quite a few reforms are already under consideration. So you should come and talk to us, not only MIT, we are all there for you. Reforms are, in the process. I mean,
we're all curious about how the government works, usually, when there is something as complicated as SEMICON, because each of the substances that go into making the chip come to us today from all over the world. So we just heard today about, how technology comes to us now from outside. From the previous panel, Tata Fab started with the PSMC technology that came to us. But there are several other things that we need apart from technology, right? You need several kinds of gases, substances, products, water, purified water that has to come in from somewhere else. So there's a whole plethora of substances, goods and services that come in order to make this work. So my question to both my co-panelists is, with a nuanced supply chain where each of those products touch more than 20 plus countries, it comes in, and we have, several ministries, several departments that work together. Can you, and because, we want to also keep up with the time, I'll make this composite questions, which lawyers are very good at. So the composite question is, what is an example of, a problem the industry is facing right now, semicon industry, that you know it is a problem and you're trying to work towards that to solve it? And what is an example of interministerial cooperation to solve such a problem, right? So it could be anything from substance import or filings, or you're not able to find the export market, but you're doing it domestically. So what is it that you would like to elaborate on? A problem that is being faced, and an example of interministerial cooperation to make that happen. Thank you.
In fact, in case of semiconductor, it has always been interministerial. It is a government as a whole. When SEZ policy was changed, it was MIT, Department of Revenue and Department of Commerce all sitting together and finding a solution. Or maybe if it is, I'll not go into semiconductor components, but electronics as a whole. Let's say when we had given some concession for display assembly, display panel, and when it was a consulted, very well consulted, and definition which is given, and a clarification which is given, which seemed absolutely clear when it was issued 2 years ago. But then when the technologies change, when the new components come, and then it looked ambiguous. But we were very clear. We had consultation with MIT, and MIT was also very proactive in clarifying, so that there is no. It was taken in the right sense.
Yeah.
Thank you.
Handholding that has been provided by MIT and some of the state governments where the pioneers in this industry have chosen to invest. And I know how the government of Gujarat came forward and held their hands and gave them all the support. And it was the initiative that the state government of Gujarat took was phenomenal. See, when you set up a plant, you need, for example, you mentioned water, the land that you require, and environmental clearances. So that's where the state governments come in play. And the regime that you choose to invest, the fiscal and non-fiscal regime, the ease of doing business for setting up a plant, there the central government comes into play. And the recent SEZ reforms are one of the very novel examples where all the relevant ministries, he has already named MIT, the Department of Revenue, including the Customs Department, and of course the Department of Commerce. SEZ, there are three kinds of fiscal incentives that are provided to a unit which would like to establish an SEZ, or to a developer who would want to, because the recent recent reforms that we have done is for the semiconductor investors to set up SEZs as a whole. And in the SEZs, minimum 10 hectares of area, in the SEZs, they can not only set up their own plants, but also invite other allied units which are going to be, a strong links in the supply chain for them. They can also set up base in that SEZ. And 10 hectares is just the minimum area. You can go up to whatever land that is available for you. So, the incentives that you have is the customs exemption on the capital, the customs exemption on the raw material, and then if you procure from the DTA, you have the zero rating IGST, GST zero rating. And this is where we interact very closely with the customs department, because it mostly pertains to customs. There used to be direct tax incentives, but they have all been sunset. So we mostly have the indirect tax benefits which are available in the SEZs, besides the very, very important overarching factor of ease of doing business, the single window clearances, the presence of the customs official right at your doorstep in the SEZ. You don't have to go to an airport or to a port to get your goods cleared. So that ease of doing business is immense, and that reform is already in progress. Further reforms are in progress. So there's a very close interaction within all the ministries of the government and the state governments. And before I conclude, I would also like to summarize the recent reforms. You named a couple of of the reforms that we have done. The first one is, of course, we have reduced the land area size, the contiguous, it has to be contiguous, from 50 hectares to 10 hectares, depending, because if an SEZ investor wants to set up an SEZ, I'm not talking about an SEZ unit, you can always, set up a unit inside an existing or some other SEZ, but then you can also establish your own SEZ. For that, you may not require 50 hectares. So we have reduced so now the two companies that we have recently approved, they have much lesser area requirements. Micron required around 37 hectares. So we have, looking at the demands, looking at the attributes of the industry, we have reduced 10 hectares. Then mortgage, because of the ISM, because ISM is also doing the viability gap funding, it is also contributing to the financing of the project. So one of the requirements is that immediately after you take the land on lease from the state government, you have to mortgages to the ISM. So that immediately creates an encumbrance on the land. So we have eased it off. We are saying that we'll not take it as an encumbrance if it is to the ISM or any other state or central government organization or the government itself. Then we have also facilitated, we have opened up toll manufacturing paradigm, because it's going to be one of the most adopted practices in the semiconductor industry. So we have enabled toll manufacturing, and at the same time there's a very strong requirement an obligation, in fact, in the SEZ regime of having NFE positive, that is the net foreign earning, that should be positive. So we have made some relaxations also for our toll manufacturer. Maybe there's some other requirements that are coming from the industry, we are considering them. Maybe some more changes will happen depending on how strongly you demand those needs. Thank you.
Thank you. And the last question from me for the panel, since our time is very close to up, is if you just zoom out of India for a bit and forget our policies and ministries and so on, and it's sort of like a global question, is that, US controls how goods move, or rather the chips move throughout the world through their BIS, right, through the Bureau of International Standards. And they have pretty much like one person who sits for all of Southeast Asia, who controls, chip movement. If it goes to China, they have a problem with it, and they're trying to administer how these controls work and how the chip flow works. From an India perspective, because we're not, a signatory as yet to the RCEP, the Regional Cooperation Economic Partnership, we are sort of charting our own story in terms of how we're going to grow, what sort of talent we have, how are we going to develop indigenous IP, and we need a whole different panel to discuss each of those sub-issues. But if you just have 10 seconds each of you in saying, is our approach, which is sort of very unique to make Viksit Bharat, and how Prime Minister said at the inaugural speech that we, less paper, more wafer. So looking at it, is there a way you look at from your perspective of establishing controls and doing ease of business that you want to comment on how the world order is going to play out, or how you think, policies will evolve given how, global chip story is playing out? Any large comments?
I'll be brief because the time is up. Of course, one is about India is more focused on FTAs, which is on taxation. But in case of semiconductor, taxation is less of an issue. What we also do parallelly is to have bilaterals with many countries to see that there is a green laning of the import and export. Let's say what we are experimenting with Singapore or with UAE is to have harmonized procedure so that we cut down on the process to do an import and export. Because we understand that always semiconductor industry has a lot of movements which takes place. So this is how we see it's not relating to only the bilaterals. We have a lot of agreements with country. We are cooperating at
FTAs.
the FTAs level.
Okay, thank you. Vimal, comments?
We are learning a lot from all across the world. But semiconductor industry is something which is very new to the country, and we would be relying a lot on the prospective investors, those who have already started the units in the country, and those and the entire stakeholders, the gamut of stakeholders relating to the semicon industry, to come and talk to us about how the changes are happening in the world and what is missing in India. We also keep a very close tab on what is happening across the world. And in fact, we not only when it comes to quality control, or you talked about BIS, it's something that is creating problems not only for semicon industry but to all the sectors of you name them, from steel to leather to toys to electronics. So this is something that is already in the works. We interact very closely with the Department of Consumer Affairs. But at the same time, if you have to make in India, if you have to make India a manufacturing hub, and at the same time have in the last panel discussion, there was a talk about the quality, So it's very important that our products have the best of quality in the world. Otherwise, I mean, it won't serve the purpose at all. So if we have to maintain the quality, it's very important that we must have a quality control regime in practice. So that's why QCOs are important. The BIS that's where the BIS comes into the picture, that only the quality product should come into India and go into the supply chain of the products that are completed or that are manufactured in the country. So that is one aspect. The other aspect is we are also very closely and growingly getting interlinked with all the other countries through, Anand talked about FTAs and many other MOUs that we keep signing, not only on government to government, but also department to department, and organization to organization. So those changes are happening. We are learning and we are growing. I would call forward all the stakeholders from the semicon industry to tell us more and give us the guidance to pave the way further for you.
Great. Thank you so much, Vimal and Anand. And it's a wrap for the panel. So do we have time to take a question? Okay, go ahead.
I'm MP Dubey, Advisor Policy Alsina. Recently the semicon industry who are facing the challenges, basically it is the restricted import on silver and gold. So if the solder ball is basically above 3% of silver, now that fall under the restriction and it is very critical material for the semiconductor industry. Similarly, gold is also one of the things. The recent, the gold potassium cyanide, which has been restricted as a compound, that also severe impact to the semiconductor and electronics industry. And the material after getting the approval, then custom used to hold it, send it to Chennai for testing, and it takes 2 weeks time. So it is an operational challenge for the industry. This is, I request Ministry of Commerce should take up this matter. Second is QCO on steel and copper, because steel, specialized steel tubes, which doesn't manufacture in India, require for the gas to be going from one place to another place. So, thank you.
You noted the comment.
Should I respond to that? Yeah, QCOs, we are already working on that with the Steel Ministry, and it is our viewpoint also that wherever the steel is very specialized and it is not manufactured in the country, it should be allowed to be imported. It should be exempt from the standards. And there were some instances of some, I won't call them unscrupulous elements, but then there were heavy surges in the import of gold and silver, and camouflaging them in the form of gold or silver alloys, because some duty differentials were there. So there was a temporary restriction on the import of such precious metals. We'll keep, we have noted your point, we'll keep it in mind, and we'll make some special considerations for the your industry.
So copper, at least you can exempt it, copper, because it takes much time.
So given the time, sir, so specific complaints and ailments off stage, and one last question from the lady, and then we'll call it.
Can you hear me?
Yeah.
Thank you. A lot of countries have the single window clearance system. India also does. What I have come to understand from going to countries like Taiwan is that The single window clearance over there is truly single window. It encompasses much more than the Indian approval system does. And since Sir mentioned about the mover license and the SEZ license, which are very helpful to the semicon sector, I was wondering, is it already part of the single window approval? Because it seems to be like a fait accompli that every semicon company would choose to apply for those. And if not, is there a plan to kind of assimilate it?
So India has a single window system for those clearances which come after the arrival. Let's say when you require food or when you require quarantine. And we have already started SWIFT 2.0, where the clearances which are required pre-arrival, let's say, which could be mover license, which could be your BIS certificate, those are work in progress. I believe maybe in another year or so, we would have all the certificates, license, everything applied in single window, and you will have a single dashboard. And in case you have one license, then there is, we'll also see if there is any duplicity which could be avoided. So that's very much in cards, and it is being monitored. And around 63 ministries which involves in different clearances are already on board, and we are interacting, developing a system. Thank you.
Thank you so much, everyone.
Yeah. Ladies and gentlemen, let's give a round of applause for this great fireside chat, and I'm sure the other questions can be answered offline. Thank you very much for this wonderful session. We now quickly move on to the next segment of our session, the market research and equipment and semiconductor consumption perspective. Well, slowly we are coming to the end of a couple of panel discussions, and then we'll have the valedictory after that. This particular session will be moderated by Shri Ashok Chandak, CEO and President of ISA and SEMI India, and request all of you to kindly move inside, sir. India's premier industry body for semiconductors and electronics, it goes without saying. And in fact, he has been actively contributing to India's ESDM sector growth strategies and initiatives. So please put your hands together and let's welcome on stage Mr. Ashok Chandak. Kindly come over, sir. And a quick word about our panelist, Mr. Pankaj Mohindru, Chairman of ICA India Cellular and Electronics Association, with more than 4 decades of leadership experience across diverse industries, has a keen focus towards sustainability initiatives. So put your hands together for Mr. Pankaj also. I would now like to call upon Mr. Sanjay Kumar, Vice President, AT Kearney, with deep expertise in semiconductor, data center hardware, and global supply chain, and so on. So hearty welcome to you, Mr. Sanjay Kumar. Mr. Ankush Vadera, as the leader of the semiconductor practice, Ankush is focused on shaping the growth trajectory of one of the country's most critical and rapidly evolving sectors, MD and partner of BCG. And finally, Mr. Neil Shah, co-founder, Counterpoint, is sought after frequently quoted industry analyst with a wide spectrum of rich multifunctional experience of more than 2 decades. So let's give a round of applause and welcome the panel. And in the interest of time, straight away, I would hand over the session to Mr. Ashok Chandak. Over to you, sir. I would request Mr. Ashok Chandak to take us through. Yeah.
Good evening, everyone. I know it's the end of the day, so we can see diffuse amount of people here, but no problem. We are very eminent and very esteemed leaders here, those who have got a full grasp of the overall market, particularly electronics and semiconductor related is our storyline. And they are expert in their own domain and have been involved in this industry for decades. So I'm looking forward to a very constructive dialogue, discussion, and getting out some messaging which could be relevant for most of you. What we're going to do over the next 40 minutes is looking at the high-level view of the electronics sector first, in terms of how the demand is emerging from today to another next 5 years, let's say 2030, which are the various verticals and segments. Those show the promising growths. And then within that, we would drill down into further semiconductor related topic, because this is a semiconductor event now, as how does the semiconductor demand scenario looks like. We would also look into electronics manufacturing, how it relates to the EMS opportunity, as well as the semiconductor related supply chain topics, which is the equipments and other stuff. And then sum up overall so that everybody understands how the markets are shaping and opportunities there. So the high level view, our value chain is a bit complex in the semiconductor as well as electronics, which includes the materials, the processing, the manufacturing of the components, the semiconductors, then assembly into various boards, the PCB, it goes on. And the first topic is actually what is the electronic end equipment market looks like. And there are multiple agencies which are doing the bottoms-up calculations, different methodologies, and we are getting to some numbers and some ideas actually, and that's what the point we will debate first actually. So I would first bring to Pankaj in terms of, Pankaj, how is your view on the total electronic market size? That is one, and number two, within that, the end equipment electronics manufactured goods. Because we want to differentiate also the market size and these electronic goods actually, otherwise we get confused. So let's go ahead, what your views are.
Thank you, Ashok. So 25, 26, we should be ending up with about $72 to $75 billion of smartphone output and about 145 to 150 billion of electronics output. That's what we estimate this year. But I think the question is, what do we want to become? What do we want to achieve? I have some super news to share with everybody. We today just inaugurated, Ashwini Vaishnav just inaugurated a 300 million cells per day plant. I mean, for the cynics who talk about value addition, this is one of the largest plants in the world. And my only point there was that this has happened because of the scale we've been able to achieve in smartphones. So it is all about scale and actually delivering on the ground. We've been giving projections for too long. In 2012, we spoke about 400 billion by 2020. I think we should just keep shut and perform and, you know, deliver. And beyond smartphones, we have to register strong manufacturing growth in IT hardware, in consumer electronics, in auto electronics, hearable wearables, defense strategic electronics, and industrial electronics. And you all know that ECMS scheme has been kicked off now, so that the middle, which was largely absent, that is also kicking in now very strongly. So by 2031, we'll be a very different animal, very, very different animal. We would have optimized most of the verticals. I mean, they will not be performing as gloriously as smartphones, but the void which is there, we are still importing laptops. It's a absolutely sacrilege and a crying shame that we are doing that. So all of that is going to end, and we will at least have all the nation's demand being met here and a significant portion of the supply chain being done here. The second one, I think after we have the first round, that how does it impact semiconductor demand, I think that we should come back.
We'll come back
in the next round, yeah.
So Ankush, from your perspective, as you guys have been involved in doing the lot of analysis as well as considering the macroeconomic conditions of the country, You are usually BCG kind of company creates very good models in terms of how the forecast could look like. So have you done anything in this sector? And if yes, how do you see this electronic goods demand shaping up in future?
Thanks, Ashok. So I think, two parts to your question. One part Pankaj addressed in terms of what's happening today and how it is expected to shape up. What's the ambition that we've set for the nation? Within that, when you look at the EMS sector particularly, or the the outsourced electronic manufacturing that's happening, again, with the advent of a lot of the Apple phones being manufactured in India, the kind of growth that is going on, we see this continuing to grow at over 30% CAGR year on year. What is probably today at about $50–55 billion, we see this becoming a $200 billion market by 2030. And there are two parts to it. There is a part around the design piece, which is the ODM piece, which will be about $40–45 billion. And there's this actual manufacturing, which will be about $160 billion plus. So that's, that's at the end of it, right? I also wanted to request if you could please bring up a couple of slides that I wanted to show. There is a ripple effect that's going to happen, because at the start of it, there is, ISM 1.0 has created, with the 10 approvals that are there in place, the fab that will start, or the fab ecosystem that will start developing. So if you just look at the overall value chain, you look at the inputs, you look at the machinery, you look at the fabs, you look at the whole design piece, right? And we were talking about EMS, which is in the end. Across the value chain, the outlook for India is far more bullish than the global outlook. So just a couple of numbers on the next page. And it's not about the numbers, right? Everybody will do their numbers bottoms up. It will go sort of a little here or there. But if you just do the comparison in terms of the growth that will happen, the Indian outlook across materials, equipment, fab, EMS, packaging will be at least 2x, if not more, across the space. So that's sort of the kind of promise that this holds. This is at the highest level. And then Pankaj was talking about the EMS piece. Within that, there are parts that have to get in, which ECMS is enabling. And on the next page, you will see that if I've just taken a few slivers there, you look at PCBs, you look at copper-clad laminates that are required for PCBs, or you look at display or camera modules. Here again, the growth in India is going to be far, far stronger than the global expected growth. So larger message is that the promise that India has, the potential that India has, is in front of everyone. We just need to make sure that we get the right people to come in and invest, the right policy push, and we should see a lot more happening.
Okay, thanks. I think you already shared some more detailing on that, which I was reserving for next question, but that's nice of you. Thank you. Let me go to Neil. Neil, as a counterpoint agency, you are a market research agency and get involved into multiple analytics and making the market outlook and forecast. So what are your numbers indicates about the electronics market?
Yeah, I think.
And I'm referring electronics market. Okay, let's not go to semiconductor right now.
Absolutely.
We'll go that next round.
So India is a very unique economy and market globally, right? So everyone has looked up to other markets as a big consumption market, but India is also one of the largest consumption market with 1.4 billion population, and like more than 60% of population is below 30 years of age. So there is enough legroom and for growth and headroom as well for India in terms of consumption. So you just talk about electronics consumption. So over the next 5 years, we are going to consume almost $2 trillion worth electronics across sectors. Maybe it's your smartphone or your car or your or an AI server, right? So $2 trillion. That is the total amount of electronics we are going to consume. And we'll talk more about what it means from the semiconductor point of view. But this is what it is at this point.
But $2 trillion is you are referring global demand or India demand?
That is just India demand for 5 years. Next 5 years, it's average.
You are counting year 1 plus 2 plus year 3
exactly.
plus year
Cumulative.
4 plus 5?
Cumulative demand.
No, don't. Let's not do that way.
So on an average,
I can see everybody was jumping in the air actually.
Yeah,
Once you say $2 trillion.
Yeah, since we are planning long term for next 5 to 10 years, so on an average that comes to 400 to 500 billion dollar per year.
Let's bring out the number, let's say 2030. Let's be absolutely clear.
Yeah, so 2030 will be close to 400 billion dollars per year.
So let's speak that way actually. So indication here is, because I could see the faces of the audience, that is why I immediately understood you are counting 1 plus 2 plus 3 plus 5, no problem. So we are looking at, let's say, market size, not market size, the electronics manufactured goods of roughly $400 billion as per their estimate. And I understand from IC estimate is about close to $350 billion as we are discussing. It's a ballpark in that range. The point we have to understand here is there is a huge growth which is expected. There is a huge growth which is projected for the electronics manufacturing in the country and the goods, whether it's an India brand or a global brand, it doesn't matter at this moment. But that's what it is emerging, and that creates the opportunity for all the stakeholders. And some of the opportunities, Ankush has already indicated, because that will result into some component demand that will result into the PCBs and so forth, multiple things. We'll come to that later. Let me bring to Sanjay. Sanjay is from Kearney, and he traveled all the way from US to India to attend this SEMICON, and we are fortunate to have it over here. Sanjay, after electronics, we are going to drill into the semiconductor demand actually. But before I drill down into semiconductor demand in terms of the markets, I want to understand from you, how do you see India as a destination for semiconductor manufacturing? Whether it's the fabs or the OSATs or the related supply chain and some other components related to semiconductor manufacturing equipments, let's say. What's your view?
Thank you, Ashok, and good afternoon, everybody. Ashok, first of all, thank you for motivating me to come here, and grateful for the SEMI body for inviting me here. Humbled to be here and sharing the panel with this esteemed crowd over here. So in your question, how do we see India as a destination? I think first of all, congratulations on Tata. I think it's a big achievement. PSMC and other foundries. So India jumped all the way to the top of the food chain by establishing a semiconductor foundry. I think it's a very, very big achievement. But because the demand is driven, because the investments are driven by demand, so India has done that big piece, and there is a lot more to go. How do the companies make the decisions when they are looking for investment decisions? And this value chain is quite intricate. It's thousands of companies are there in this value chain. So India has a right to play and in different parts of the value chain. So let's talk about, OSAT. There are 3 or 4 verticals, 3 or 4 fundamental axes that defines which country gets what part of the value chain. So the OPEX heavy businesses, India has a natural advantage over there. We have a lot of talent. We have a lot of human capital. So the businesses which are OPEX heavies, for example, OSAT business. Low end of the OSAT business is OPEX heavy, and high end of the OSAT business 2.5D, 3.5D, that's fully automated. In between this range, India has, because of the human capital, because of the low utility rates, because of the cheap land, we bring down the OPEX. And those are also not that CapEx heavy. So that part is, I think, a natural for India. Second thing is that there is high purity chemicals. So it takes some countries, they drag their feet in terms of environmental reviews and so forth. So if India accelerates on the environmental reviews and make single window decisions, so India also has a right to play in high purity chemicals. And third piece is essentially when we look at assembly, if we think about a camera. So there's a camera chip, but then there's a camera module that needs to be made. There's a filter that needs to be applied. Those are in the value chain. The other countries, they have not invested as much. So I was in the US Department of Commerce as a senior director. So I underwrote big deals, about $6 billion in deals. And I interacted with the European government, Singapore government, Japanese governments, and Indian governments. And we coordinate you know, what investment goes where. And if we think there are white spaces, if we track the investment done by Europe, the investment done by Japan, investment done by Singapore, and investment done by India, there are white spaces. A lot of investment has not happened. We have invested a lot in the front end. All the countries, they have tried to buy the front end, basically the fabs, by investing. But other parts of the value chain, they have not kept up the investment. So right now the lead times are long. For example, in the equipment, the lead times are long because the countries did not subsidize the equipment. As far as I know, most of the countries did not subsidize. So that investment is happening organically, whatever the companies can do. So we probably will, that's why we are a long lead time. So India can potentially leverage those white spaces and go into the value chain where the investment has not happened. Second is lower end, the margins which are sensitive, 5%, 10% margin businesses, they have not been subsidized. If we look at the equipment themselves, so there is high end of the equipments from Applied and Lam and so forth, and then there are sub-fab equipments, chiller, vacuum pumps and others. Those are low margin business, pretty sensitive to that, and countries have not paid that. So basically this is a non-sexy portion of the supply chain. And so India has a right to play over there with the right policies. I hope that answers some of the questions, and maybe I will get a little bit more detail once you ask more questions.
Thanks, Sanjay. So I appreciate your words, which you underlined multiple times. India has the right to play. Indeed, India has the right to play. And I think we have to strengthen and expedite that play quickly. Let me, after that, now get down into quickly, a very crisp answer I would like to seek from our panelists is, we have seen the electronic markets are growing and there are multiple verticals. Pankaj already indicated smartphone as one of the vertical already. Let's look at the top three verticals. Where do we see the electronics demand of the top three verticals actually in addition to smartphones? So maybe I start with Pankaj, then I go to Neil and then Ankush.
So just one input. You see, we have ignited a huge amount of excitement about a foundational industry. And there are missing pieces. You see, as I said, that the electronic industry is overly dependent on smartphones output. The responsibility now is to take a pause, and build the other verticals very systematically, very strenuously, along with design and Indian brands. If we don't do that, there will be no demand for semiconductors, right? Because let's say you have theoretically, let's say laptops. Currently laptops are being imported. We are counting it in our demand. It doesn't work like that. You have to have first the laptops being made here, designed here, then second, having your own brands so that the silicon demand can be influenced. This is the step. We have made this huge leap to semiconductors without building the sort of the middle kingdom is missing at the moment. And that is what our focus should be. Not only for IT hardware, but consumer electronics, appliances, air conditioners, wearables, auto electronics. Auto electronics, we are working on estimates of $45 billion by 2031. All this has to be enabled, you see. All of us have to work together and see that the two pillars of the establishment of the industry, which is GVCs, their lead firms who bring the supply chain, and building the Indian design and Indian champion companies who go global. Because we all decided that we are not going to discuss geopolitics, geoeconomics here, which is what a relief, because that's all we've been discussing for the last 4 or 5 months. So purely on establishment of the industry, I think beyond smartphones, Ashok, that answers your question, that the $350 billion manufacturing target, I think smartphones will have to do some heavy lifting go up to about $150 billion. And we cannot say, one of the panelists in our pre-discussion was saying that, well, there is going to be no demand of silicon from the smartphone industry. We can't have that thought process. By 2030, 31, we should be having our own silicon, right? That's why the Semiconductor Product Design Leadership Forum has been put in place to work on that very, very seriously, right? Then the IT, which is the laptops, etc., the other heavy-hitting segment, there also we should be able to turn out about $30 to $35 billion. Amitesh ji worked so hard on the PLI 2.0, we are still struggling with it because that's a hard nut to crack. But very serious effort is going on, and I think that requires more concentrated effort to see that all the big players are here producing and Indian brands are here. That will also, there also we have to work on our silicon. That will actually add up to the demand. Otherwise, what Sanjay was saying is that currently the residual demand of what is available is very tiny. I like him to repeat that, what we were discussing at tea before this. So the very serious tasks are in front of us. Let us stop being Vishwa Gurus for the time being, and for the next 4 years, 5 years, put our heads down, slowly build all these segments and deliver this number for the nation.
We're doing a pre-alignment on 2 topics actually. One is we are not discussing geopolitical situation here, but that is more of the uncertainty topic which in the short term. We're to look at the long term, how India plays into the overall global value chains. And number 2 also, it's very important what Pankaj just mentioned, that it is designed to manufacturing that would matter most. Currently, a dependency on a smartphone is there. Most of the global brands, nothing wrong. I mean, that also adds its own value and important for the country. But we have to look at how we get into the designs of the electronic products. And there are other sectors that show a lot of promise, as we have seen in industrial and automotive particularly, including some of the consumer appliances. There is a good opportunity to do the local designs, local brands, and also build up further. So let me bring to Neil first actually. Neil, how do you see the other sectors in terms of the electronics demand perspective actually? How is it unfolding next few years?
I think the next few years, I completely agree with Pankaj. The next few years, it's going to be more about the 2 low-hanging sectors for us, I think, is industrial and IT, followed by consumer electronics, and then automotive. So if you look at industrial, why it is low-hanging opportunity for us, because there's so many multiple segments, right, from smart metering utilities to smart grids and other industrial automation, because we are getting into this manufacturing era where we are manufacturing everything, right, from smartphones to white goods and others. So I think industrial automation is going to be a low-hanging opportunity for factories. And at the same time, we are also upgrading our energy infrastructure. So smart meters is also a big opportunity. And since we have a lot of fabs which are coming on the mature node side, a lot of chips and electronics, semiconductors we are going to manufacture are going to go into these industrial sectors and applications, because these does not require NVIDIA or Qualcomm type CPU, GPU, which we are not going to anyways manufacture for next 3 to 4 years. So from that perspective, I would say industrial and IT is low-hanging opportunity. Within IT also, if you look at, like Pankaj said, we need to follow the same process which we followed for smartphones to make sure that 99% of the laptops are manufactured in India at CKD level, not just SKD or imports. Similarly for wearables, and similarly for servers and other storage systems. So that will drive a lot of domestic consumption and ecosystem around to suffice the electronics and semiconductors opportunity for that particular segments.
Great, thank you. So now let me go to the next element, which is related to the semiconductors, and why I brought electronics first is from there, the semiconductor consumption gets derived actually. So I will come to first now to Ankush. Ankush, how do you see your modeling of semiconductor demand in future? and I want to clarify to the audience, the way we want to look at right now, the semiconductor demand is, whatever electronic goods consumed in India, whether the semiconductor is purchased locally or not, whether it is ordered and received as a chips or it is coming as a kits, we will count everything together, because that is the total semiconductor consumption, just to make sure everybody comes on the same page. By assuming, just as a hypothetically, if everything was built here, everything was purchased and supplied here, what is that demand going to be? It's a different topic, because we know that there are a lot of kits being imported. So you don't place the order for the chips and ICs also in many equipments. Sometimes you place the order to the overseas suppliers, because obviously India does not make much of a semiconductors today. So let's not worry about that. We look at the total consumption aspects of the semiconductor chips, which is not only integrated circuit, but the power devices and sensors and anything for that matter, which will be in the category of semiconductors. So Ankush?
Sure, thanks.
What do you say?
So, Ashok, what I would say is that if you look at a semiconductor lens, the overall demand by 2030 will definitely cross $100 billion in India. The requirement, right? The consumption. And of course, you know, it is 105, it is 110, 115. You know, my guess is as good as yours. So, but that's how we see it playing out. Number one. Number two, in line with the end sector electronic demand that we were talking about, manufacturing demand, we see about 49 to 50% broadly coming from mobiles and wearables within this. And then we see a similar range share, anywhere between 7 to 12% for the next set of top sectors, which will include telecommunication, industrial, consumer electronics, auto, and IT. And there will be a low single digit but substantial demand that will also come from aerospace and defense. So that's how we sort of see the whole space playing out.
So you indicate it's going to be about 100 billion plus, maybe 115, 117, whatever number it can come. Nobody has predicted the future precisely. Pankaj, based on the ICA analysis, where does the number stands?
You know, this, it will be 100 approximately based on demand, but that's a notional number. I'll again repeat my hypothesis that a product designed in China, made in Vietnam, consumed in India, should not be, and of an American brand, is not really our demand, right? It doesn't matter. Unless we go nuts, like one of the countries has gone, that we decide to weaponize our market access, but we decided to stay out of geopolitics and geoeconomics. So the process of design, you know, first semiconductor design or first product design, system design, I think the silicon guys will also have to play a big role in the product design by offering the system design altogether, because the entrepreneurial talent of India is, you know, I can use the word a little superficial. It's very ebullient, but it doesn't want very deep, patient work over decades. So I think providing systems will be very important for the silicon guys, which is the full system design. And we saw the complete radical change of the smartphone industry because of what happened. So 100 billion, yes, if it makes us happy, but if out of this 100 billion, 50 billion is solid Indian design, Indian brands, silicon demand derived, that will be real value. And also the silicon designed by Indian product companies. That is what will give us the real foundation of a strong nation.
Great, thank you. And that's a very important point. Neil, I want to come to you because we know that a lot of semiconductors are coming as a part of the kits. So even if it's a global supplier, but even the orders are not placed over here actually. Because when I speak to the semiconductor chip companies, ask them how much business they do, so it's hardly counting into few $1 billion actually, while based on the end equipment market, it's about $45 billion worth of semiconductor which is consumed in India. So have you done any analysis in terms of what is the locally purchased, or today's locally purchased components may be supplied from outside, doesn't matter, but at least purchase orders are issued from here for semiconductors and removing the kits portion actually.
Right.
Well, at least there is some control on that actually. So you have done anything analysis on that?
Yeah, we have done a lot of deep analysis by sector as well. So if you look at the locally built and locally produced together, right, that comes to around $2 billion right now, but which is still just 9 to 10% of the total semiconductor consumption right now. And like Pankaj said, if we have more indigenous designs, indigenous players and fabs who can produce this and add value, we can easily reach like $20 billion out of the $100 billion. So 20% mark, that should be our minimum target. But if we have more fabs, if we have more indigenous players and more foreign players coming and doing a JV and also sharing knowledge and building in India, designing India, I think we can reach more than 30% by end of 2030. It all depends on how we put out our policies and infrastructure, build that.
Ashok, I just wanted to sort of build on what he said, because you mentioned policy, right? And I think that's where we should again look at how ECMS is playing out, because ECMS is fundamentally enabling not just for the phone but for all other sectors that we're talking about. If you take the bill of material, if you open that end equipment, you will see that many of them will have a camera module subassembly, many of them will have a display module subassembly. Everything has to have a PCB, everything has to have passive components. So once we are fueling through policy local manufacturing of these components, the design element will then get enabled further, right? That is what will create local design.
Okay. Sanjay, you want to put any comments here? I know you said you don't want to empathize the numbers, but let's say in terms of the trends as we take our journey on semiconductor manufacturing, and considering this demand which is getting generated may not be fulfilled everything locally. But how do you see this shaping up actually? I mean, what are the opportunities for India? What do you see?
I think, the panelists have made the astute remarks. Pankaj asked me to comment on the earlier discussion we had, that, even though we are exporting 20 billion or 50 billion, whatever the smartphone we are exporting today, but the buying decision of the chips are done in US or Europe by these companies. And they already have an established supply chain. They get their chip manufactured at TSMC, Samsung, Intel, and whichever the companies they get manufacture their chips. So they are not, those decisions are done over there. Those decisions are not done in India. And for them, it's a lot of change of cost to qualify a new fab. So there has to be some magnitude order of, I would say, gains for them to take this cost of change. Either the quality has to be better or either the cost has to be better. But that's why we need, China can be a study for India, how China did it. So if we look at a smartphone, so there are a lot of components in the smartphones. They are of different complexity level. Yes, we cannot maybe design a 5G modem right now, but yes, we can design a Wi-Fi chip in India. We can design a display controller chip in India. And if we have those companies who are actually making those designs and qualifying, then we can generate the demand for India. So I think that Pankaj already also mentioned, and other panelists also mentioned, that we need to have our local design system, ecosystem come up and our chips getting into these smartphones. Second is the opportunity, adjacent opportunity is there, because once we have the EMS segments, whether we are assembling laptops or servers or smartphones, the modules manufacturing, so this is how it happened in Taiwan. They started making modules first, then they moved up in the complexity. And I think the same playbook can be done over here, that we have to go from assembling not just the PCB, assemble the modules. Just to reiterate the camera module example, I mean, you take a chip and then you put a lens on it and then you assemble it. It's quite sophisticated product by itself. Now we have $20–25 billion export. I think the policies should encourage those types of businesses to come from Taiwan to here. So those businesses who have to locate from Taiwan, so there is already a demand pool in India, local demand pool in India, because we are exporting smartphones, laptops, servers, and to these. So there is a demand pool. Now we have to incentivize those companies to build a supply node in India. So they have supply node in Taiwan, they have a supply node in Japan, they have a supply node in Korea. So we need to pull those companies in, bring those module manufacturers over here. Along with that comes the people who supply to them, the chemicals, the whatever they supplies. Along with that it comes. And that's one axis. Second axis is China's playbook, which is design the components on these electronics, less complexity components. For example, electronic motor control units, electronic power supply. So there's enough local demand in India. Those products are of less complexity. We need to bring up the design capabilities, and then we can supply these from India. So mix. So India's opportunity is not 2 nanometer, 3 nanometer, or even 28 nanometer. It's I would say specialty fabs, power electronics, RF, which are of less complexity, less capex, and with the local demand already there. I think that's where India's opportunity is. I think this has happened in China also. If we study what happened in China for last 20 years, that's how they grew from 100 some nanometers. So they supply the largest. They are the largest suppliers of PMICs to the Western world, power electronics chips.
Thank you. So I think we have 14 minutes more left. I would use 4 minutes for a quick, sharp shooting question to everyone. We keep talking about make in India, make for the world. So the question is very simple. In a semiconductor industry, do we have opportunity to make in India and export for the world? If yes, what are those product categories where we could focus on? So we can start with Neil first from the end.
Yeah, I think with all the fabs coming up in matured nodes and so many design houses also cropping up like Moshchip, Tata, everyone. So I think there is a lot of opportunity for power electronics, and that is going not only for domestic, for world as well as the MCUs and power, I would say display driver ICs, also PMICs as well, I would say. So these are the top 5 applications which I think we should be able to.
Ankush?
Within the semiconductor value chain, one place where I see make in India for the world would be the sub-modules of the semiconductor capital equipment. And this is, the logic behind this is we are a low-cost manufacturing nation, number 1. 2, we have very good machining capability. We know how to do precision manufacturing and machining using material sciences. We do that for aerospace, we do that for auto. So, bringing this together and doing a lot of semiconductor equipment sub-module manufacturing is something that I see India doing for the world. And there are already examples of some small boutique players who've started doing this from India. It's about scaling and growing it.
Okay, thank you. Sanjay?
Just reiterate the point already made, that we have these capabilities and then we have the opportunity to branch out. There are a few companies already exploring business in India, the semiconductor equipment companies, not the very high end of the applieds and the lamps, but the component that goes into the applied and the lamps. Those companies are already exploring JVs and tie-ups with Indian companies who make the precision, who are in the precision industry already. And the second is that yes, once we make a supply node to these module makers, then we can start exporting those capabilities to the rest of the world too.
Interesting point. Pankaj?
India is not going to be a vertical sectoral economy. We are going to be the largest economy in the world, firing on all cylinders. So when it comes to a foundational and the most critical industry of the present and the future, that is semiconductors, we cannot have a toe in the water kind of approach. We have to, for example, AI, GPUs, compute, we have to work on that. It's a 10-year program. That is what our focus has to be. We have to power the smartphones. We have to power the, compute devices. Those are the big boys, right? What I was saying earlier is that there is going to be certain domestic demand which can give a leg up to our design companies, right? That's all. But what we have to design, produce, your exact question, will be for the world. And in 10 years' time, we have to be the major semiconductor country of the world.
Indeed.
Can I say one last word? Something came to my
30
mind.
30 seconds.
15 seconds. I mean, one thing is AI infrastructure demand has quite picked up a lot, and that's a low complexity things. For example, liquid cooling. And right now there is not enough capacity to go around in the world. I think that's another opportunity, AI infrastructure.
Great, thank you. So we'll take another 7 to 8 minutes for audience. You have been also keeping a confidence in the panelists to stay in the hall. So I need to give you a time actually. So can somebody move the mic in the audience if somebody has any questions or want to make any points? Yeah, we have already hand is raised there.
Sir, since AI and semiconductors are converging, and India is trying to make itself a world's most largest semiconductor hub, how do you see the opportunities growing in India for students in next 10 to 15 years?
Ankush?
So I think you've touched upon the most pertinent point, that most of the people who've already made investments, made moves in India are struggling with, and that struggle has a huge opportunity, and this is the skilled talent that is required. So, way back when I graduated, I was intrigued by VLSI and chip design. This was early 2000s. But at that point of time, it was, these kind of opportunities were not there. So, we produce the largest number of STEM graduates in the world every year. And there is huge talent requirement here. So I think the opportunities are tremendous. It's just about the student population also needs to start having a mind shift of saying, I'm going to specialize and I'm not going to be a jack of all and master of none.
Thank you. So we have a question here.
Yeah, good evening, everyone. My name is Mithilesh. I'm part of a mental health organization for a health tech company. So my question is with Mr. Ankush from Make in India for the World approach. How India look like for a healthcare wearable devices?
So definitely very promising. Reason being, if you look at, if you sort of go back in time and if you look at post-Obamacare, right? What had happened was that a lot of specialized equipment needed to be de-specced and be made more affordable. That's what India needs and India has needed, number one. Number two, given the healthcare setup that we have in India, you need a lot of remote monitoring and remote assistance that you need to provide. Both of these will be done only with the use of technology, as is being done, and I'm sure you're aware of that. So tremendous potential. This is again a place where India is and will set an example for the world. The adoption of what we create will more be in developing nations, right? Not in the most developed nations where the healthcare systems are far more mature, but tremendous opportunity.
Thank you.
Okay, any more question? I think there is one last
I had a question here, right at the back. So this is directed to Pankaj sir and Mr. Sanjay. Both of you mentioned a kind of policy push, and when you said servicing the demand of EMS. So kind of a couple of questions there. First one is how much of the policy push do you think will be an enabler as well as addition on top of, let's say, the organic demand that comes in EMS and electronics manufacturing? And if you could put some kind of numbers to that, like whether, like what parts of a policy environment can be a make or break for continuing the growth in demand of EMS manufacturing?
Okay. So right now the decision, the way the companies make decision is that they have a supply node and they want to bring that node to India. So they have to contend with the economics of it. So yes, India has a natural advantage, maybe in terms of the land prices and other things. But then there is the equipment that they're buying. So this is undepreciated equipment. So first for 4 or 5 years, about 20% of their gross margin will be impacted by, but it's a rule of thumb, don't quote me, it's a rule of thumb, about 20% is gross margin. So the way I evaluated the applications and how much to subsidize, it was basically looking at the business case that yes, this is the amount of the money that's required for this company to compete if they go and bring this new investment here. Otherwise, their cost of production will be higher. So depends on the business. I am not expert on the businesses that serve the EMS segment. On the semiconductor side, the front end side, it is 70 to 30. 70% is equipment, 30% is land and other things. So that 70% is undepreciated, land is undepreciated. So basically the formula is take a look at it, make it even play so that they can, right from the day one, they start producing. They are producing at the same cost as their, whichever the country they are coming from, where they have depreciated assets. So that's how you make it level playing field for them. And so local demand is there, and as long as the cost of production is same over here, I think they have a very strong incentive to be here. For various reasons, they have incentives. One is, okay, the logistics. They already save 5, 6, 7% because they don't have to ship. Second thing is that the geopolitics, this is more resilient. They buy protection against the policies, tariff barriers. So they buy protection already. So it's a very advantageous for them. So as long as we make it economical for them to produce here as where they are today as the cost base.
What is the specific question?
Right, sir. So specific question was like how much of the policy push is kind of an enabler without which the kind of organic demand growth, because of the factors that sir just mentioned, won't be possible, and what are kind of the critical make or break policy push? Yeah.
So let's take hypothetically $350 billion is what we've set out to do, which is overall $500 billion. So we are not against lazy countries like the West and so on, You are against tiger economies like China and Vietnam and all. Okay? They are tigers on the prowl. So, and it's winner takes all. I mean, whatever the West is trying to do, set up fabs there, etc. I don't know how it will, pan out. What will be the yields there, etc. Because, I don't get a feeling that they have the ear on the ground so much. The kind of, spunkiness you feel in these Eastern countries. And I think India is equally hungry. But without policy support, whatever we have achieved till now can also go back to zero. We've had that situation. So for the next decade, you will have to be like that. And India is changing very fast. Yesterday, the GST rationalization was happening, and the revenue secretary, no other than the revenue secretary, when asked what will be the revenue loss, said there is nothing like revenue loss in this country. There are implications on revenue. So it's a completely different India, which is also hungry, which is on the prowl, and the policy makers are now, behind the businesses and not monkeys on their shoulder.
So could you list out maybe 2 or 3 very specific?
So I think we can last minute, and want to the time actually. So thank you very much, as well as my fellow. How does it conclude? There is a major growth we expect in electronics manufacturing. Number of 350 billion to 400 billion is the range we're looking at. Not worrying about the precise number, but the growth rate and the CAGR are very healthy and very robust. Number two, the semiconductor related demand, which is translated from electronics, is 100 billion plus. Again, substantial and very huge. But also to look at what could be built over in India, in products, India brands that will create the demand for really design in India chips is also we have to look into. And that is what is going to be really very important stuff. And the third important point which is coming up is on the semiconductor manufacturing related topics. So as Sanjay mentioned, we have a right to play. And within that as well, there is something we can capture as a market for the supply chain related topics, including the components and sub-assemblies and modules that would go into the equipments as well as the gaseous chemical material. So these are the three broad areas which are emerging. I just made a note of a summary and we will continue to work on this. There are a few questions I know those are pending from the audience. We can take it up later. Thank you very much. And my display shows time up. So thank you very much. Thanks a lot, panelists.
So all of you can have a quick photograph. A photographer also will take a quick photograph. Thank you very much, Mr. Ashok Chandak, for moderating this session. And we'd also like to thank the panelists, Mr. Sanjay Kumar, Mr. Ankush Vadera, Mr. Neil Shah, and Mr. Pankaj Mohindru. We now are heading towards the final session prior to the valedictory. And this panel discussion will focus on the development of the semiconductor ecosystem in India, one of the most vital areas in ensuring that India is well positioned to capitalize on the semiconductor revolution. This all-important session will be moderated by Dr. Surinder Singh, advisor to India Semiconductor Mission. And of course, he has significantly contributed to India's communication satellite programs, including the indigenous INSAT series and the Indian Regional Navigation Satellite Systems from its first payload, IRNSS-1A. So please put your hands together to Shri Surinder Singh. Dr. Surinder Singh, sir, kindly come over to the stage, please. He has been serving as the advisor technology with the India Semiconductor Mission since August 2023. Bahut swagat, sir. And the panelists consist of Mr. Manjunath Jyoti Nagara, who brings more than 3 decades of professional experience in shaping innovative ventures and delivering transformative results. I would request Mr. Manjunath to please come over. Currently, he leads KAS Group, a leading provider of high-tech engineering projects and solutions for the solar and semiconductor fabs sector. Hearty welcome to you, Shri Manjunath. Mr. Diganta Sharma, Head Strategy and Business Development, Inox Air Products Private Limited. Yes, in fact, more than 3 decades of experience, leadership experience in the industrial gases domain, has worked internationally across business operations and innovation with a career that spans the development and commercialization of new technologies and so on. Hearty welcome to you, Shri Diganta Sharma. Mr. Sushan Mahuli, the Senior Director, Supply Chain, Lam Research India. Welcome to you, sir. More than 2 decades of experience across diverse industries. I can hear only the friends of Sushan Mahuli clapping. What about all the others? Yeah. Thank you, sir. Welcome to you. And finally, Mr. Kunal Mittal, Senior Vice President, Sumitomo Chemical India Limited. Worked for 15 years in investment banking. Yeah, that's a great response from the audience. Keep the energy going because we have the valedictory after this. Is one of the big 4 consulting companies involved in several marquee M&A and joint venture deals in India. So with this, once again, a hearty welcome to the panelists, and I would request Dr. Surinder Singh ji to kindly take us through. It's on, sir, it's on.
So we have come to the last mile I'm basically a communication engineer by training. So as they say in communication, we have come to the last mile of this mega event. You must have seen discussions on almost all aspects of the semiconductor ecosystem during these last 3 days, which have covered fabs, packaging, materials, talent, skill, startups, investment, VCs, policies, and all the regulatory requirements which are required to make such a complex ecosystem. When we say, of course, some earlier speaker has said that ecosystem word, probably you also have now heard many times during earlier discussions. Of course, in different contexts. Semiconductor ecosystem, when we say, so mainly it covers design, R&D, manufacturing, packaging, testing, and of course, delivery of products. So various aspects, as I said, are touched earlier. What we are going to concentrate in this last session, few aspects related to facility which we are trying to set up. When I say ecosystem, in India, the semiconductor ecosystem has started in the late 80s with the setting up of semiconductor laboratory, which was earlier called semiconductor complex. And of course, a first R&D center, from a global player, Texas Instrument in Bangalore. But it took us a long time to reach this exciting stage of semiconductor manufacturing in the country, which you are witnessing now. With me, they are all senior functionaries of this manufacturing value chain who are taking part in this discussion. Basically, the major component when I look at the facilities, when we have to set up facilities, are equipment, chemical, gases, and of course, the utilities which have to be put in the fab. You must have heard, you must be wondering, every time each discussion, like last discussion also, so much emphasis on chemical and gases. Though we are here to discuss semiconductors, chips, which are supposed to be an electronic component. But if you really go to a fabrication facility, you will see that you will hardly see the electronic portion of your equipment. Mainly you will see a good amount of chemical and gases, valves, running pumps, somebody mentioned in the last discussion, going around in these huge facilities. Of course, these are what are critical when we make such tiny, there are huge equipments which make these tiny chips, a network of very complex network of distribution for chemical and gases. But unfortunately, if you say till date, almost 100% of this chemical and gases which we require for these facilities are imported. So I'll start the discussion with a general question to all of my panelists, that from the operation viewpoint of what are the most critical single point dependency in their fields. Of course, they can talk that India must address in next 5 years to ensure a sustainable and disruption-free production from all the facilities which are coming up. Start with Manjunath.
Hi. I think Dr. Surinder Singh said it has to be disruption free. So when we talk about disruption free, each disruption has got a huge consequences on production of semiconductors. And that's not acceptable way of any kind of a investment efficiency. So when we talk specifically about some of the facilities that are supporting the semiconductor chip manufacturing, we talk about gas delivery system, chemical delivery system, some of the exhaust systems, and the clean rooms. So each of them have a direct impact on the semiconductor chip making. So as you rightly said, we don't see any electronics in the chip making in the fabs, but what you see is about the chemical engineering perspective of manufacturing these chips. So setting up such facilities is going to be a very, very hardened task. It's not going to be an easy task. So the fabs have their own requirements to ensure such facilities are up and running 24/7 without a smallest blip in their performance. And that's where the quality systems and the reliable engineering comes into place. So talk more specifically to make sure audience get a perspective on this is, let's say a gas cabinet, which is used for delivering some of these toxic, hazardous, and pyrophoric gases into the process while making the chips. The system reliability is done for years together to ensure such cabinets are meeting the requirements of safety and the reliability. So such systems are tested for leak rates of 10 power minus 11 millibar liters per second. So you can imagine in a common man's language is a 10 power minus 5 is about 1 cc of leak over a period of 30 days. And we are talking about 10 power minus 9 or minus 11 leak rates. So it's like unimaginable decimal of 1 centimeter cube in a 1 month. So to do that, you need a lot of engineering expertise. Unless vendors meet such kind of expertise or reliability of the equipment, such fabs would not accept such equipments to deliver gases into their fabs. So where are we as a nation in this? Of course, we never had such kind of a gigantic opportunity ahead of us, so naturally the system did not really grow as fast as possible. But solar industry has taken off, and some R&D semiconductor has taken off in last 2 decades. Given that there has been some element of local expertise that has developed. So as a company, we have done a lot of such installations for solar companies and some of the semiconductor R&D facilities, including SCL Chandigarh, IASC Sense, and CSR facilities and DRDO facilities. But that's not sufficient. Because here we're talking about a large fab of investment up to $10 billion. So there will be a huge amount of learning, and the only way I see is how do we collaborate, connect, collaborate, and contribute into this ecosystem. So a collaboration between Indian players or Indian companies with the global expertise or a company with a global expertise is very, very vital today. So that's how we can make this disruption free. Otherwise, going through everything outside India is also not going to be a very valid hypothesis here, because then we'll always be dependent outside India. At the same time, expecting the Indian ecosystem to support in every angle is also not going to be feasible to begin with. So it's going to be a collaboration approach, and that is going to make us a more reliable ecosystem in the next 3 to 5 years.
Thank you. Can Diganta take this?
Good afternoon, everyone. Thanks for having me in the panel. Gases, as you know, are called the invisible backbone of the semiconductor industry. We can't make any chip without gases. So the supply chain for that needs to be safe, reliable, dependable, and available whenever needed. So as Manjul was saying, we are a little bit just starting the journey on the semiconductors. But if you look at the demands from the semiconductor fabs globally on the gases side, the basic demands are that you need ultra high purity at PPB levels of purity. You need capabilities to handle those gases, those toxic, those pyrophoric, and those hazardous gases that come in. You also need the capability to distribute it locally, have the last mile connectivity from the production site to the fab, and you also need people who will ensure this whole chain in terms of supply reliability, quality, and safety. So at Inox Air Products, we are very excited to see this opportunity. We also see this as a challenge as well as a great moment to contribute to the nation's first and upcoming fabs that make in India process. So we are already investing ahead of demand in large manufacturing sites for ultra high purity specialty gases. In fact, we have just announced a 500 crore investment in Dholera to build air separation units, hydrogen plants, and specialty gases facility there, so that we are co-located or next to the real hub of the chip making. We have already commissioned India's first ultra high purity nitrous oxide plant earlier this year to support these kind of specifications. And obviously, since we have been, our company is a joint venture with Air Products of US, with their global reach and expertise and years of association with the major fabs around the world, be it in China, be it in Taiwan, be it in Malaysia, Singapore, or Israel or US, of supply chain management of ultra high purity gases. We are bringing all that into India already. And as we said, we have made baby steps in the solar side of things, and now we are bringing the same level of, I would say, diligence, the SOPs that is required to safely and reliably deliver these gases, and also the quality assurance bit of it. We are investing also in talent pool, on training programs, of hiring people from in the best places around the world to make sure that we are ready for this. But as I said, the other thing that is really required is the support that we need from the governments of either the central or the state, like PLI schemes, duty waivers, quick approvals, and storage, etc. needs a lot of pollution control clearances and so on. So this is the other thing that is really required. I would say that we are very well poised with the global collaborations we already have place, and many more which is on the way, plus the deep knowledge in the supply chain of semicon industry. We feel we are truly ready to support this. And as many of you in the audience know, we have been the lifeline of the oxygen in the pandemic, and I feel we will be the lifeline of the semiconductor industry going forward. Thanks.
Sushan.
Yeah, hi, I'm Sushan from Lam Research. To answer your question on single point dependencies, which are very critical, they are very immediate need for the next couple of years, is I would put it twofold. One is awareness of what the value chain is. We have been trying to develop, we have been involved in the development of this ecosystem for a couple of years now. I think that's taken a lot of efforts on building the awareness. Where does this ecosystem start and what is the interlinked value chain? I think awareness is very, very important. At this end, alongside that, understanding the requirements and differentiating it from the existing sectors that the ecosystem is familiar with is very critical to overcome first. Once that is done, when we are aware of what I can talk from an equipment manufacturing company, that awareness leads to developing the capability to meet that requirements. And there's a long way to go. There is a lot of bridge to be crossed in terms of establishing raw material sources, component strategy for these sub-assemblies is very critical. And that are the few things that are immediate, which we see is needed to advance in the ecosystem. So I'll keep it in short. Thanks.
Thank you. Kunal?
Yeah. Thank you, everyone. So I think Dr. Singh and my fellow participants like Sushant ji, Manjunath ji, Diganta ji, they have already covered most of the technical points, and I would like to make a different point. My name is Kunal. I am from Sumitomo Chemical Group. We are a Japan-based company having operations in several countries in the world. We also have a separate sector for semiconductor-related chemicals, and we are looking at India. So I think whatever we have learned and understood in last few weeks and months is in India, this is going to develop, and from government side, lot of support is being provided, lot of things are being done. From the customer's point of view, people are making investments, technologies. So for whatever is required to make this successful is being done already. And it is a matter of time when it will be completed. But one important point, as Dr. Singh asked about, that what is a kind of a risk factor or kind of a disruption, what is possible. I think it is about the mindset, because see, from the government side, they have everything. From investor side, a lot of things are being done. From customer side, everything is being done. But now it is about the implementation of the entire ecosystem partners. And when we interacted and researched the market a little bit more, we understand that most of the ecosystem things, especially if we talk about chemicals and gases, is available in India. But it is available at a different grade. And all we need to do is over next few years, we have to upgrade that levels from the current levels to the semiconductor requirement grade. And that is going to be challenging, that is going to be difficult, but it is the responsibility of the people involved in the ecosystem to take it to that level in terms of technology, in terms of the SOPs, in terms of the processes, investments. Things will come on the ground, but it is the people who are working on these projects or these chemicals or these gases to implement it day in out, 24 hours, 365 days with the same seriousness, with the same sincerity is what is going to drive it. Because in other sectors, some scope of errors is possible, but when we talk about semiconductor, this is one of the highest technology in the world, and this requires a very, very sincere efforts from all the people involved in the implementation of these projects. So very, very important point from our point of view, what we have learned and what we are looking to develop in India is a pool of people who are of course talented, who get right technical skill, but at the same time that sincerity that they get involved in this project with full sincerity, like a national objective to make it successful. And that is something which is going to be very, very important in next 3 to 5 years. How many people we can get into this who follow the same SOP, same processes, same things with full 100% sincerity is what is going to be the very important challenge.
Thank you, Kunal. I'll start with you again. If you see the Indian chemical industry, it is 6th largest in the world, 3rd largest in Asia, with nearly 80,000 products in almost all sectors. So, do you see in future India, what is India's potential? Can it act as a base for semiconductor grade material, semiconductor grade chemicals and advanced materials? Do you see that potential exists here?
Sure. Thank you. So, sir, how we are looking at it globally, our experience over last 30, 40 years is that many of these products, especially what we manufacture, they needs to be very, very close to the end customers. So the way we are starting to look at it is that whatever is being done globally, what all can be localized in India? Going to be the start. 3 to 5 years, how many more things we can do? So maybe to start with, we will start with say few things, and over the next 5 to 10 years, we believe a lot of things can be localized in India. we don't see that as such a big challenge in terms of technical capabilities or anything like this. But our current understanding is it has to be first for the Indian requirement, because many of these things are required to be close to the customer, close to the market, especially at least the products and the technologies which we are into, and the transportations become very, very difficult. And as the localization take place, I think the domestic industry will also evolve. So in the future, the final products like the semiconductors and the chips can be exported, but as far as the ecosystem is concerned, that has to be localized. And that is the same experience we have in Korea, in Japan, in USA, that the entire ecosystem is more localized. And that is the good point, because when the semiconductor industry is getting developed, the option of getting everything from outside India doesn't exist. There is no choice, but we have to develop these industries in India. And the good point is many of these industries, as I mentioned earlier, already exist in India, but at different grades and different purity levels. So you have to just upgrade the skill sets to meet the requirements of semiconductor grade with the support of the technology from the global partners. But we don't see that as a big challenge. But yes, a lot of work needs to be done in that. And to start with, first 5 to 10 years for domestic requirements, and then gradually maybe for the global requirement for chemicals and parts.
I like Diganta also to substantiate on this, because lot of specialty gases, if you see apart from bulk gases, lot of specialty gases are needed. Of course, as Kunal has said, the same is the purity level he is asking, the same is valid here. But if you see at the specialty gases, typically the number is large and variety is large. They are hazardous, pyrophoric, as you said. So what is you say that what INOX can do in enabling the ecosystem for specialty gases in India for all the upcoming facilities?
Right, thanks for the question. So as I already mentioned, we have been manufacturing nitrous oxide for 50 years now in India, and we have just upgraded to the SEMICON level of standards, purities, earlier this year. So we are in the journey already. Our next projects are ammonia and other gases that we are doing at the same levels. So this requires capital, this requires technology, this requires SOPs of operations and safety, and also a lot of assets to deliver on time, and also in terms of make sure that there's no safety incidents, etc. that is happening. Going forward now, if you look at the rest of the gases, obviously not everything is at a very high level of critical mass that is still required in India. So out of the long list of gases, maybe a couple of more them, or 5 or 6 more could be made in India now, immediately, to serve the local market. And at the same time, since it is meeting the global standard for semiconductor industry, it can also be sent out of India to the other fabs, which is in the vicinity of Asia and other places. So we see that as happening very quickly now from a gases perspective. The set of other gases which are low in volume and low in users times, but equally important and critical. So these would still need to be, at least for the short term, need to be sourced from our other facilities. As I said, we are joint venture with Air Products, and Air Products have facilities in nearby countries for many of these gases. So that will continue to be sourced from there. And then once we see the critical mass, we will obviously indigenize the manufacturing here. And obviously, bringing the gases into India itself is not enough. You need to store them properly. You need to be ready on time for on-time deliveries. You need to make sure there are no interruptions in the supply chain. And as I already mentioned, to do this, we are building a world-class facility in Dholera to serve the semiconductor market. And we see investments into that business going even higher in the coming years with other plants and other products. So this is where we see the journey as the capital has been committed, the plans have been approved, and it is the time to execute.
Thank you, Diganta. When you see at a fab, we have heard from our earlier viewer that Tata Fab is there now. These fabs are capital intensive. That is one reason why very few fabs are here in the country. Out of that capex, when I see out of that capital amount, when I see, more than 2/3 of that amount goes to equipment. The equipments which produce those chips. But as I said earlier, all the equipments we are importing. So seeing in the context that probably there is a great push for bringing more and more facility, I would like to turn to Sushant for saying that what approach we should adopt with regard to equipment. I'll briefly say how we can evolve. See, right now we are like designing, as you know, maybe for the knowledge of the audience, Lam is having a very good base in India, and they are designing most of the equipment parts here. So how we can evolve from that design and software stage to maybe coming to manufacturing, let's say, of initially of parts, then probably sub-assemblies. And see, one critical thing, it is not that once the equipments are there, it is not that equipment maintenance and at regular intervals, because most of the fab people who are sitting there, they require refurbishing. So even, or maybe cleaning of those parts, some parts. So even for some small cleaning, those parts go outside. In the current scenario, they go outside the country again, and then, so it is time consuming, it is costly. So what you probably think that we should, which way we should approach to reduce these timelines, again to expedite the development of semiconductor ecosystem, which probably we are discussing.
Yeah, thank you for the question. I think you brought up a good point. You know, in India, we've been fairly matured, I would say, over past several decades in the design and engineering areas. When it comes to manufacturing of these equipment, we are still far away from building the equipment in India. But what we can definitely achieve is creating a subset of that ecosystem in India to cater to the needs of the fabrication equipment, which forms a large part of the cost for the fabrication industry. Within India, we see, I mean, we have taken up this initiative to develop an ecosystem in India for a couple years now, where we strongly believe that India already has a established foundation through adjacent industries such as aerospace, defense, healthcare, and a very matured automotive manufacturing capabilities. I think it serves as a very good starting point, and especially aerospace. And that's where we believe that we can very much leverage that ecosystem to get a head start in the semiconductor wafer fab equipment. To specifically answer your question, you talked about cleaning as an example, right? Even in this development of the ecosystem, our parts that we develop go in a clean room. Our equipments in Lam Research are built in a clean room, and we have to package each and every critical part with precision cleaning and package it to directly come into the clean room where we open it and it goes into the equipment. Any deviation can lead to contamination. So that's the severity of consequences that we deal with. Coming to capability, what we have experienced, though we have a very good supply chain manufacturing capability for aerospace, which is still growing, and it's still very different. When we have engaged with our companies, I think it has taken us a steep learning to really understand that, yes, it is similar, but not the same. There are many semi-standard requirements, specifications, standards, which have to be well understood by our suppliers. That's the most important thing to understand, and that's where one of the advantage that we also believe India is a very good place for developing this ecosystem is the availability of vast talent. Every part that needs to be developed has to be going through an engineer who has to understand the requirements in all the commodities that we are engaging. And that's where our companies in India have an advantage in, not just advantage, even as a differentiator. And that is why we are investing in, empaneling more suppliers in India. So in short, I would say there aren't, I cannot just list one, there are plenty of areas for us to overcome. You talked about cleaning. Even the cleaning, we have to have a very ultra high pure requirements to clean our parts. We cannot, for some of the components our military specs, mil specs that we call is sufficient, but for many of those we need more advanced methods of cleaning. We do special process treatment of the parts that get into it, which we currently still take it out of India, get it back. So we are already developing those capabilities in India. And very soon, that will cut down the lead times. It will help the overall ecosystem. And we are fostering a very open ecosystem for the country.
Yeah. Thank you, sir. As far as I understand, Mr. Manjunath, UHP is also, he has told the importance of suppliers. So you are also one of the suppliers to them. So what priority areas you see? He has pointed certain things for localizing supply chain components in India, and particularly what role you see for our SMEs for participating in this ecosystem.
So I was just looking at the panelists here. So we are the common link for chemicals, equipments, and the gases. So that's how we come into this ecosystem. So if we have to deliver all these chemicals, gases, and make sure the equipments are performing well, our engineering capability to transfer gases, chemicals to the tool is absolutely at the global parlance, right? There's no scope for any error. And if we have to make this local, it's not going to be a case of, though we are common thread here, but it's not possible for us to do everything. So what we have initiated is, there are a lot of pockets of engineering excellence among the SME players in the country. We talk about Pune in Bangalore, Hyderabad, Pune, Coimbatore, Rajkot, Faridabad. All these places have got a lot of passionate entrepreneurs who are very good in engineering, but they don't able to connect the dots with what's happening in the semiconductor industry. So we have taken a small pilot project of how to work with such passionate SMEs, and we kind of onboarded two such companies in Bangalore, where they work with us as not as vendors to us. They work with along with us when we talk to people like Lam, people like Applied, people like Tel, any of these companies, global companies. So there is very little lag between what we understand, what we communicate to our vendor partners. So that's what we did one step. And second step is, all these SMEs don't have the best of the equipments for them to meet criteria that has been laid out in the specs of the equipment building. Let's say they finish the surface coating levels, the GDT tolerances, all is not easy with a run-of-the-mill kind of equipments. So we are now initiating a new venture of setting up such equipments in our facility, where our vendor partners would come and use those machining capabilities to deliver some of these engineering components to meet the SEMI S2 standards. So this case, or this pilot we are running, is not limited to just two today. And we are actually, yesterday we spoke to, we gave a briefing to the media, and wherein we said we are earmarking a fund to support such SMEs in the country, and our aim is to at least tap 20 such, 200 such SMEs across these 5 to 6 global, what do you call, excellence centers in the country. If we can get those 200 such passionate small entrepreneurs into this ecosystem, then we are in the game of $5 billion opportunity. So $5 billion opportunity of the component industry. Hello? Yeah. So these 200 small entrepreneurs can become leading players for component industry, which is as big as $5 billion globally. So I think taking this cue, I would really urge many such large companies to see how we can engage with the small entrepreneurs across the 5 or 6 excellence centers in the country, and they can come into mainstream.
Thank you, Manjunath. Though I had a set of questions, I wanted few more questions from you, but seeing the time paucity, it is only 4 minutes left. So probably I'll again come up with a common question to all of you, which is something similar which you have spoken already. I'll again ask, what are the key capabilities probably which we should develop? Okay, we should develop, but we should develop those key capabilities so that we are meeting the global benchmarks, but at the same time, we are competitive. Because nobody, this is firm belief, nobody will let you in unless you meet these 2 requirements. So what do you think that we should try to develop in all your fields that we meet both of these requirements?
Just take this one point which I forgot to add, very specific to your question that you said. It is not a game of just 1 or 2 companies in this ecosystem. So, and that calls for a very different approach. How do we connect the dots between what is happening at the macro level to the ground level with the small entrepreneurs who, if you go to any of these ecosystems outside India, I think, like for example, Malaysia ecosystem has about 500 plus small entrepreneurs supporting the semiconductor ecosystem. So given that kind of a requirement for a small country like Malaysia, we have a huge opportunity, and I see a very big responsibility which through ISM and local industrial bodies can get the small entrepreneurs into this ecosystem through education. We are not educating only the engineers or physicists or chemists from the colleges. We also have to educate these entrepreneurs from a quality standpoint of from the semi requirements. And I think that will really speeden the whole process of getting the talent into the industry.
I just add a couple of points to Dr. Singh's question. The first is, of course, the collaboration that we need, which is there in many other industries that we see in this country. We see great collaboration in electronics, we see in automotive, we see in other industry segments between the government, the suppliers, the consumers, and so on. We need to build the same level of collaborative approach and very long-term partnerships with the fabs. So if I give examples of countries like Taiwan or US, there are decades-long partnerships in place, which is really working with one goal of seamless support and uninterrupted production of the highest quality of chips. And that we see the development of the, from 110 nanometer down to 2 nanometer today. That is happening with the support of all this. So to accelerate that, we have to learn from it. I was recently in Taiwan and I learned that the government is really proactive in supporting. So this is something we must do. We must get the ecosystem as well, because the government has a large fund to support the fabs, maybe a similar system for the ecosystem suppliers, both on the capital side as well as the operating expenses side. If I give examples of our industry, we have large dependency on power. So does the semiconductor fabs. Semiconductor fabs get subsidized power. We don't get it yet. So that is one example which I want to bring it. So similarly, the couple of quick and very critical issues, if we can address now and sort it out, it will be great.
Sure.
Yeah, I talked about the advantage that our ecosystem has, but at the same time, in the equipment industry, our suppliers, global suppliers, have been working with the equipment companies for several decades. They have spent and learned through several decades of experiential learning. They have invested, they've taken the risk, they've got the rewards. That's, in a way, it serves as a challenge to Indian ecosystem that they have to start competing with the matured ecosystem from day one. So we don't have decades to wait for us to be competitive. We have few months. So we have to be very agile, adopt speed in learning, and build, productive partnerships through the supply chain, benchmark, understand how this value chain is. Can we vertically integrate a lot of components to be able to to compete and be competitive with the global companies. So that puts a lot of emphasis on capability development, and also keeping in mind, this industry is also very cyclic in nature. Right? It's a capital investment is very cyclic. So it's also very important for the companies to utilize any kind of support that is there from the government to use it, and I'm sure the ISM and the government is working on that, but it's very important to use that and build that flexibility to bear the low cycles in this industry. So.
Thank you, Shashank. Kunal, quickly,
Sure,
our time is up.
Yeah.
So
from our side, what I would like to mention is that when we talk about semiconductor grade chemicals, the purity requirements are extremely high. Like, for example, some of the metal contents required are in single digit ppts, not even ppbs. So for meeting those, like companies like us who are the global experience player, we will certainly come in. It's a matter of time. But at the same time, the entire wide ecosystem needs to be developed. Just for example, water. So the water which is being used by the chemical industries today in India versus what is required for semiconductor related chemicals is very different. And in last few days, we have had a lot of experiences and meeting with the things. So it is not something that everything you need only semiconductor grade. Whatever you are doing related to chemicals, gases in the ecosystem, just start thinking about how you can improve it. So if you are making a high purity, how you can go to the ultra purity water, ultra purity anything. So anything which is required in the chemical, more or less things are similar. But how we can go to the more and more purity, more accuracy is what I think is required, and it is not going to be a matter of few companies or only the global companies. As I think we very clearly mentioned, it is going to be the partnerships across the value chain, across a very wide network of entire ecosystem, which needs to be step up. And that is how it will be developed, and that is how it has been done globally. It is not everything was there on day one. So over a period of time, all of the wide ecosystem partners needs to upgrade their skills and their delivery patterns.
Thank you, Kunal, and thank you all panelists. Before I wrap up, maybe we can take one or at the most two questions. Yeah. Please go ahead, ma'am.
Hello. So it has been a very insightful discussion over the past 2 days. My query specifically is with regard to what are your plans in ISM for the telecom sector with respect to, instead of going for the entire fabrication and everything, we do have a good ecosystem, as I can see. So any immediate solutions, or we can have a list of certain SOCs or certain chipsets which are probably already available within India, which we can start replacing with, for import replacement. So do we have any sort of such list? We can probably come out with a white paper. It's a kind of a suggestion, and I would like your inputs on that. And another query is with regard to the IPRs. As everybody is aware that mostly the IPRs are in the design area of the fabrication. And although India has a lot of engineers in the design sector, but maximum IPs do not belong to India, they are outside India, and that leads to a lot of revenue loss or in that sense. So what are your plans to ensure that we have more IP generation within the country, any sort of patent funds or any incentivization? And with respect to the telecom, if you can come out with a list of, for example, we had a talk where we were told that, for example, in Maruti, you approach Maruti, and there is some component which is already in use, which can be replaced with something which is indigenously made. So something like that, a list, where we can start collaborating immediately for the telecom sector.
Thank you for the questions. Ma'am, I'll take your second question first. As far as the IP generation is concerned, IPs belonging, that was the main concern. And if you see the DLI scheme, which is Design Link Incentive Scheme, that was launched with this purpose. Initially, like the scheme which is currently running also, it was for startups, and see it has, like you have seen, it has percolated to a very wide base. Now you will see the new scheme coming. It will be enhanced many folds to take care of the concern which you have put. The concern, right? Most of the design, if you see the advanced designs, even we are talking of nanometer fabrication, very advanced chips, all advanced chips, most of the advanced, I will not say all, the designs are being done in this country. 20% the global design force you may have seen in earlier presentation is here in India. But unfortunately, your point, what you have pointed is that the IP is built to us. So that is the reason why this DLI scheme is there. Now I take your first point, you have said that is a right, maybe in some way it is a right approach, that we start, you have said particularly from one sector. You are concerned with one sector. But this country and its needs are huge. They don't belong to one sector. Say, my task is strategic, space, and defense. So people will start saying, no, take care of these chips. So basically, when a technology is decided, technology node is decided, that takes care of most of these requirements. Even the earlier decisions, like we have not moved to 2 nanometer straight, as most of the speakers earlier have also said, why the technology nodes which Tata has chosen for the first fab which is coming up, there was some of these consideration, what are our current needs, okay? So technology nodes have been chosen accordingly, seeing not one sector, but a huge consumer base which exists here. People in the earlier discussion also have talked about demand, which probably, what is the demand, but so they were talking of many other sectors. So always when we decide on certain technology, so this is again, it is not a static, this is a dynamic exercise, this will be continuing as the demand in certain areas increase, the technologies will be chosen accordingly. So maybe I think we are already quite up. Our time was up about five minutes back. So from this discussion what you have taken, the one very key point is that if we want to develop the semiconductor ecosystem in the country, we must localize suppliers. We can get the technologies transfer, but the technology transfer again has to go back to level of tier 2, tier 3, level of suppliers, like you have said for Maruti. So Maruti is a great example. When we started, and now even a smallest component of Maruti is available from the local suppliers. If we want to, this is also a very huge industry. If we want to really develop this in the country, we must encourage our local supply. Thank you very much. I thank you all the panelists for their time. Thank you.
Well, ladies and gentlemen, it's been a great time here the last 3 days, and we have now come to the grand finale. And as we all know, in any event, the grand finale is probably the most important things, because whatever the deliberations have taken place during the last 3 days, the summary of that, and at the same time, the way forward. When we started off, it was yesterday. We discussed about the present, but in the finale, we are going to discuss what is tomorrow. So yesterday, today, tomorrow is the crux of everyone's life, and so we are going to do just that. So I would request all of you to kindly be in your seats, because this is a very important takeaway of this particular conference. First of all, it's my pleasure to call upon Shri Amitesh Sinha, Additional Secretary MITI and CEO, to please come over onto the stage. Put your hands together for Shri Amitesh Kumar Sinha, the CEO of the Indian Semiconductor Mission. In his current role, he is responsible for driving the nation's semiconductor strategy and advancing research and development in critical technology areas. His career reflects a unique blend of administrative acumen, sectoral expertise, and commitment to advancing India's technological and, of course, infrastructure landscape. More importantly, ladies and gentlemen, you would have all realized by now that his leadership at MITI is central to strengthening India's position as a global hub for electronics manufacturing. And prior to this, he has served in various capacities in different areas, and extensive experience also in the Indian Railways. So ladies and gentlemen, put your hands together. But more importantly, above all, it's my personal comment that he is a great human being. So that's what towers everything about the personality. So that's what makes you remember forever and ever. A great human being, sir. Welcome to you. After that, I would like to call upon Mr. Ajit Manocha, the President and CEO of SEMI, the Global Industry Association for the Semiconductor and Electronics Design. A strong advocate of industry collaboration, he has steered SEMI to address critical challenges, including geopolitical concerns, sustainability, supply chain disruptions. Well, he is recognized as one of the semiconductor industry's superstars. So put your hands together for all stars. Manocha, he continues to shape the global electronics industry with his visionary leadership. As he's getting ready with the mic, it's my pleasure now to also call upon Mr. Ashok Chandok, the President of SEMI India and ISA, who in fact moderated. I had given a brief introduction about him. Well, moves around like Mercury. So put your hands together for Mr. Ashok. And all three gentlemen will now tell us where we stand, where we are going to be tomorrow. And it's all important for all of us to listen to the words of wisdom. somehow I felt the energy level was just not enough. Please put your hands together, ladies and gentlemen. They have strived hard right through their entire team to bring this successful SEMICON India 2025. It's now straight away over to Shri Amitesh Sinha sir to take us through this session.
Time is up.
Good evening, friends. I want to hear good evening.
Good evening. Nobody can be tired.
Hi, good evening, everyone. I hope my voice is audible in the exhibition hall. I cannot get the feedback from there. I am assuming the exhibition hall knows what's happening into this Brahma Kamal hall. So friends, as we come close to this 3 days of SEMICON India event as a closing ceremony, we all together stand at the defining moment of India's semiconductor journey, building the next semiconductor powerhouse. Over the last 3 days, we have not only seen the cutting-edge technology, product solutions, demonstrations in exhibition hall, more than 350 exhibitors, but also we have got the word of wisdom and experience from a lot of global speakers, more than 150 speakers in multiple sessions. And we'll take you through the last phase of 15 minutes now of the closing ceremony. But before that, we want to also exchange some more MOUs. We did on the 2nd of September, and some of them were still pending actually. So we have completed about 11. And to do the rest of the MOU exchange, I would request Mr. Nishit to come on the dais and tell everybody what are the additional MOUs, and also we invite those dignitaries to the dais for the exchange of those topics. Thank you.
Hello, good evening everyone. This is Nishit from Ministry of Electronics and IT. So in the interest of time, we are not inviting the dignitaries. So there are a list of 7 more interesting announcements during this closing ceremony of the SEMICON India. So the first announcement is about reopening of the application window for ED tool access under the Designing Incentive Scheme. So we were receiving requests from many startups to reopen this ED tool access, and the application window was closed for some time. So some of you might be aware of that about 72 startups are currently accessing this ED tool under the DRI scheme. And this Chip-in Center, which is established at CDAC Bangalore, has powered about 14+ million hours of ED tool usage across 350 organizations, including 280 academic institutions.
So dear
so
friends,
now,
what Nishit is trying to say that there was a popular demand that access to EDA tool window should not be closed. So today we are happy to announce that the EDA tools window for startups is still open and anybody can apply for that.
So the startups and academic institutions across the country can go to the respective web portals of the DLI scheme as well as the CTOS program, and they can submit the application. So the second announcement is regarding the announcement of 30 semi-finalists under the Digital India RISC-V Grand Challenge. We announced this challenge in the March 2025, and from over 1,200 participating teams, 30 semi-finalists were selected in the Digital India RISC-V Grand Challenge, launched under the Chips to Startup program by the Honorable Minister, Ashwini Vaishnav sir, in March 2025. And these student teams will now receive the Shakti processor and Vega processor kits ported on the FPGA boards, and also the seed funding to develop the prototype applications around these microprocessors. So these are the indigenous processors around which they will be developing now the prototype applications. So, I mean, the list of 30 semi-finalists has been uploaded on the CTOS web portal. So, yeah. The third announcement is regarding the Global Foundry, which is a leading fab, is announcing support to the companies approved under the Design Link Incentive Scheme through their India Foundry Connect program, providing access to the GF's process design kits, PDKs, multi-project wafer support, MPW fabrication support, IP access and engineering support to help the startups accelerate the process from design to manufacturing. The fourth announcement is regarding the Chip-in Center is today collaborating with the OCHIP program of the state government of Odisha. So, as we already, so Chip-in Center at CDAC Bangalore, the Designing Incentive Scheme and Chips to Startup program is collaborating with the Odisha Semiconductor Fab and Fabless Innovation and Acceleration Program, OCHIP, to catalyze the fabless chip design ecosystem in the state of Odisha by way of enabling the state-of-the-art chip design infrastructure, including EDA tools, among the student and startup companies in the state of Odisha. The fifth announcement is regarding unveiling of the roadmap of the chip by the MOSCHIP. So MOSCHIP Technologies today unveiling the roadmap for the Vidyut chip for the smart energy meter, which is fully indigenous smart energy meter chip, and they have already successfully validated some key IPs, including the power management unit, temperature sensors, clock management unit, and the LCD panel controller on a 180 nanometer foundry, which is SCL Mohali. The mouse chip is now planning to make the Vidyut chip completely indigenously, including its fabrication, supporting India's push for the self-reliance in the semiconductor chip designed by the 2026. So another similar announcement is regarding indigenization of the roadmap for the CCTV surveillance camera. So Netra Semi, which is the DLI approved company, is today collaborating with Parama India, which is a leading video surveillance solution provider. Today they will work together to work for integrating the indigenous system on chip by Netra Semi into the CCTV and surveillance devices. So basically this collaboration marks a major step towards reinforcing a secure homegrown supply chain and advancing self-reliance in the surveillance technology across the country. And last but not least, CDAC is also making various collaborations towards expanding their potential and capabilities in the cryogenic chip design. So CDAC has signed an MOU with the US-based Rigetti Computing for co-development and fabrication access and letter of intents for cooperation with Quantumware Netherlands and Control OX Finland for supercomputing chip design and fabrication facilities, software collaborations, and access to TU Delft's advanced fabrication facility. So these global partnerships will accelerate India's capability in cryogenic chip design and position the nation in the front foot of hybrid quantum computing. So these are the list of announcements, and all the respective details will be available on the respective portals of the DRI scheme and features program. So thank you very much.
Thank you, Nishit. So friends, it has been really spectacular. Several MOUs, the announcements, thousands of networking meetings, business-to-business discussions. Many things happened over the last 3 days. The previous session which I conducted, there was a poll here and everybody said I was a good moderator actually. So they asked me with demand that I should question now both these gentlemen on the stage here. So I'm going to proceed with that. And I'm expecting once again all our exhibitors in the exhibition hall are able to listen and hear what's happening into this Brahmagapal hall as a closing ceremony. So my first point here is we always look at the success of the event and try to compare what happened in the last year. So, Sri Amitesh ji, what are the highlights of this year 2025 Semicon India event from your perspective?
So dear friends, first of all I will start this session with thanking Mr. Ajit Manocha, who is the advisor to India Semiconductor Mission also and President SEMI also. So with the help of Sri Ajit Manocha, ISM and SEMI together, they have organized this function, this second edition of joint collaboration. And from last year, there was some unique features. First of all, there were 4 country pavilions in the exhibition area. So that was a new thing. In parallel sessions, we had 6 country roundtables. That was very, very fruitful. And the companies from both the side attended that, and we are expecting a lot of collaboration and technology transfer talks going further. We also saw a workforce development pavilion where students were mentored by our experts. There were some training sessions across fabrication and packaging and all those things. And they were guided about the future scope in electronics and other verticals of their studies, including chemicals, mechanical, robotics, and all those things. So these were the unique features. And then we saw a good amount of footfall. So 30,000 footfalls we have witnessed in last 3 days. The
Talia.
I'm happy to also announce that participants from 48 countries and regions participated in this SEMICON India program, and more than 350 companies showcased their technology innovations in the exhibition hall. So I am thankful to all those companies, international delegates, international visitors who are here, who has taken pain to come to SEMICON India 2025. And from ISM side, from my side, we thank all of those participants. I also thank many Indian participants, Indian companies, global leaders, CXOs who were part of this function. We saw a great participation and a very, very firm commitment from government side led by Honorable Prime Minister of India. He actually came to this SEMICON India 2025 twice. On day 1 he inaugurated, on day 2 he came to see exhibition, he interacted with the exhibitors, and also he chaired a round table in which the global CEOs and CXOs, he wanted to understand the global perspective and their suggestions if they have any for the further betterment of the SEMICON India program. So this kind of commitment, participation and all degree of enthusiasm we have witnessed. So I am very thankful to all of you who have come here in a great number. Thank you.
If I may add to that.
Yeah, please.
I mean, I go to SEMICONs all over the world. SEMI holds SEMICONs in 7 other countries. India is the 8th country we added last year. And the leaders from those countries and different countries come to SEMICONs. But what happened this time, Modi ji spent more than 7 hours in 2 days. That is unprecedented. What that means is that he is committed to the ambition or the vision to making this country a semiconductor nation or the powerhouse. And that's important for India, not only for India, but for the entire world. And he is looking at that way, not just for India, but for the entire world. And that amount of time he committed is unprecedented and exceptional.
Thank you. Indeed, there has been a great progress which has been made during this SEMICON India 25 compared to previous year, and we will continue to march further surely. And Amitesh ji very well articulated and narrated some of the key topics which we achieved. That brings me to the next point, and Ajit, as you mentioned, SEMICON events are done in almost 8 countries now. How do you compare the SEMICON India event to the rest of the world?
I would say uncomparable. What I mean by that. Thank you. Before coming to SEMICON, I had my staff provided me all the data of the SEMICONs, first SEMICON and the current SEMICON in all these 7 countries. And I was totally surprised when I saw the data. It took US, the SEMICON West, 14 years or 13 years to get to the size of this SEMICON happened in India this year. It took 12 to 13 years for China, SEMICON China, to get to where we got in 2 years. This is unprecedented. And I don't know if you remember, I cheated with Amitesh ji. Despite his view that no slides, I had 1 slide on the screen. It showed the ramp of the mature SEMICONs from the time t equal to 0 to 13 years, then SEMICON India from t equal to 0 to 2 years, vertical line. That was the exponential growth of Modi's law. And basically, SEMICON India in 2 years has come to the level of maturity of any other SEMICONs in the world. For example, SEMICON Southeast Asia, for 30 years, same level as Semicon India. Semicon West, which is US, is almost same level as India. Semicon Europa for 50 years, is the 50th anniversary this year, is same level as Semicon India. Yes, there are leaders. Semicon China is the largest show on the planet. And then the 2 or 3 other large shows are second, third categories: Semicon Japan, Semicon South Korea, Semicon Southeast Asia, Semicon Taiwan. The question for all of us is, okay, it took them, these other semicons which are pretty big now, it took them 30 to 40 years to get there. Will it take same number of years for India to get to the same level? I think the answer, you should know it yourself. If the slope is like this, it should happen in 5 to 7 years. But just with one caution, it will not happen if you become complacent. We, the entire world, the industries, the companies who came here, they need to feel inspired to come back to help with the ecosystem. We need to continue to have the policies which are very business friendly. We need to have the vision of the government and execution by the companies that were started. That will actually help us to get to the trajectory of becoming the top Semicon event in this country.
Thank you, great indeed. Amitesh ji, last few days, several global leaders were at the event, including the Indian leaders, participants, and you were a most sought after man actually. You have interacted with almost many people, not a single minute of vacant time for you. What is the feedback you get? Is there any being said about the policy? Because, you know, when I go to the industry, people keep telling me government should do this, government should do that, government should do that. Well, I keep saying it is not only government, industry has their role to play. So there is something only which government will do, we have to do more. But what's your view? Do you see any gap, any feedback to you, and are you going to address those?
Actually, first of all the global leaders who came and participated in SEMICON 2025, they showed their firm commitment about the prospects of India's semiconductor mission and their commitment as part of the company. They also highlighted some of the areas which we all have noted. During the roundtables also, they pointed out certain improvements which we have taken note of, and we will try to work on that. If you ask me about the policy gaps and how we are seeing this total landscape, the journey of electronics manufacturing started with the play of EMS, assembly. And this journey is continuing for last 10 years. We started with the assembly, semi, SKD, CKD, and now we are following the journey of electronic components manufacturing, which we were trying to push through other schemes of METI. Now there is a dedicated scheme, electronic component manufacturing scheme. So what we are doing, we are trying to increase the value addition. The next stage of value addition will come from semiconductors. So we are led a program for designing, fabrication and packaging of semiconductors. The value addition which will come, which we'll see, will be around from 15% to 35%, depending upon the complexity of the electronic device. If it is electric vehicle, the percentage will be more, and more will come in future. Then the last piece of the puzzle is R&D and product development. So whenever a semiconductor design chips is trying to find a place in a particular device, it has to cross the hurdle of passing the board or module, and that is not in command of Indian manufacturers. So the next problem to be addressed is how to incentivize and cover the gap to find a chip on the board and module, so that ultimately it is part of the overall product of electronic manufacturing. So we have to work on product development. We have to fill the gap of finding chips, placing chips, Indian chips, made in India, designed in India chips on the board of different products. That gap we will try to fill up. In R&D, we will try to do some more research in technologies, whether it is fab or advanced packaging.
Yeah.
In design sector also, we have a startup ecosystem, but we will see that how the strength of Indian companies can be leveraged towards that. So I think these are the gaps we will try to address in the next SEMICON.
Great. Thank you, sir. And it's indeed heartening to know that the government is listening, taking the feedback, and also very much willing to work on those. And I keep saying, industry people, we do our work also, actually, don't ask everything. With that, my next point is to Ajit. Ajit, how is the outlook for SEMICON 26, and what is your message to the exhibitors? They are not in the hall, but they are listening your voice probably. So you could indicate what is your message for exhibitors, and what is the outlook for SEMICON 26?
First of all, I want to thank all the exhibitors, and let's give a big hand to them. And I want to thank you all for participating, and the attendees who are not here right now. I mean, we had like 30,000 registration or people showed up for various programs. I want to thank the government. The role of government was very important in making this SEMICON happen. So I think for 26, Ashok, my team has already started work, and you actually gave me some of the inputs already. We're looking at what are the lessons learned from this SEMICON. We want to make sure that we don't make the same mistakes again, so that we can make it much more meaningful for everybody. Exhibitors who spend a lot of time, energy, investment to come to this country, as we said, participation from 48 countries and 350 companies, 1,300 booths. We ran out of space. I think we underestimated the space we need. Next year, SEMICON Edition 3 will be on September 16, 17, and 18, 2026. And we have already started asking exhibitors about their interest level for that SEMICON number 3, global SEMICON number 3. And we will not have any reason to say that we don't have space. So we will make sure there's enough space. But again, the most important thing will be, can we remain on that trajectory that we already started? And I think we'll make sure that that happens. And the other important aspect is, can we really have this ecosystem get on autopilot? That will help the country to become self-sufficient in making a semiconductor nation. So that's really the big difference. And the last but not the least, as Amitesh ji mentioned, there was a big focus on workforce development. Next year, we'll take it to a newer heights. I'll give you one example. Sorry, I know we're running out of time. In US, we launched a major program for workforce development based on the collection of 250 universities and community colleges called American Semiconductor Academy, which brings the semiconductor curricula in partnership with SEMI, bringing industry context. That program provides the focus on elementary schools to the high schools, to the university levels, to reskilling at all levels, soup to nut. That program is a nationalistic program for the US. US government has awarded big sum of money to, again, develop the skill set apprentice programs for US. We are trying to launch same thing in India called ISA, India Semiconductor Academy. I want to remind everybody, that does not mean the programs which are running here, they will have to stop. No, every program will continue. They are important. Then over that, there will be an umbrella of a nationalistic program for speeding up the talent development in the country. So wait for that. That will be another feature of 2026.
Thank you. So that's a...
So friends, I just want to end from Honorable Prime Minister's vision. He said that we are not here for short term, we are here for long term. And this is the commitment of government, and this commitment is way beyond the ISM 1.0. So we will try to develop the complete ecosystem as Ajit Manuchar sir has said, and complete ecosystem considers policies for everything from design, fabrication, packaging, equipment manufacturing, chemical, gases, material development. These are the things, these are the ingredients of complete ecosystem. So we will try to find out the policy measures that is required and try to address all these things together in ISM 2.0. Thank you.
Thanks. Also, Honorable Prime Minister said very clearly, we are late, but we will go fast. So our journey continues on a fast track basis. And I once again want to thank you, the exhibitors. Those are in exhibition hall for their time, traveling all the way worldwide as well as from India and exhibiting those cutting edge products and solutions, which really has been very helpful, and that also helped us to increase the footfall in the event. I was given a list that I need to do a thank you to all the entities and the teams, those who have really contributed directly and indirectly for the success of this event. Total list is 51. So I cannot read everything now, but I can only say that on behalf of organizer, that is ISM and METI, as well as SEMI, big thank you to all of you, all the people, all the participants, exhibitors, distinguished guests, government dignitaries, various entities, event management agencies, service, volunteers. Keep going, everybody. Thank you very much for the great event. And
my team in SEMI and ISA, they did a great job. I'm proud of you. Thank you.
Yeah, it's a ISM team, SEMI team. Yeah.
All our facility providers, Thomas Cook, Active.
Everybody.
All the team members. Thank you.
Thank you very much. And I won't say see you next year because we keep meeting actually every day. So SEMICON is next year, but we'll keep meeting. Thank you very much. Signing off, triple A's. Amitesh ji A, Ajit A, and Ashok A. Thank you.
That was a good one, triple A.